most successfully, it's like AI implementation is like based on the deep learning that is rarely used in space industry today, but it's in the future. It is like it is mostly it will be implemented in future. It's like AI is particularly is like machine learning, which is paving the way that's before to go extensive space applications. That implementation of new technologies, something like investigating of satellite operations, in particularly you can able to see the support, and you can imagine like how AI has been taken a very wonderful role here from 2017 to 2020. So the potential applications that will be investigation of the satellite operations, as I said, there will be like large satellite constellations and also relative position systems and also the communications, end of the life management some of the satellites. By the end of the satellite, your satellite has been done some work for 3 years operational. After that, it automatically it will come back. Fall back and it will be burst in the environment, something like these are all kind of environmental sustainabilities. So here, how artificial intelligence for space application and spacecraft operations, this means either the robot or the satellite. But the concept is something like we have to the operator makes the decision from the ground station, and the ground segment will be will do the the pre-planned activities and scheduling and something we need to execute. And it is need not to be sit and you always sit in front of the computer to give the commands and necessary inputs actually. In the International Space Station, because they have the ground support from one in Moscow, in Korolev, it is in Russia, and another one will be based in Houston, in USA. So they will both the teams will be constantly monitoring the International Space Station, and they will communicate with them. Some of the necessary data inputs that will be, monitored and also submit to the onboard to the satellites and also to the International Space Station. So this is how. It's like some kind of astrodrone. It's like using your mobile phone. You are flying your drones. That is the future. And also some of the drones are coming autonomous flying. When you map something like you want to inspect your area, or maybe you want to inspect some construction site, you can put the coordinates and it is autonomously fly and come back, something like. So these are all kind of some of the technologies, some of the initiatives, and this is what it's like. Wide applications mostly in a rover, but we have worked as like a 40 million Google Lunar X Prize challenge, and we got the finalist in US. So I heading the team, and we will need to. Our job is like to build a smallest spacecraft, a rover that will be landed on the moon, and it go for the mobility studies and the lunar communication studies. Something that we need to demonstrate actually. So we got in the finalist of 40 million challenge, and unfortunately we are not able. No teams of finalist team cannot be able to land on moon because of some bureaucratical and also geopolitical things. But we guys are still we are working on this mission, and some of the basic activities that I would like to give some inputs in real space applications that mostly like AI and ML in space missions. Like for example, the rovers can navigate around the obstacles that autonomously find the way of the unknown fields, and also the artificial intelligence is an idea of the astronauts, like to onboard the International Space Station. Some of them are intelligent. You can see the small boat. There's like it's like a buddy. Your speaking friend in International Space Station that was developed by IBM, and this is used for intelligent data transmission software that is onboarded, and it is like interact with like you guys have been like interacting with Alexa. Hi Alexa, I need what is the score, or what is the temperature right today, or something like what is the it is today's rain will come, something like you ask some kind of the questions to Alexa. The same like that, it's like a buddy in International Space Station. So that this is called like fully voice controlled Simon. It's like a crew interactive mobile companion. So it wasn't launched in 2019, and also it is like the new. It is replaced with the latest hardware. So mostly NASA is like mostly working with the Google to for extremely to get giving the training for extensive AI algorithms for effectively to shifting through some data of the Kepler missions of the future. So took some of the signals that for from exo, because this is mostly useful for exoplanet research, and this is some, the human scientists, like I mean, like even in the future, it's like the even a robotic scientists that themselves they can make some discovery and observatory, like something like that. So they will just you need to plug through some of the data transmissions and continuing with some kind of machine learning algorithms that can able to quickly identify the clusters of the debris and also the comets that leave that way. For example, for making some kind of the decisions that data analysis that there will be funded by the several government and private initiatives also, but this is the time to work on intelligent systems and space data. Data is the fuel actually. You know the oil, how the 30 40 years, I mean like last 50 years, I mean like oil and gas is the ruled the world like that. So data is the fuel for the future. So this is how we have to work on mostly in intelligent systems, in artificial intelligence and machine learning. Some of the one it is like this one is like 3D printed surfacing on the moon. It's like mostly the additive manufacturing techniques that remotely controlled, and also it is used to automated construction technologies that can build some moon base on the moon. The second one is like a 3D bioprinter. So this one is like the one. It's me actually. The one is bioprinter is you can able to see the one bioprinter in my hands. This is the world's first 3D living organs printed on International Space Station, and recently we have demonstrated one mission. In July 15, you can find that we made a 3D printed chicken nuggets. Okay, in KFC. So this is like you like astronaut food in, this will give like an astronaut food in space. So it is like it is give the it is continue the supply chain. Like you can get the fresh meat or fresh paneer or some fresh items in International Space Station itself. Next is like agriculture technology. It is like a lunar plant factory, because no farmers on the moon. Like like it is everything is like automated process. So this is where the technology right now, and some of the experiments that we are planning for in house using the technology. I mean, like cultivating something in space. So we need the technologies that for agriculture and space station environment, and also we do the evaluation of cultivation of plant like organoleptic properties, and also the exploration of ensuring the psychological support for the crew actually. Next, this like drone, or like this like a platform like Simon is there. But after that, some of the robotic space systems that algorithms testings are autonomous flying and working. These are some of the experiments that we have planned it. And some of the nano sensors with deployed with artificial intelligence. That's like mostly it is micro sensors, and it has in small analytical softwares and also nanomaterials, something like. And this is like exploring the possibilities of a high radioactive background, and also they, I mean, systems itself to make themselves steal from the environment, something like that. So this like microbial fuel cells, and that will convert chemical to electrical energy through the actions of the microorganisms. That is an under testing, but for that and all, you need an AI and DL techniques that to analyze the data, because you have to collecting the different sensory inputs, and you need to identify what exactly you need it. So this one is the one we have launched into International Space Station. This is the astronaut, the cosmonaut in Russia. So I mean, like it isn't deployed. This is the bioprinter. That's in like it has some AI inbuilt in. So it will cultivate the living tissues and some of the glands, and we produce the living organ printing in International Space Station. Before NASA or before any organization, we did in International Space Station. So this is like our systems, like we working on Soyuz spacecraft simulator system that every astronauts or cosmonauts they will train in simulators before they will fly. This is me. I'm operating the the international. Docking. That I'm trying to dock to the International Space Station using the Soyuz spacecraft. So this is the Soyuz spacecraft simulator. This is the one in the right side. You can able to find. This is the one in the real one, real size, and this one is like a simulated one. It's like but actual control systems. It has it is like autonomous dock to the International Space Station. It is planned in. I mean, we worked in AI also, but this I'm doing in manual because what if AI fails? So how we can to get into the International Space Station, something like that.
Excuse me, Dr.
These are some of the
Venkatesan.
experiments. This is the head of the Human Space Flight Program. They are also practicing it, and the Prime Minister of Russia is in the middle. So he was operating. I mean, like just to experiencing like how the astronauts are really going to the space. So next technology demonstration which we are planning in next 2024 with collaboration with Russia, India, France, and Malaysia and US.
Excuse
So
me.
we're looking forward some kind of collecting some data sampling on-site data sampling collection and also processing with AI.
Excuse me, Dr. Venkatesan.
So thank you
Please.
very much for listening. So these are some delegates from Member of Parliaments that visited us in 2 years back. So this is the big hand. The one is like a lunar lander, and the one is this is their hand is like a rover that is going to the moon. So thanks a lot. Thanks for the opportunity, Dr. Professor Kumar, and I'm very happy. And thank you, sir.
Very exhaustive presentation, Dr. Jaykumar Venkatesan. Only one question to Dr. Jaykumar. Participants, please, only one question.
Good morning, sir. I am Kannan Mahadevan from Prestige University. Hello, sir.
Yeah, please.
Sir, how do monitoring plant experiments of space robo in different environment from Earth?
The concept is simple. You have to design. You have to coordinate the sensors, and also how you get the sensor inputs to you, how you communicate through that actually. So it is we collect the data, and that sensory inputs to go to some edge, and from edge to it will get transmitted to our systems, something like that. So it is not only necessary to be a plant data or something like that. You can manage any data. It's like this data gets from any kind of the sensor, and that will be transferred to us.
Thank you, sir.
Good morning,
Thank
sir.
you very much. Thank you very much. Thank you very
Hello.
much.
Hello, one more question, sir.
Later you can pose question. Please, later you can pose question. Now, Dr. Lata, please introduce the advisor of Prestige University.
Okay, sir.
Sir,
Thank you, sir.
more questions will be sent to your email ID, sir. More questions be sent to your email ID. Now, next session is the advisor of Prestige University. He is going to deliver. For that, Dr. Lata, you take care of that. Okay?
Thank you, sir.
Okay. Okay.
Good morning, sir. Now, we will turn the time over to our honorable advisor, Dr. Ramachandran, Ponniya Ramajayam Group of Institutions. He is a doctorate in architecture. He served as the Vice Chancellor of Periyamanima University, Tanjavur, for 2 successive terms. He was also the founder and Vice Chancellor of State University, Nasik, Maharashtra. During his career, spanning across 4 decades, Dr. Ramachandran has held several distinguished positions in the academic arena, including a number of central and state government assignments. As a researcher with rich experience, Dr. R. Ramachandran has sponsored research projects worth rupees 125 crores under his belt. He is also a recipient of several central and state government awards. I request you, sir, to deliver a welcome address, please, sir.
Yeah, very good morning. Vanakkam to everybody. Hope I am audible to you, everybody. Kumar?
Yes, sir. Yes, sir.
Yeah.
Yes, sir. Very much audible.
Yeah, it is a very great privilege and pleasure to be associated with these galaxies of eminent experts from all over the world for the last, even including today, third day. It's the third day. Very successfully pressed university, Ponnaya Ramajayam Institute of Science and Technology, one of the leading university in the southern part of India, which is promoting higher education under the able leadership of Professor Murugesan, the esteemed Chancellor, and Professor Ethirajulu, the Honorable Vice Chancellor, and all my colleagues. In fact, as an advisor to the Priest University, I am elated to be an associate of this program in coordinating with the Singapore University Technology Design. My beloved good friend, the most studious, dynamic Professor Dr. Rajesh Mohan Yelara, under his dynamic leadership, we have a very good support in terms of coordinating such international webinar, connecting more than 15 countries from Australia to America, in between whatever country you call, Japan, South Korea, China, Singapore, India, United Arab Emirates, then Brazil, Mexico, every Germany, New Zealand, Netherlands, every country. It is a very, very excellent opportunity for participants and also the eminent speakers, both from academia and industry. Friends, of course, we are really delighted to have such eminent speakers. And, the participants also quite intelligently participating and interacting with the speakers. Of course, bear with us. We could not give you enough time to put your questions, queries, because this is an opportunity where we connected with the American Professor Dr. Emma. Stepden was morning. The late evening she is addressing with us as a first working on environment. And the next gentleman, Dr. Jayakumar Venkatesan, who is a space scientist, a renowned guy, who has given you excellent, presentation on how this artificial intelligence, robotics, automated guided vehicles, even autonomous mobile robotics, how they are being deployed. This is the day. Almost, I believe, in the future, we are going to deploy maximum of robotics than any other machineries. In a way, people may think that because of the introduction of the robotics, some may lose their jobs. I don't find such losing jobs may not occur. On the other hand, it will enhance our employability and the employment potential opportunities for the studious youth of the global community. Because in the sense, if you just go back 30 years back, 1980, 90, in the middle of 80s, more introduction of computers have come. Many they have started even, vehemently approaching introduction of computers because of they may lose their job. On the other hand, today, without a computer, nobody can work. Without such a system, nobody can move. Even I am on move on my way to another industrial town, to Sivakasi. But even then, I could be able to get connected with this international arena through the connectivity, the networks, the systems, the computing facilities. That is where any technological development will always enrich our ability. Rather, that is why even the topic which was very appropriately chosen, enabling technology and emerging technology of robotics and their users. We see really, of course, writing, they have the experts, they were talking about agriculture, they're talking about rural development, they're talking about maintenance of infrastructure, including shipbuilding, maintenance, everything, space, whatnot. Even in these afternoon sessions, some doctors, they were one of the prominent Indian cardiologist, Dr. Damodaran, who has conducted first robotic surgery in Apollo Hospital, one of the premier institute in this southern part of India. who is going to address how this, the artery management using the robotics. And another, there is one ENT doctor on ENT surgery. See, that's where this is become ubiquitous. Robotics in our life, it is like a sixth finger. This is what I personally feel. Friends, there are a lot of opportunities and openings. That is why Christy University very appropriately chosen for their curriculum, for their own students at present. Since last year, we have collaborated with IBM International Bangalore office for offering courses like artificial intelligence, machine learning, deep learning, Internet of Things. This is all order of the day. So of course, our management, our chancellor is also having the plan to implement some of the educational robotics based R&D units in our own campus. So because even the day started with the education, very first in our webinar, the very first speaker was talking about educational robots. So that's where, friends, I believe this COVID-19, of course, it is a major setback for the entire global community. But on the other hand, it has given a very beautiful opportunity. How one can be a self-reliant guys, how one can use the technology. Even the current scenario, the current dictum is contactless. So contactless is the order. Even post-COVID, this is going to be a major lesson for us, children and youth, and these adults, including our senior citizens, geriatrics. So children to geriatrics, again, the robotics is going to play a major role, including entertainment. So every area, it is going to work like anything. So these 3 days, I believe there is a lot of opportunity to participate by my colleagues from Christy University to Singapore University Technology, joined their coordinating various programs. I must also compliment the young clerk deans from SUTD, like Dr. Amir, Dr. Satya, and Dr. Balakrishnan, and their team. Similarly, here in the Christy University, the moderator, Dr. Kumar, under the able leadership of Dr. Professor Christie, the Dean Academics, and my colleagues like Sandil Kumar and Ramachandran, everybody. We are sitting all in different locations, and finally we are reaching. So this is where the technology is playing as a major role. Friends, robotics industry as going to be very big boost in the days to come. I wanted to say the statistics on the robotics. Why? Here, robotics engineers means it doesn't mean that our old scenario, when we were studying, we used to study civil engineering, mechanical engineering, that the discipline specific. Now, robotic engineers requires, it is a consortium of various engineering groups. Maybe robotics engineer, these robotics, this works on different areas. So that expertise are required. So interdisciplinary, interdepartmental, inter-institutional, inter-university. That is going to be the approach. Possibly this exercise would really make us to think aloud. This is an opportunity for the participants. Maybe a young student, maybe a young researcher, even persons working in industry. It's a very opportunity for all of us. By 2024, the robotics industry is going to grow like anything, almost 9.2% growth. Something amazing growth is expected with the present $50 billion to $75 billion. I'm only just comparing with the Indian auto industry. Indian auto industry, completely saturated. Even then, our auto industry is going on. Many electric vehicle has come. Even automated vehicle also is going to come. So without that, our Indian auto industry will be around 250 billion. But whereas robotics industry globally has become almost 1/3. It's a very huge opportunity. So we must try to work with this space, and we must try to understand the concept of solving different specifications and application to their own respective area. I believe this international webinar on robotics will make a lot of sense, in the sense, lot of industry, even for that matter, every country, go globally, Singapore, Japan, Germany, they are investing more on their economy, especially on robotics. Those expenses are available in countries like here and countries like, like Lebanon, UK, and Germany, and so on and so forth. Everywhere, they take Singapore. One cannot avoid. And that too, on Singapore, the Singapore University of Technology same country. You cannot, just like that, forget. The reason is there, the Dr. Mohammed Martin Canada. I think dynamic leadership, they are supporting the government of Singapore. Government of Singapore almost everywhere. Of course, under the labor is a problem now. So now the when deploying the robotics, everywhere they are really supporting and they are giving a lot of comfort to them. They are specialized to them. Lion Park, experiences, something amazing. For doing that kind of work, we must try to bring it for the country. I believe, friends, this exercise, this participation really equals a major strength by strength. Of course, robots required the enormous amount of supply of power. Can the human being without energy can work? No, it is not. You may say some negativity is there, not at all. After all, our intelligence are sharpened by the definitely that artificial intelligence depended on very perspective work. Of course, any vulnerable situation, mission-based work, regulated work, robotics will work and will make work better than difficulty. I definitely feel as a person working in higher education for more than 40 years, I believe that robotics, introduction of robotics in every segment will give you a lot of opportunities. So, for that matter, I really appeal to all the academics, industry, researchers, and the most important thinkers to concentrate how we can deploy our minds through the machine. Which really gives us a good life and really gives us a joyful life. That is where I think this international webinar, I believe,
remember that given the we saw in the previous slides the challenges in the Indian roads.
And timely
Even
needed,
such an Indian context, honestly, there are a lot of studies done. So this is not my scripting that autonomous cars or fully autonomous car would probably take around 2050 to come in India.
For having chosen,
but then there are a lot of things that
wonderful webinar and the appropriate time. So this is an education really we learned due to COVID. If COVID is not there, we may not even get such a eminent scholars from 15 countries for organizing such an international webinar. It's not an easy task, but it is a very simple now because people are sitting at their own table and desktop and delivering their eminent expertise. And we the people sitting across various spectrum, even all over the world, I would say, and we are enjoying. I think really this international webinar has given a lot of laudable openings. We believe that this must be encashed by our technocrats, by our scientists, by our sociologists, by our planners, and by all our administrators. With this, I thank the organizers. I thank both the institutions for having given a very beautiful opportunity to understand, to undergo such a very laudable exercise in these 3 days. I wish this third day today is going to be another major, mind-boggling day. And with that, let us enjoy, let us work together, let us network together, let us identify the problems of local by using the global expertise. And thereby, let us keep the humanity safe. With this, I thank the organizers once again for having given a very beautiful opportunity to share my views and thoughts. Thank you very much. All the best. Very good day. Thank you.
Thank you very much, sir, for your extraordinary delivery. Now, formally, Dr. Lata would take care.
Okay. Thank you very much, sir. Now, we have the privilege of listening to Dr. Balakrishnan, Ramalingam, Singapore University of Technology and Design, Singapore, on the topic the role of deep learning in robotic vision system. Dr. Balakrishnan is a postdoctoral research fellow of robotics and automation research lab at Singapore University of Technology and Design at Singapore. He was working as a research scientist in Tata Power Strategic Engineering Division. He received his BS and MSc degree in electronics from Bharathasan University, Tiruchirappalli, India, in 2006 and 2009 respectively. He completed his PhD degree from Sastra University, Tanjavur, India. His research interests include artificial intelligence, computer vision, and embedded system design.
Prest Deemed University. உங்களுக்கான பெஸ்ட் சாய்ஸ். Prest Deemed University, Tanjavur, Kumbakonam, Madurai, Trichy, Puducherry, Chennai City Campus and Chennai ECR. Prest offers all approved courses in engineering and technology, agriculture, architecture, law, pharmacy, optometry in association with Agarwal Eye Hospital, Education, Commerce and Business Studies, Arts and Science, MPhil and PhD. Prest in collaboration with IBM. IBM collaborated courses, BTech, BSc Computer Science,
Pleasant good morning to
BCA,
all. Hello.
BBA, MBA and BSc Agri.
Very good. Yes, sir.
Okay, fine. Yeah.
Prest, an ideal
Pleasant good
place
morning
to
all.
become worthy
Myself
citizen.
Balakrishnan. I am working as a postdoctoral research fellow in Cloud Labs, Singapore Institute of
Prest Deemed
Technology.
University.
Today, my topic is
உங்களுக்கான
the deep
best
learning for
choice.
cleaning robots.
Prest Deemed University, Tanjavur, Kumbakonam,
Yeah, this is the
Madurai,
outline of my
Trichy,
presentation. The first
Puducherry,
few slides I would like
Chennai
to speak
City
about
Campus
the
and
deep learning
Chennai
framework
ECR.
and use cases of deep learning framework in the robotic vision system. And the next few slides I'll discuss about two real-time cleaning problems we solved using human support robot and a deep learning algorithm. One of the case study is the table cleaning task in food court environment, and the next one, door handle cleaning in hospital-like environment. So, deep learning is the branch of machine learning. In recent years, this deep learning, yes, is audible.
Yes, sir. It's audible, sir.
Yeah, okay. Yeah. The recent years, the deep learning algorithms are widely used in the robotic vision system for solve the various real-time problems like obstacle detection. Sorry, 1 minute. So various problem solving. One is for object handling in the industrial robot for handling the so industrial robot for handling the various objects, and also environment recognition system in autonomous vehicle and service robot, and also obstacle avoidance for indoor and outdoor service robot. Generally, this deep learning architecture are classified into three categories in the robotic vision system, like the classification model, detection model, and segmentation model. If you see this image, you can understand the difference of the three models. Like the classifier model can able to only classify the object, can't able to localize the object. The detection model can able to localize and detect the multiple object in the image. The segmentation model is slightly different. It's perform the pixel by pixel classification, and it provides exact outline of the object within the image. So this segmentation model is mostly used in autonomous vehicle and service robot for identifying the environment. And this detection model mostly used in obstacle detection or the object recognition in the service robot. convolutional neural network is one of the key components in the deep learning neural network. This CNN architecture is a specialized deep neural network architecture. It consists of a set of convolution layer and pooling layer and ReLU components. It's a backbone of most of the DLL algorithms. This architecture has self-feature extraction capability. You can automatically extract the feature from the image without human assistance. This is one of the key advantages in the CNN architecture using the DL algorithm. So in recent years, there are a lot of feature extraction algorithms are available like LeNet, AlexNet, and AGG, ResNet, Inception, MobileNet, and DarkNet. According to our robot computing power, we can select the suitable feature extraction model. If you see that, this is the model, is the SST model, is the one of the lightweight feature extractor for object detection model. And the inventor used the VGG16 as the base network. But if our robot have limited computing power, we can replace this VGG16 as MobileNet or DarkNet. Because these two this base network is used as the feature extractor. So generally, this VGG16 is little bit high computing power. So if our model, if you need light computing model, we can choose MobileNet or DarkNet. Similarly, in that, this is the SegNet is one of the semantic segmentation model. This model, they use the same VGG16 as the base network for extract the feature. The inventor used the VGG16, but in our mobile have a light computing model, light computing resources. We can replace MobileNet or DarkNet as the base network. So according to our computing power, we can select any base network for feature extraction. So in the earlier period, we need a large amount of database and high computing powers for train the models, and also for collecting the database is a huge headache. So it's a time-consuming process. But nowadays, a lot of pre-trained models are available. These models we can easily use for train our own, solve our own problems. So once if you are using the transfer learning model, we can use only the very less amount of images for train and solve our own problems. The TensorFlow is one of the best tools. There are a lot of pre-trained libraries are available. So these pre-trained libraries we can use for train our own model with the best computation time. And in the early stage, a lot of computing powers is required for executing the pre-trained trained model itself. But nowadays, a lot of sophisticated hardware architectures are available, like that's the Intel Neural Compute Stick and Intel Compute Stick. These hardwares is a low power and low power hardware. You can easily adapt for any robot application. Okay, so I'd like to go to the real-time problem statement. Hello, yes, audible, ma'am? Hello.
Dr. Balakrishnan, it's audible. Please continue.
Hello.
It's audible, sir. Please go ahead.
Okay, yeah. This is one of the real-time problem we solved using deep learning algorithm with a human support robot. This generally aged population community. The manpower shortage is the constant problem in the food court like an environment. So we have planned to solve this issue with the help of human support robot. This robot we use the deep learning algorithm for clean the table and collect the food traces. For that we use the human Toyota HSR robot. This robot has the inbuilt robotic operating system for control all the packages, arm manipulation, and motion planning. So this robot we have a RGBD camera for recognizing the object in the environment, and have a 4 degree of freedom, so it can able to access the 3D spaces in the environment. So this is the architecture we developed for recognizing the food litters on the table. This is a 16-layer architecture. I comprise of 9 convolution layer and 6 pooling layer for extract the feature. So this architecture we build with the Darkflow framework. The Darkflow is the flexible architecture. According to our application, we can adjust the CNN layer in the net. So for training the model, we use the pre-trained model. So we use 300 food rubbish images for train the model. And that model, the images are we have collected, we have generated in our road lab. And yeah, this is the test bed. We are so this is the experimental results. After trying the model, we have tested with this HSR robot. So the detection accuracy of the model has been evaluated with the standard evaluation metrics like accuracy, precision, recall, and F1 measure. After the trained model, we observed that the model has obtained 96% litter detection accuracy, and also the false detection has been very less. It's only the 3% of the false detection, and the model has reached up to it took 9.4 seconds for detecting 50 objects from the image frame. This is the video I'd like to share. So this is the test trial we done in our lab. So we have put some solid and liquid food traces in the table. So first we run that model for identifying task. So the model has accurately detect the object on the table. After that we have initiate the cleaning task. So in this trial, we observed that for cleaning the solid and stains, the robot need multiple, for stain type food traces, it required multiple iterations. So the algorithm has been run multiple times up to clean the entire table. Yes, this detection accuracy of the model already I showed. This model has 96%, 96.3% detection accuracy for both solid and food leader detection. So this model we can able to trial and multiple tested. We can done in the multiple trial. We observe that it can able to accurately clean the table with the different food traces. Yeah. Yeah. This another case study is the door handle cleaning. This door handle cleaning we developed for hospital environment. Generally, this COVID-19 situation, we need to clean the door and hospital environment. We need to clean the door handle multiple times. So is this COVID-19, the door handles are the high sensitive point in the hospital environment. So it's required a high frequency to clean routine and also avoid the human contact. So usually usually the door handles require 2 to 3 minutes for to clean the door and door handle. So large size hospital and the institutions, it need more manpower and hard to follow the highly continually follow this task. So we have planned to automate this task with the help of human support robot. And this robot he has to customize according for perform the cleaning task. This is the sanitizer model we have we have designed in our own lab. This model can automatically spray the sanitizer on the door handle. This model controller has been connected with the HSR for spraying the sanitizer. for varying the angle, we have provide one more position for according to the door handle size, we can adjust the spraying angle with the help of this Arduino hardware setup. This is a video how this. This is the case study we done in our lab for cleaning the door handle. First it will do the spraying, then it will perform the cleaning. So before we load this model into the HSR, we have tested in offline with a different door handles. So the algorithm can able to recognize the different door handle. So according to the door handle detection, we can able to plan the cleaning pattern. Yeah, the detection accuracy, we observe that in the offline, the model has accurately detect the door handle with a 97% in the offline, and the real time is slightly low. It's detect the door handle with a 91% accuracy. We have tested this model in the two different environments. The first environment has 4 door handles. So for cleaning this 4 door handle, the robot take 18 minutes. Similarly, the second test bed, the model that had 3 doors and took 10 minutes. So this computation time include navigation, robot navigation and object detection and cleaning. Yeah. So this model will help to reduce the cleaning time and also automatically detect the room. It can able to access the door and also perform the cleaning on both sides of the door. And the sanitizer mechanism we develop is the refilling mechanism. Once it gets empty, the robot automatically intimate we need to refill the process. And also we try to improve the self-cleaning evaluation mechanism for try with the different door handles. Yeah, any questions?
Excellent demonstration.
Yes,
excellent fine demonstration. Audience, participant.
Hello. Okay, if you feel this model is not stable, we can add some security layers for protecting the vision system data.
Okay. Thank you, sir.
Okay. Yes. Hello.
How the 3D happens, the solid and the liquid mix.
Yeah. Yes.
Please brief. We are far ahead of the other professor, so you can brief more.
Sorry. Can you speak louder? Your voice is not clearly. I can't.
Okay. The solid liquid mix. How the 3D happens.
Yeah. Usually this stains and solid we have trained with 3000 images. It's the future extraction process. Solid usually have some depth, is a very less depth data. So we use the RGBT depth images, and the stains don't have any depth value. So this is also one of the scope we can identify the solid and stains. Yeah.
What is the error rate?
Yes. Usually the solid error rate is very low, but stains, there is a false detection. If the objects look like stains pattern, it also detects as the stain we observe. Yeah.
When undertaking this kind of work, what are the challenges they face?
The main challenge is the quality of the image. If the captured image is not related with the real time task, the most we observe that lot of false detection and the misdetection. So the image should be matched. The training image should be matched with the robot perspective. This is the key. So this is a very key factor we have to follow in the training stage.
During system development, what techniques, what challenges you face?
Yeah, system development, usually the robotic have mostly the light computing platform. So we have to select the light feature extractor and object detection model. And if you see that generally the SSD is one of the model is running both mobile platform. It's running mobile platform also. So this model is most preferable for robotic object detection and this segmentation task. SSD mobile net is the best combination. We done a lot of applications based on using the SSD mobile. The next one is the YOLO. YOLO is the recent YOLO V3 is the updated one. Its detection accuracy is good. So it also we can use in the robot.
Do you find something that is extremely difficult?
Sorry?
Do you face something that is extremely difficult when you undertake this research work?
In what aspect is extremely difficult?
Something is, have you faced something you find that is extremely difficult?
Yeah, one of the application we developed for aircraft skin inspection. And that model we use usually that aircraft skin inspection is corrosion and crack or defect detection. Is a human inspector is required for perform this task. But we replace with our RoLab, the Mantis, one of the platform, the vertical climbing robot. We use this vision system for identifying the crack and defect on the aircraft. This is one of the challenging platforms we use.
The software platform you use with MATLAB.
We are using TensorFlow. So for all the development, we use the TensorFlow tool, and Python is our programming language. Yes.
Have you used Colab? Google Colab? Have you used?
No, sir. No, we are not using Google Colab. Yeah. We are using TensorFlow.
TensorFlow. Okay. Yeah. Something do you want to say? Participants could make a simple attempt on your better learning. The participants in general, they can they can practice some kind of aspect like that. Could you say?
Sorry, sir. Sorry.
To the beginner,
okay.
Could you say something?
Okay.
For their practice? Have you got my question?
Yeah, no, not clear. The voice is clear. Can you better type the command? I can see.
Yes. To the beginners,
okay.
To the beginners, do you want to say something?
Yeah, so for beginners, they first start this deep learning framework from pre-trained model. So first they can start already trained model and test with their laptop or some low computing devices. The next stage they can use their own image database and using the transfer learning model in the next level to solve their own problem. Then they can start design own CNN architecture according to a robot computing power or according to their need. Yeah. There are three stages I have to follow for learning this one. There are a lot of trained libraries are available like indoor obstacle detection or outdoor object detection, semantic segmentation model. Just first we try to run this model, how we can learn this technique. Then we can move on to
How much time, sir, you took, how much time you took to reach the capacity?
For theoretical point of view, it takes a long time. But in the application, we can learn this concept 6 months. Yeah.
Okay.
So understanding all the deep learning concept and all, it take long time. Practically, it's okay. 6 months.
Do you suggest any book? Do you suggest any book?
There are some advanced, the good books are there. Jason Gillespie is one of the best author book. It's available in online. His tutorials are more useful to understand the deep learning and the machine learning.
Publisher, sir? Publisher of that book?
No, it's an online book. It's online. Yeah, soft copy. No publisher on that. This copy is available only this person website. Jason Gillespie.
Okay, sir.
Yeah.
Audience, participants?
Good morning, sir.
Yeah.
Very nice.
Sir, I am TTM Kannan from Prestige University.
Yeah, tell me, sir. Yeah, good morning, sir.
Sir, deep learning of robotic vision can be adopted in disaster management, sir.
Yeah, it's possible, please.
Any big disaster system is possible, sir? Management system?
In that vision, in visit aspect or some other different applications? Because this deep learning algorithm will support in different applications. So my research only based on the vision system.
Oh. Okay, sir. Thank you, sir.
Some more questions from participant side? Since the speaker is far ahead of time, now we have around 10 more minutes. If possible, the participants can raise more questions. We welcome the participants to raise more questions. Whatever the nature of the question. The participants? Sir, your experimental demonstration and all, building a
Yes,
system, how much time you had, sir? Building one
Usually
system.
that the image database collection is a time consuming process. It may take around 1 month also. Sometimes the collected data will not good for getting the better results. So again, we need to do that image database. This is the hectic process in this deep learning. But some standard application no need the image data set collection because those are lot of libraries are available like ImageNet. Apart from ImageNet, according to application, we can find lot of image database. We can get that images through proper permission or it's freely available. So those images we can use for training. Yes, sir.
You have taken your own images, okay? You spent
If the application is very specific, we need to say, for example, the stress and food stain detection. I didn't find any data set, so we have to create our own data set. But we use the pre-trained model for training the network. For this corrosion and crack detection, lot of libraries are available, so no need to spend that. But these cases are specific cases, so we need to create our own data set.
When you collected your own data, the camera resolution, do you want to suggest?
Yeah, camera resolution is not an issue. You can use any camera. Moreover, if you image have if you take in the different lighting condition and a different different pixel resolution, this is good for algorithm to learn the new parameters. Because if your images are all more stable, so algorithm could not able to learn any new parameters. So the database, the data set image collections, we have to collect the different lighting conditions, the different angles. These are very important.
that moves.
Yeah, okay.
That kind of nature, how you have to handle. Let us say they will, that way, let us say that moves, that trips, that twist.
Sir, this idea is given by my Professor Mohan Rajesh Silara. So we have planned to create the benchmark for this cleaning robot for identifying the trash, floor trash, and the food stains on the floor. So this application we developed mainly for. So generally, robot have vision system for understanding the obstacles and other objects. But the cleaning robot also need the knowledge how to handle the trash. But human have the knowledge how to handle the trash. Even the small stain, the robot can able to clean. But large size stains, it should know whether it can able to clean or it should avoid. These things we have discussed so that we have formulated this problem, the solid and liquid detection. Hello.
Yes, sir. Sir, when
Yes, sir.
you
Please just
handle,
touch on.
when you handle images, any data overflow, that and all, you have your experience, data, when running software, any kind of, software difficulties, running that kind of data flow.
So for only training, we need a high computing CPU like a GPU cards enabled system is required. But now we can use the cloud server for train our algorithm because it's very cheaper, like $5-10. We can rent out the cloud servers for train the models. Moreover, it takes 1 or 2 days is required. Usually, the training is the it take long time for training. Usually, 2 or 3 days it may be take. It depends on the images and accuracy. It will be.
Training the images takes 2 to 3 days, you mean?
Maybe one day you need to monitor that. Say, okay, I'll show the screen. So you need to monitor the detection, the loss and all.
Okay, something you want to say to show your screen, please show that.
Yes, I think my screen is visible.
No, sir. No, sir.
Oh, sorry. Yeah. So these are the three parameters we need to observe regularly when we put the algorithm in the training. When you initially the initial stage, the loss will be very high. So after 25,000 or 30,000 iteration, usually it take 1 day for 30,000 iteration. The loss will slowly get reduced. Once it gets stable around 1.5, 1 or 1.5, we can stop the training. This is the parameter we have to follow. The classification loss is indicate how the algorithm is accurately classify that, and these things we can analyze here. And localization loss is the bounding box, how it's accurately mapped that bounding boxes. This is a total loss, the parameter. Yeah.
Okay. Okay, sir. This presentation on behalf of the participants, on behalf of Trust University and the SUTD. We appreciate your patience or aware of or motivating the participants.
Yeah, thanks. Yeah, thank you.
Thank you very much, sir.
Thank you. Thank you, sir.
Dr. Lata?
Yes, sir.
Yes. Please take care of the next speaker.
Okay, sir. Our next speaker, Dr. Prabhakaran Veera Jagadishwar, has completed his Bachelor of Electronics and Instrumentation Engineering from Satyabama University, India in 2013 and has held a Master degree in Information Technology from Manipal University in 2017. He received his PhD in Advanced Multidisciplinary Engineering from Tokyo Denki University. Currently, he is working as a postdoctoral fellow in Robotics and Automation Research Lab at Singapore University of Technology and Design. His research interests include development of complete coverage path planning, SLAM framework, and embedded system for reconfigurable robots. Now we have the privilege of listening to Dr. Prabhakaran Veera Jagadishwaran. Please, sir.
Dr. Veera Jagadishwaran Prabhakaran, please.
Hello everyone. Yeah, can you?
Yes, sir.
Yes,
It's
sir.
audible to
It's
you.
audible, sir.
Yeah, can I? Thank you. So let me share my slides first. Uh,
Take your time. Take your time. You are well ahead of time.
so can everyone see uh, my presentation? Can
Yes,
everyone?
Sir,
sir.
we can see. We can see. Very nice.
Okay. So hello everyone. Good afternoon. So myself Veera. I'm working as a research fellow in Roads Lab at Singapore University of Technology and Design under the supervision of Professor Mohan Rajesh Ilara. Today I'm going to present a topic on towards developing efficient area coverage approaches in domestic robots. Okay, before I jump into the presentation, let me give a small introduction about the domestic robots. Domestic robots are in which is being deployed to perform domestic tasks such as cleaning, lawn moving, inspection, entertainment, and so on. A recent survey shows that 96% of total domestic robots are being used for cleaning related tasks. Another survey on the right justifies that argument by showing steep improvement in revenue generation from the domestic robots. Even there, the top three spots again goes to the cleaning related robots. There's another survey shows increment in robot shipments. So from these surveys, we know that the usage of domestic robots are steeply increasing, and most of these robots are used for cleaning purposes. When when we say cleaning, one critical parameter that defines the cleaning robot is area coverage. So in this study, I'm going to explain what are the existing bottlenecks in the cleaning robots and the design process we did to overcome these challenges. Yeah. So as we know, um, the cleaning robots are very famous, and there are commercially available robots all the way from Roomba to Philips to Xiaomi. So all these robots are already famous and it's been available in the market. So these robots are going to occupy our household, especially in the developed nations. Even though we can see big players already ruling the market, the existing cleaning robots has a series of performance issues. One such issue is one such issue is their area coverage performance, which is affected because of their fixed morphological shapes. Due to such a drawback, these robots cannot access narrow spaces and room corners. Because of this issue, the current day cleaning robots can only access 60% of the overall coverable area. So when the robot can only access 60%, that means the cleaning percentage, the total area cleaned, is also around 60%. So that means 40% is unclean. So this is a typical problem what a cleaning robot that faces, and the current day cleaning robot faces. So you can see the robot cannot able to enter this narrow space. So these are the typical areas that we can identify in our room space in the living room. So yeah, one obvious option we have was reducing the size of the robot. So when we do that, when we reduce the dimension, the cleaning capacity, the battery capacity, and the computational capacity will also be reduced. So on the other hand, the other option we have is we plan to implement multi-robot strategy by reducing the size of the robot, which obviously increases the computational complexity, and the multi-robot coordination decision will further increases the difficulty in terms of implementation. So our main aim here is to make the cleaning robot to adapt its shape for the given environment to maximize the coverage area. In order to achieve such capability, one viable approach we came across was the shape-shifting techniques, which has been widely used to optimize the living space to have more accessible area. Such techniques were also applied in robotics field. So like you can see in the right hand side. So most of these reconfigurable technique that is being already applied in robotics field are mostly fixed or tightly fixed with the mechanical design and on linkage mechanisms, and often loosely connected with the end application. So these reconfigurable mechanisms are not being applied for an end application. So now we know that what we need to do, what techniques that we need to apply, and to achieve our aim. With this basic idea, we started looking for inspiration. So inspiration is a critical the process for developing any robot, to design any robot. So with the basic idea, so we need to know what we need to achieve. So we, from the previous studies and from the previous literatures, some parameters that we take as our baseline for the inspiration. So we fixed modularity as our design concept to achieve the reconfiguration. So this so such consideration we taken from the existing was taken from the existing robotic designs that were involved self reconfigurations. So when we see for inspirations, the first thing with the consideration of modularity, the first thing we saw was the Lego kit, where all the modules can attach and detach. But the problem here we face was we need to have multiple small parts, which is difficult for us to assemble, and so we move on to other options. So the next option we had was origami. Origami is also is a reconfigured in nature, so the origami can able to change its shapes by folding and unfolding. The third one we came across was the game inspiration from Tetris, the game that we played in 90s. There is a building block game where we different shapes fall from the top, and we need to fill it without any gap to gain points. So in this game, you can see there are 7 shapes that fall from the top. So all these shapes can need to be filled without any gap. So this is the main concept of this game. So we thought we can use this game, these shapes as our baseline, as our inspiration, and we started developing on this. So the shapes that we the pieces that fall from top is called the polyominoes. Polyominoes were geometric structures that was formed by joining 2 or more equivalent square blocks together in edge to edge. If 2 blocks were joined, they call it as domino. If 3 blocks are joined, they call it as tromino. If 4 blocks is joined, they call it as tetromino. So this tetromino is where they derive the Tetris name. So when 4 blocks join together is tetromino. So the inspiration that we take from Tetris is basically a tetromino. So we know now in our robot we are going to have 4 blocks, 4 equal and square blocks. But how to make these blocks to transform from one form to another and to achieve all 7 shapes? For that we came across the concept called hinge dissection. So hinge dissection is a technique wherein various pieces are connected as a chain through hinge points, so which can rotate to make these pieces to transform from one shape to another. Similarly, we need to identify the hinge points, which is critical for us in order to achieve all 7 shapes. So the table here shows the hinge points that we tried and able to achieve the 7 shapes. So the hinge point that we tried is left right configuration. We basically called it as LLR. So we took I as our base configuration. From there we choose which is the best hinge point to make the robot to transform between all 7 shapes. And we finally came to the conclusion that the left right was the best configuration to achieve all 7 shapes. So once we have that, then we started developing our robot. So the one you're seeing here is the basic system. So we have a different functionality for each block. So totally we have 4 blocks. So we initially, this is the initial design. So in the initial design, we made the first and second block as a locomotion block where we have all locomotion components. The second block is basically an anchor point where the block don't move. So it acts as an anchor where the hinge motors are housed, and these motors drives the other blocks. So the block number 2 will not rotate, will not change its shape. So we call it as an anchor block. So here in block 2, we put all the electronic, like controllers, circuits, batteries, everything we put it in block 2. In block 3 and 4, we used for our vacuuming module. So this is a basic system architecture for the HTRO. So where how the connections between blocks and how many motors we use, how many drivers, what are the drivers we are using, what's the controller we are using. And we also developed a small Android app where we can we can connect the robot with Bluetooth and send send the shape commands and move locomotion commands through Bluetooth. So we ran an experiment where we considered different chair types. So in order to compare with justify our work, our concept of reconfiguration can improve cleaning efficiency or area coverage efficiency. So we need to compare it with the fixed morphology robot. So we ran different experiments. So we ran 2 experiments. In the first experiment, we choose different chair types. So these chairs are the common chair types that we often see in any working area or in any any households. So we rank these chairs from 1 to 10 using their number of legs and the distance between their legs. This is the first experiment. In the second experiment, we tried we set up a room type setup, and we actually used 6 different obstacles. So we varied these obstacles from 1 to 6, and we compared with the area coverage efficiency between the HTRO and the fixed morphology robot. So we mount our overhead camera which records all the coverage process. Later we track the robot and generated a track map. This track map gives us the total area covered by these robots. So in the first experiment, this is the results from the fixed morphology robot. You can see the fixed morphology robot can able to cover the chairs the chairs rank 6. That means the distance of the legs is higher, and because of that, the fixed morphology robot have enough room to cross over. and you can see all this green area where the robot is covered. So you can see in rank 6 the robot can able to cover almost all area, but when it comes with a higher ranked chair, that means higher number of legs is high and the distance is low, the distance between the legs is low. So in this case, the the fixed morphology robot cannot able to cross over. Because of it can only cover the release area. So this is coverage area of H-tetro robot, and you can see the robot can transform between morphology and can able to cover all the area. So here in rank 10 and 8, the difference between the coverage difference between the fixed morphology and the H-tetro is significant. And this is the percentage that you can see for the different ranking, and the coverage is suddenly decreased when the rank when at 8, 9 and 10 ranking chairs. In the second experiment, you can see the fixed morphology robot can able to cover the area if the number of obstacle is just 1, and if the number of obstacles increased, the area coverage is also decreased. So it is inverse. Here in H-tetro, the robot can, even after increasing the obstacles, the H-tetro can able to cover by changing its morphology. So this is also the percentage for the experiment, the area coverage percentage, and you can see H-tetro is significantly higher than the fixed morphology. So the video that you are seeing now shows the robot's ability to change between shapes, and this is in experiment 2. You can see the fixed morphology robot, because of its fixed morphology, it cannot able to enter these narrow spaces. And the total area that covers is 60%. So here in the H-tetro, it can able to change its morphology by knowing the environment, and it can change to optimal shape and can go into the narrow spaces and room corners and can achieve more than 95% of the area coverage. So this is another typical example where the fixed morphology robot cannot able to cross over from one end to another end because of its fixed morphology. So in the same with the H-tetro, we can now the H-tetro can actually change to O to I and I to O to cross over from this end to another end. So here, so you can see that from I, it can actually change to O and can cross over and can cover the area. Yes. So once we have the platform, then we have to obviously make it autonomous, right? So the autonomy, when we say autonomy, the critical development, the ability for every cleaning robot is it need to perform a coverage path. So it needs to have a coverage path for to cover the environment. So in the literature there are existing coverage path planning techniques available. One is the obvious one is zigzag path planning, where the robot goes in zigzag path and can cover the area. The second is grid-based path planning, where the map, the robot converts the map into grids and try to cover each cell. So there are other concepts like cellular decomposition, where they decompose the map into small cells and can cover. Also landmark-based coverages and distributed approaches. But the problem with the H-tetro is that applying the traditional one is these algorithms don't consider the reconfiguration ability of the robot. So the cost that it takes for reconfiguration, even the morphological change, when the morphology is changed, the the perimeter of the robot change. So these algorithms don't care or doesn't care about that, doesn't mind of the perimeter of the robot. So we need a new method for area coverage. So then we thought of using polyominoes tiling theory. So then we again jump back to polyominoes. So where we get the inspiration, right? So we again jump back to the polyominoes tiling theory. I mean polyominoes, and we found polyomino tiling theory as one solution that we can apply for area coverage task as an autonomous area coverage path planning task. So polyomino tiling theory is a branch of mathematics where they see how to tile a given 2D space with a given number of polyomino pieces. So these problems were handled by mathematicians, great mathematicians, where they derived theorems mentioning that with this boundary, with this A cross B area can be tiled with these particular shapes only. So for example, if 4 cross 4 or 6 cross 6 area can be covered with only T shape and L shape, something like that. So they have derived various of theorems, number of theorems for these kind of polyomino tiling theory. So these theorems will act as an algorithm for in the Tetris games, and using these theorems that the algorithm generate the pieces. So whenever the the stage is going higher, the difficulty level is also goes high. So these theorems we use it as our in our path planning technique, and we try to implement for a hackathon. So these theorems previously used for packaging algorithms and gamings, but never been used for a robotic application. So in our case, we are going to implement this for our robotic for a path planning technique, and which is very novel. So this is the first time ever be used ever polyomino tiling theory has been used for area coverage application. So this is the task. So this is the framework that we developed. So first is the mapping. Obviously the robot will just map the area. Once the map is generated, it makes the map into occupancy grids. Once we have the grids, we can make these grids as a matrix. Once we have this matrix, the algorithm will generate the tiling set for the generated matrix. With the tiling set, we can able to generate the different waypoints. Once the waypoints is created, the the trajectory generator will generate the path, and the robot is just uses its motion controller to follow the generated path so that it can cover the entire area. So this is a typical example of our. So here the theorem says one can completely tile, and this is animated video. This is a concept video that we made before we start developing developing the tiling theory. So here the theorem states that one can completely tile a 3 power n plus 3 power n square with one square removed. That means we just remove one cell with any of O, J, L and T tetrominoes. So, and you can see the robot just used O, J, L and T Tetris shapes and to cover this area. And this is the so this is the generated tile pieces. You can see the robot starts slowly covering the area, and at the bottom left you can see the tiles that is been already covered. The tile is being generated and the robot is being the process of coverage. I'm just time lapsing it because it's a 2 minutes video. So we implemented these theorems in our real-time robot with the Hackathon. So the theorems that we used is theorem 1 is the A cross B rectangle can be tiled with T and skew Tetris pieces if A, B is greater than or equal to 4. So this is the basic conditions that the theorems need. Once we have the map, once we generate the matrix, we know what is the number of cells inside A and in B. So once we have this, we can able to decide what theorem need to be applied. So the algorithm decides it and start generating the tile sets. So these are uh, the tile sets generated, and we use the similar setup like what we used in the previous experiment for to conduct this experiment. So we use the overhead camera to track the robot. So this video, you can see in real time the robot is now able to generate the tiles and try to fill the generated tile. Likewise, the robot can able to cover any area. So these are the results that you are seeing for different theorems. The video shows the the theorem 2, I think. Yeah, theorem 2. Video shows theorem 2, and here you're seeing the results for different theorems. So from these we know the robot can able to do tiling based coverage. So similarly, so it's just the so far we have whatever we discussed is hashed row, which have four blocks. So when I was presenting in some conference, when they ask for these questions, so why can't it's just 4? Why can't be is 3? Why can't be is 2? Why you need 4? So it was an interesting question. So we wanted to also work towards that. So then we started just removing one, and we made a hash tromo. Tromo is basically have 3 blocks, and yeah. So similarly, we use a control app to communicate, to have an interface between hash tromo. So in this, here also we applied a similar tiling theorem for coverage, and you can see the robot's coverage process. Yeah, hello. Someone's mic is on. I think I'm getting the echo. Hello. Yeah, okay. Now it's clear. Okay, thank you. So from that, we also prove that even though we reduce the number of blocks, we can able to implement these tiling theorems as a coverage path planning technique for reconfigurable based robots. So these things are these are the results that we used, that was generated for different theorems using H Tromino. And you can see we put lot of obstacles here in theorem 4 and theorem 5, and still the robot can able to navigate and can able to cover it. So as a conclusion, we propose the reconfigurable technique to maximize area coverage in domestic robots, and developed HTO as a self-reconfigurable cleaning robot. So we propose the novel area coverage technique, presented a motion planner, and explore different robots with the different blocks. We have H-hetero, H-romo, H-pento with 5, and it shows that the proposed technique can achieve maximum area coverage under the proposed tiling motion. So in future, we wanted to do optimization in terms of overlappings. So how we can reduce the number of overlapping, and how we can reduce the number of reconfigurations happens in between the process. So so that the energy can be saved, so that the time can be saved, and so we are also considering other aspects to optimize it so that we can make it more efficient. And other work is like we are planning to do multi-robot coordinations, where we call as how multiple tested through comes together and forms a global position. So that we have multiple, not just 7 years, but have other number of features. So these are the future works that we are planning to do and we are currently working on. Yeah, thank you. And if any questions, please you can switch on your mic, or otherwise you can chat. You can type it on the chat box.
Yeah, very nice presentation, sir. Participants, please ask questions. Dear participants, this is the time for you.
Sir, good morning, sir.
Hi, good morning.
I'm Kannan Mahadevan from Presty University, sir. Sir,
Hi, Kannan.
What is the process parameters for designing and development the area coverage approach of domestic robots, sir?
Okay, the parameters mostly we use is, of course, the area coverage, the total distance traveled, and the
Yes, sir.
total area recovered. And first of all is the area coverage and the total area recovered and the total distance traveled. And these are the main, and the time, how much time the robot lasts in a given area. So these are the main parameters that we needs to develop. That means needs to optimize so that we can make these robots more efficient. So there are research where they mention what is the critical parameters that needs to be uh, focused in the development of building robots. So over there, these are the four parameters they mainly use. So even in our optimization program, we are planning to use these parameters. How we can optimize these parameters. I mean, this is our keeping these parameters as our base, and how we can optimize the robot to maximize the efficiency. So yeah.
Thank you, sir. Very informative to your lecture, sir. So another one doubt, sir.
Yes.
How to arrive a efficient area of coverage, sir? What is meant by efficient, sir?
Okay, efficient is basically how so for example, if you take one parameter, for example, if you take area coverage, total area covered. So with like I mentioned in my presentation, the comparison I did a comparison between tested pro and fixed morphology robot. So how efficient the fixed morphology robot can cover the area. So if the robot can only cover 30%, that means the efficiency in coverage is very less in fixed morphology. So these are the parameter efficiency we consider. So if how efficient a parameter we can, that depends on the parameter of course. So how efficient we can make design these robots to um, perform better. So efficiency is directly related to the performance.
Yes, sir.
So efficiency and the performance are tightly are close each other. So efficiency is very important. If you want to improve the performance, the efficiency is to be improved. Yes, like that.
Thank you, sir. Thank you. We have learned more
Thank you.
about your
Yeah.
lecture, sir.
Thank
Thank you,
you,
Thank you very
sir.
much, sir.
Thank you very much.
thank you, Durai Raj. Yeah, thank you.
Dr. Lata, please.
Hi, sir. Thank you very much, sir, for a valuable presentation. Our next speaker, Professor Ming Jiang, Peking University, Beijing, China, on the topic Perspectives of Image Similarity Measures for Joint Multimodality Image Reconstruction. Professor Ming Jiang,
Yes.
interests are mathematical and technical innovations in biomedical imaging and image processing with X-ray computed tomography, optical molecular tomography as a focus. He has supervised doctoral and mentored postdoctoral research in the reconstruction development for X-ray and optimal tomography techniques. Now we have the privilege of listening to our Professor Meng Jiang. Welcome, sir.
Yes.
Thank you very much for the nice introduction. Can you see my screen?
Yes, sir. It's clear, sir.
Okay, thank you very much. I'm honored and pleased to participate in this conference. And thank you very much for Dr. Kumar for the invitation. So I'm talking about image similarity today. It's about how to compare two images. I will start with the application that we worked with. That's why we come to this image similarity measures. Now I'll share with you my lessons from a topological perspective and also psychological perspectives about similarity measures. Then it's a brief summary of recent work on similarity measures. So my application about image reconstruction. So as NASA has introduced me, I'm working on X-ray tomography, MRI. So traditionally, we have this forward process for X-ray. It's a projection. And the image reconstruction is to open the image F1 from the measured data G1. Because this problem is U-post, so the conventional way is to use a recognition term. And there is a huge literature on it. So with the possibility of other image modalities, so one possibility is to obtain a recognition based on the information, that's a structured information from another image. And we have many image modalities here for biomedical imaging. I think this is the same situation for robots. Here you have a lot of sensors. How to fuse the image, how to fuse the information to get what you want. It is something we need to compare the information, to compare the images. But this is definitely depends on the task, depends on what kind of image features you are to compare. So with the information from another image, so instead of the only one recognition for a single modality F1, we can take some kind of image features. T is some feature operators, and I compare the two image features. In this way, the image feature from F2 can be transferred to F1, and we hope this can help the image reconstruction of F1. And in a similar way, F1 can be used to help the image reconstruction of F2. So we have image features that depends on the application, and then a new thing or difficulty or challenge that we faced, how to define this image similarity between some kind of features. And in some literatures, they call it feature dissimilarity. So simply, they're just negative to each other. For feature divergence, the smaller, it means the more similar. And then the other one is the vice versa. So here is an example that if you use extra information, then the image reconstruction can be made better. So this is some the tube plates in airplane engines. It is very thin in one direction, but a little bit longer in other direction. This used to be a very difficult and non-destructive testing problem. So in one work by Schrapp and Herman, they just use a shape of these plates, just an optical imaging of this engine plates, then the reconstruction quality is significantly improved. And they have, in their paper, they have better results if they use more information. So for joint modality image reconstruction, that means we have two modalities. One is A1, like CT. Other one is A2, that means some kind of function image like a PET. Then we try to reconstruct by using information from each other so they can help each other. So that's we start with F1 and then do some instruction with F2. Then we use F2 to do some instruction for F1. So this process is an iterative process. But the difficulty is that the images, because they are from different modalities, they are not the same. It looks similar, but they are not the same. So this formulation can also put into the previous formulation is just do one iteration, one modality reconstruction, and then do another by using the information from F2 and F1 iteratively. We can also put it into joint reconstruction like this. This can be justified from the Bayesian inference approach. And by using the other possibilities for image reconstruction here, but mostly we use the maximum posterior estimate. That means we try to find the maximum or minimize them. What is our other alternatives? So there are some recent work. I don't want to read off them, but they all shows that the advantages of using the information and doing image reconstruction simultaneously or jointly, it can significantly improve the image quality. So, talking about the image similarities, that's something we need for this new area. It's related to image registration and image quality assessment, but for multimodality image reconstruction, I think it's the same for robots. The difficulties are from a different modality. That means the physics underlying is different, and they have different contrasts. And there are some features in one modality, but not in another. Like the images for CT and the MRI, that seem different things. So there's some parts that look similar, but they are not the same. There are features like for CT, it's good for bones, but MRI is good for soft tissues. And so the similarity is only partially in some regions and for some features. And for robot system, most of them have a lot of cameras. So for multi-views, they share the same issue. They have similarities, but the similarity is only partially in some parts. So for similarity measure, if we wanted to use it to help the image reconstruction, we need to have a similarity measure that encourages the reconstruction of features when there is sufficient data evidence, and avoid non-existent features to be reconstructed in another. So the most simple similarity could be from mathematics, like a matrix, or someone call it a distance. So this is very like a L1, L2 distances. But mainly because they are distances. So they satisfy symmetry and triangle inequality. But the similarity measures we want should not satisfy this. The reason is like this. So this is a basic definition for matrix or distance in mathematics. So look at the symmetry. If we have symmetry for image similarity measures, so the feature in one modality will be forced to be reconstructed in another. That's the issue with the symmetry. And for triangle inequalities, basically it means if x is similar to z and z is similar to y, then x is similar to y. That means it's transitive. But this is not good for this image reconstruction from multimodality, because they will introduce cross-talking that we do not want. So if we remove this requirement for symmetry and also triangle inequality, then we come to this very general definition called parametric. And if it satisfies this, that means it's a divergence. And this parametric, this word, when I give this presentation, many colleagues ask me if it's a typo. But I have contacted a translator for this book from Russia, and she confirmed that's a good translation for the original Russian word. That's parametric. And it does not have symmetry. And there is no triangle inequality. So that's good for our applications. So when we come to this, there are a lot of divergences. The most famous one is C-F divergence, and among them is the Kullback-Leibniz divergence. It's a very general definition. And if we choose this function fr, we come to this Kullback-Leibniz divergence. It does not have symmetry. It does not have triangle inequality. It looks good. But the big family of this divergence, this is just a very short list. And there, if you go to this book, you can find that almost infinite. So, and also from the perspective of this matrix or mathematical topological theories, this symmetry or the universe symmetry is typical in some fields, like a traveling coast from A to B and from B to A could be different. And Professor Smith, he is working on geographic planning. So he studied this problem many years ago, and he created a theory for it. I think this is also useful for robotics. If it's moved from A and B, it could be different. So we need something that's not symmetric. That's good. And but the problem with this divergence is a little bit deep in mathematics. So triangle inequality does not hold if this function satisfies this. This works for entropy and Kullback-Leibniz divergence. And then the problem is that if we wanted to define some kind of a topology in mathematics, we start with this epsilon balls here. And in mathematics, they use these small balls to define open sets, and then define neighborhood. And inside this small ball, there is another point, psi. And the divergence from psi to mu is infinity. And each of these, mu, lambda, psi, they are very close to each other. But the last one, psi, to the first one, could be infinity. That means if you are stating under the point mu, there is some danger neighbors. The divergence from it to itself could be to mu, first point, could be infinity. So one colleague told me when he was doing some computation, he has this unwanted issue. That means the algorithm could not be stable. That's the problem with this divergence. From a topological perspective, you have dangerous neighbors. And so in mathematics, some theories try to comment this issue, but like in Harimo's work, it defines several kind of convergence and topologies, but so far, to my knowledge, they are not tractable and easy for implementation or computation topology. So we do not have a good choice. So let's look at from another perspective, psychological. So Tversky is a very famous psychologist. So in one of his, in my opinion, very important paper, it's called Feature of Similarity. And he argued similarity should not be symmetric. That means it is directional. And it depends on the feature strings. So here is some example. So basically, the variant is more similar to the prototype than vice versa. So we see the son resembles the father, but not the father resembles the son. And there are many examples in his paper. It's about the symmetry from this perspective. And how about the triangle equality? So here is some, because if we have a triangle equality, that similarity is transitive. So Tversky gives some nice examples here, like Jamaica is similar to Cuba. Cuba is similar to Russia, but Jamaica is not similar to Russia at all. And if we look at the image applications, for image reconstruction, so a kid could be similar to his father and his mother, but the father and the mother are not similar at all. Now here is another example from a paper by Phil Camp. So if we look at these three images, A is similar to B in some parts, almost the same, and B is similar to C from the tails, the legs, but A and C are not similar at all. So that means triangle inequality should not be addressed for image similarity. So in Tversky's paper, it's here. So he studied this similarity problem among other very mathematical approach. He proposed some axioms about similarity measure, but for binary features. For binary features, that means it could be either 0 or 1. So one example is image age. If there is an age or there is not an age. And then the axioms is very involved mathematically, matching, independence, solvability, invariance. And then heuristic successfully proved mathematically the similarity must be of the following form. So A and B are two sets of binary features. That's just the sets, like for image, that's the image age sets. So basically it says the similarity is the contribution from the common parts, but minus the different parts, A minus B, B minus A in set operations. And the theta set to parameters, constant. I'm sorry, here it should be in another way. It's A, the union of A and B. So P is some kind of measure satisfies this condition. This is a very important work. If you go to psychological literature's Tversky's feature contrast model is very famous. That was applied to image similarity for joint image reconstruction. For image set A, for the set A and B, we simply choose K1, K2 to be the edge sets from each modality. Like for CT, we choose an edge set from CT, and for in our applications, diffuse optical tomography, and we choose an edge set from a DOT. And for P is just an cost of measure, basically an edge length. Then we find a similarity measure, because this S here is a dissimilarity. And if we want to use a similarity, we take a negative for it. And there are some other image similarity measures too. So like, we know, I think if we are working on image processing, you must know total variation. And for two images, they just take a vector total variation. That's one image similarity, but it's symmetric and satisfying a triangle inequality. And there are also high order vector total variation, and there are also more intricate formation called the nuclear norm. Basically, they represent L1 norm by another norm. And there are other famous work is called parallel level sets. And so this one we developed by using Taritsky's work, could be some kind of generalized Manford-Shah function. And there is another very involved construction is called the infimum convolution for Brigman divergence. Those are, in my opinion, most impressive image similarities for image reconstruction. So if you need more detail, I have recently finished a review on image similarity measures. There could be more details there. So in summary, I just talked about joint multimodality image reconstruction. I think it's quite related to image fusion for robotics system. And the similarity depends on task and features. And I discussed the similarity measures from this mathematical topological perspective and the psychological perspective. And by using Taritsky's general feature contrast model, we can have a generalized Manford-Shah function. And there are a lot of work left. Like Taritsky's paper is only about binary features. What happens for non-binary features? I have no idea about it. And what happens if we wanted to compare multiple features? And also about the performance and the evaluation of all the image similarity measures, that's very difficult because it depends on a lot of issues. So if I have time, I could talk more. And also these similarity measures could be served as loss function for neural networks. That's a very active area nowadays. And I get the permission from Kumar that I could do a little bit of advising about this general things and imaging. This published paper on things and imaging by Spring and Nature. And we welcome your submission, and also we welcome your proposal for tropical issues. Actually, now we have a proposal from India about a special issue for things and imaging. Thank you for your attention.
Professor Benkia?
Yes?
Very interesting, exhaustive. Multimodality image reconstruction is very significant in robotics.
Yes, I'm hearing.
Yeah. So, very, very valuable. Now, the participants can raise their questions. Now, we welcome the participants to raise questions to Professor Benkia.
Thank you very much.
Thank you.
Thank you.
Sir, good morning, sir.
Yes, I'm trying to stop sharing. Oh, here. Thank you very much.
Participants, please ask questions.
Good morning, sir.
Yes, sir.
Yes, please.
Please, sir, how to find performance of similar and dissimilar image in joint multimodality image?
Please again.
How to find performance of similar and dissimilar image in joint multi-image?
You mean the performance? Do you mean the performance of this similarity measure? And not of noise.
Dr. Kannan, please ask your question again.
Here, sir.
Unmute, please ask question again.
Here, sir, how to find performance of similar and dissimilar image of joint multi-modality images?
Yes, so that's very difficult because it depends on a lot of, factors. First of all, it depends on your application. How do you evaluate the image quality? And also it depends on the implementation. And also it depends on the data quality. That's not easy to compare. That's not easy to conclude which one is good, which one is not good. So in my talk, I have shown this very simple vectorial total variation. It's symmetric. It satisfies the triangle inequality. It's not good from my perspectives, but nevertheless, it has achieved good results. Because you can also tune the parameters, the recognition parameters. And also if you put it into an iterative framework, how to choose the iteration numbers. That's also something that will influence the performance. It's quite complicated. I'm sorry I do not have a definitive answer to say which one is good. It depends on how do you use it. I hope I answer your question.
Sir, triangle inequality is the best method for find performance, sir.
Which one?
Triangle inequality.
Triangle? Yes. I don't think that's something we need for image similarity. The only thing is that it's good for the mathematical theory. And if you have a triangle inequality, that means the image similarity measure is uniformly continuous. That could be good, but it may not be good. Difficult to say. I'm sorry. That's because of my limited knowledge.
Thank you, Professor.
Oh, thank you very much for your question. Yeah.
Thank you, sir.
Thank you.
Questions from other audience? Thank you, Professor Mingyong.
Thank you, Kumar.
We see you later. Now we move on to the next presenter. The moderator is Dr. Yalini. Please come forward and please introduce the next speaker.
Okay, sir. Hello. Sir.
Yes, audible.
Is audible, sir?
Yes, audible.
Okay, sir. Shall I start, sir?
Yes, please start.
Okay, sir. Good afternoon to everyone. Now we have the privilege of listening to Mr. Nigel A. Jacob from Nebula Robotics, Mumbai. The title of the presentation is Robots for Automotive Applications. The Nigel Jacob has that rare and desired ability to turn original ideas into business that both innovative and profitable. Just 18 years old, he is creating heliotropic solar tracker, and he has won the Innovators Award from B.A. Shiva Ayadurai. He then began developing projects in various disciplines to have wider expertise in different subjects. He has extensive knowledge and experience in the robotics and e-commerce space and his company. Nebula Robotics has developed and delivered robotic projects for more than 500 companies in India and worked with Indian Defense. I request you to start your session. Welcome, sir. Hello.
Yeah, hello.
Mr. Nigel A. Jacob.
Hi.
Yes, sir. I request you to start your session. Good afternoon. You are welcome, sir.
One second, huh? I'm just trying to
Yes.
show my presentation.
Please take your time. Okay.
Okay, sir.
Okay, am I visible? Hello?
Okay,
Yes, you are visible, Nigel, yes.
Yes, sir.
Hello?
Your presentation is visible, sir.
Okay, I'm audible also, right?
It's audible. Okay, sir. Okay.
Good afternoon, ladies and gentlemen. A warm welcome to me as well. It is exciting to see the excitement in youth talking about what robotics can do to the world and how the world is changing. I was asked to talk about robotics and how technology is developing. So let's get started. I'm the director of Nebula Robotics, a robotic company that makes robotic arms. So the story behind Nebula Robotics. Nebula Robotics is a result of focused innovation, targeted primarily at micro, small, and medium enterprises, being relevant to large manufacturing industries as well. Our robots have taken a quantum leap and will revolutionize industrial manufacturing in India. We call it robotic evolution, and we welcome you to join. The robotic evolution, like the industrial revolution, is aiming to change the manufacturing scenario. Our robots are designed to address the pain points of the industrial users. A product that is easy to use, reliable, and easy to maintain, with an objective to take away dull, dangerous, and dirty work from people, so that they can concentrate on higher level of work. We have made our robots so user-friendly that anyone without any previous robotic experience can effectively operate it. A majority of Indian MSMEs are yet to realize the advantages of using an industrial robot. Their view that robots are for big companies has to change. Our effort is to change the manufacturing ecosystem so that not only large but also micro industries can operate their operations, which would complement the people force and give them an edge over manufacturing. Looking forward, We believe that success is not an end game. It has to be earned every day through consistent passion, dedication, and hard work. We will continue to develop and leverage innovative technologies with breakthrough ideas to stay future ready and to achieve market leadership. Interestingly enough, it is not the first time in the world where we have a new technology which has huge benefits but also potential hazards. When cars were introduced in England in 1862, there was a law stating that you had to walk in front of a car with a red flag, warning pedestrians, there is a car coming. This kind of approach takes away all the benefits of technology, but at the same time, it might be necessary to gain acceptance of technology. Because if these first cars killed people, you wouldn't be riding around in cars. So it's this ongoing battle between acceptance of society and harvesting the benefits of technology. So let me get you how our robots are changing the world to some degree. There's always been a relationship between man and technology. I would argue that what is being human is use technology. This is what makes us different from animals. And in all of these, we view human evolution. Technology here is a spear, the iPhone, and the iPad has been an integral part of the evolution of humanity. I have given a detailed talk about how art has inspired technology. You can view the video later on the link shown here. So, at the same time, we have used technology to represent art ourselves. Here is an example of a painting on a cave wall, which is basically our desire and understanding to understand ourselves through technology. Doing our work more efficiently with technology has been always the way, be it the fire, the wheel, all these technologies which augment people and allow people to do more work with our energy and our time. So robotics started with art. It was Da Vinci's experiment with mechanical statues, moving to industrial robots in the 1960s. So robotics started with art, but ended up as an industrial equipment. If you want to know about how art has influenced society, you can see the previous link, like I mentioned here. So I'll just briefly touch on the Industry 4.0. Industry 1.0 was the Industrial Revolution. The steam engine that replaced animals and humans, the rise of Europe, the rise of machine age. So the first and second happened within 100 years. Industry 2.0 was the electrification and assembly lines of Henry Ford. Till now, people walked around fitting components and everything else. Now, an assembly line was brought where the assembly line was moving and the people stood still. And you got the parts. You put it and you became a widget. This dramatically increased productivity. It also expanded the supply chain because you had sub-assemblies, assemblies coming all over the place. This happened again around 100 years of the third one. Industry 3.0 was the CNC and PLC machines, where you had this machine which is automated to a great extent, and the machines would work by themselves with the human controller. So he didn't have to cut the machine. The machine followed the path and it executed it. This happened in around 49 years. Now in Industry 4.0, the entire floor is getting automated, where you have robots doing the work on the shop floor connected to the internet, and the robots make sure things happen on point. The welding, the paint shops work in an automobile factory, and the entire dealer network and supply network is connected by IoT and ERP. That means the front end and the back end. The front end being the sales, and the entire production being updated depending on the sales forecast. For example, if you go to BMW site, there is an option where you can customize your car that is fed into the production line that makes sure your smaller bespoke batches depends on data so that you can have smaller runs, flexible output, and dramatically change just-in-time manufacturing to do that. In the backend, you have a series of sensors in the manufacturing plant to make sure that the part comes on time, the part goes on time, and the quality is maintained. So what you see is a level of automation that has gone up maybe 5x with robotics, AI, predictive analytics, right from the consumer. If you want a prime example, look at Tesla. The entire factory floor is robotic. Sales is direct, and the car is gone to be a piece of software. So the data about the car, the use of the car comes to Tesla every day. And now you know where the car is, how the car is running for every single car. And in case of a crisis, you can send a software patch and change the configuration of the car. Let's say where the speed is cut and the battery has a long life.
Towards that, not only job.
So
whatever you do, you have a passion towards that. If you have, again, this is an animated film, all the hands will be, lot of hands will be coming out from that. So in that way, the passion will be more helpful to come out with flying colors. Another one is that we have to continuously, as a teachers, especially we are teachers, we have to update ourselves. Repeatedly, the things are in science also, in technology also. Day to day, we are not so technocrats before this COVID period, but we came to know about the Google Meet, Zoom, the Microsoft. Like that, so many things we came to know now only. So we are able to update ourselves using all these conferencing softwares so that we can reach people. So nowadays we are taking class with that. We are well versed in that activity. So in that way, we have to update ourselves then and there. Then only we will be recognized by our students. Unless we are, we cannot use that yesterday tools for today's teaching because the students are very smarter than us. So we have to, if we know more regarding this technology, because we are not only the resources for them. We have enormous, Google will be the teacher, they will ask, they will discuss with the people in and around the world. So they have more number of teachers. They will go through in the book. So in that case, we will try to polish ourselves. Then in a 24 hours day, we do a lot of work. We'll go for a job, we'll go for the TV. With all the work, we have time, we go to sleep. In that 24 hours has to be divided by each and everyone according to their nature of work. So we have many chakras in our body. Those chakras to be for the stomach, for the growth we are eating, the nutritional food express. Same way for our mind development, these chakras should be given nutrition. So around us, the magnetic field is there. So from that,
participants please mute except speaker. Participants please mute.
Can give nutrition to all these body through these chakras. So in a day, at least, because we are busy with all these activities, for some time, 5 minutes, 10 minutes, 20 minutes, whatever is possible for you, you have to try to be calm enough.
Participants, please mute yourselves. Participants, please mute yourselves.
All participants, please mute yourselves except speaker.
To make
us mute participants.
I have heard and I have read also, every individual is having aura. But
I
please mute yourself.
I mute all, but someone is giving some mischievous things, I think.
Aura miles away from him. So like that. So we have to extend our aura through this. I cannot say that meditation, but you first start doing this as a calm, quiet sitting. Afterwards, we can do the rest of the things. So the
Participants, please mute yourselves.
What of this? Initially, you got.
Next is the rapport. So rapport development is because we are the social animal, we have to live in the society. So it is the basic requirement for us to develop a rapport between people.
So as part of that, you can see here the complete image is being reconstructed back without any cropping.
We have to develop the rapport between those people. So in that case, we is a positive mind.
Image that is shown in
Everything, all these qualities, when we are positive, automatically develop. We don't find fault with it. We try to accept the people as they are. Next is the social stigma. Most of the time, we don't believe in ourselves. For example, if we fell down somewhere, immediately we'll get up and we'll look around who are all watching us. We don't see what has happened to us. We have any hurt or we have any... That
Hello? Mute yourself. Hello?
What we do...
Hello, please mute yourself.
For others only we are doing.
Hello? Please mute yourself. Hello? Please mute yourself.
What I am doing for me.
Please mute yourself. All of you, please mute yourself.
But sir, you can mute
as we
the participants, sir.
Dr. Kumar?
Like it. But so we have to think in whatever. We have to think twice, thrice, whatever the possible. So,
Hello.
all those things,
All participate.
then only you have started doing things. But if anybody is, whatever you do,
I mute all, even then someone is doing unmuting. Again and again. This is the problem. Not all to talk on this issue. Please.
It is simply filthy people
I
are there.
mute all, but that mysterious person is doing unmuting again and again. This is happening.
So we have to get rid of that social stigma and stress.
Sir, Kumar sir, please change the host to me. I will mute all the participants.
One is stress.
I mute all, here and then someone is doing. I mute, I am doing that.
Scientific advancement. There are lots and lots of gadgets have evolved. Those gadgets for example, electricity. Oh.
Please proceed, Elijah Jacob.
Okay, shall I go ahead?
Yes, sir.
Yes, please proceed.
Okay. Mr. Elijah Jacob, please continue.
Okay. Okay, so where I stopped is, so Industry 4.0 is automation to an extreme chain in the supply chain, in surrounding systems, and in the heart of manufacturing plants. So if you look at whichever country participated early in the industrial revolution, they became world leader. So if India has this dream of becoming the third largest economy, then India has no option but to not only participate, but be the front runner of the industrial revolution. The thing about Industry 4.0 is that you need an economy which is not demand constrained. India is not demand constrained. We now have a national market because of GST. Our cost of logistics has fallen from 14 to 6 to 7% because you have a national market. then we have the IT skills and technology skills in abundance in this country to make the transition. So we are not a country starved of IT and technology to automate and get into robotics and do everything else. Next, for robotics, we need to get these devices also. The cost of manufacturing has come down so dramatically low that China can supply to us for the rest of the world because we don't have to manufacture because the cost has come down and we can do some of the more sophisticated software settings. For example, the embedding of chips. The embedding design has become very expensive that the chips have become very low cost. So we can do the design. Now in Industry 4.0, there will be a distributed manufacturing. Industry 3.0 was about centralized manufacturing. Like I said, 3D printing. Let's say I wanted a car. So I got a who designs a car in 3D for me, the way I want. All right. Then I go to my neighboring shop, which is next door to me. He's got a 3D printing machine. He'll print out the entire car for me. So you can have the distributed network all over the country where metal powder can come and this can be used. So we have the design. So now we have to rethink. We have to do it massively. Till now, India has had a disadvantage so far in manufacturing because we are not part of the global supply chain. Now the global supply chain is getting disrupted because it is getting very expensive and you can have direct selling B2C. Immediately bespoke in moment's notice instead of a long chain. Even how a country has reacted during the COVID situation is a very big example of it. Another real life example. A 3-year-old company which was competing on a defense manufacturing global tender in which it is competing against American, European, Korean and Israeli firms. And the youngest of which was about 50 years into the systems manufacturing. The tender was, once the system was deployed, the bid was being evaluated on the lowest life cycle cost. This Indian firm went and said, instead of supplying spares, we'll supply you a 3D printer which can be deployed on the field. You know what was the life cycle cost differential when the bid was opened? It was 60%. The Indian firm was cheaper by 60% despite having an age disadvantage of 15 years. Despite having very little credentials to prove it. It was still able to win the global tender, and this also proves one more point. In this automation business, 10 years back, when you went to a supply chain guy, he said, listen, quality is given, let's talk about price. Today they say automation is given, let's talk about price. So we know for a fact the world is shifting to a modern manufacturing. We can also see that the driver behind this is Maslow's hierarchy of needs. It's no more about having a dry place to sleep in the winter or getting enough food. It's really about self-realization and getting new exciting experiences. And this is where humanity is moving because of this technology. So the point is, we are not losing our jobs to robots. It's a big scare that happens. We always use technology to take us to the next level. We can do with robots, what we can do with robots is spark human creativity by allowing people to express more what they want to be known for. This is what we see with our robots as well. It is a tool to help people get more work done efficiently. We can see from various industry studies this combination of man and machine. This is most probably in robotics, but also in other areas. If you combine humans and machines, you get some significant value there. There are 4 or 5 aspects of industrial revolution, whether it is capital formation, whether it is technology disruption, research, whether it is government policies and creating the infrastructure. We're doing a pretty good job in India. And there are a number of examples in each one of them. And then, of course, there is a lot more that can be done. But we are at least in the right direction. One thing which disturbs me, and the reason for that anxiety is, if you look at the Indian demographic, we have a huge amount of young population. But if you analyze the population a little deeper, the number of engineers who are coming, are these graduates hireable? More often than not, they are not hireable. So while they are getting a degree, but the education or the degree they're getting is it useful for the industry as of now, let alone for industry 4.0? Secondly, if you look at the workforce, less than 5% of Indian workforce is skilled labor. While if you look at Korea, which is at the other extreme at about 96%, or even China, which is at 24%, so that is one area. While we are working on it, we cannot afford to spend 10 years on that. We need to get that right. I mean, whether it is online training or mass open source, which is available, that is one area where we need this, and we need to be a little bit more faster doing it today. I have started 2 initiatives I would like to share with you. We are doing 2 things to accelerate this. One thing is we are creating a robotic platform. Basically, we are opening our platform so people can experiment with our various solutions online and figure out their use cases. Also, so that our platform can add technology to it. This essentially allows small freelancers and small businesses to contribute to our ecosystem and create added value per se. This also lowers the technology barrier for our end customers. Another activity we are doing in our academy, where we are planning to do training on our robots and taking an exam, and they get a certificate. What it does is it takes people from working like robots and instead become robot programmers. At the end, I would like to share a few robot applications that I've never seen commonly. Some of these things are things that I couldn't even imagine a few years back. Firstly, robots at the Olympics. Robots are used to record the track and field stadiums and also swimming stadiums. I think this was in Olympics in 2017. We've also started to see robotic surgeries, where you have pinhole surgeries, where your recovery time is much higher. Robots used for physiotherapy and ultrasonic and massages. Robots used for rehabilitation. Robots being used in TV studios, using robots for special effects as R-cams, where you can have a small studio and you can have a green screen and have all these really beautiful or crazy effects. Robots coming into construction sites. Robots in kitchens, where you can text your kitchen on the way home from work. And this robot will start cooking for you in the way the best chefs cook. And these are not ideas, okay? These are already being rolled out by companies. Robots landing as a co-pilot, landing a plane as a co-pilot. Robots being prepared to build our houses on Mars. This is already being done in NASA. Robots being used for building robots. We are currently preparing our own plants to start manufacturing robots themselves. Robots which are used in lights out factories, where robots work continuously without human interventions for 72 hours to 1 week straight. Basically, you have raw materials go in from one end and you get the final output from the other. So basically, what we can see here is a new era coming of how man and machine. So the point is, it's not man against machine or man or machine, but basically the combination of man and machine. Before I hand over the session, we are shaping Nebula as a technology leader for digital industries and as your partner of choice to get the benefits of digital industrialization. We are ready to work with you, but we also know that especially in the next phase, where collaboration, skill development, and jointly working makes a big difference. I look forward to writing the future together with all of you. Thank you very much.
Very nice presentation, Mr. Nigel Jacob. Excellent. Audience, please, only one question. Now we are running out of time. Participants, please raise only one question.
Mr. Nigel, how does Nebula Robotics contribute to the robotics technology? Could you please say a few words?
So we have our own R&D team, and also we tie up with startups, and we are looking for college collaborations where we try to roll out all these experimental work on our already proven industrial robots, such as like I said about the predictive analytics or predictive maintenance, where these are concepts which are being worked on the software side. But we once we are collaborating with these universities we could actually roll it out in actual to the industry, since we already have quite a big industry connect.
Prist University would like to collaborate with you in future.
Definitely. Looking forward to that.
Thank you.
Thank you very much, Mr. Nigel Jacob.
Thank you. Thank you.
Thank you. Thank you. Dr. Yalini, please take care of the other speaker.
Okay, sir. Hello. Hello. The next speaker is. Good afternoon. Good afternoon to everyone. Next, the speaker is Rabinder Henry. Good afternoon, sir. I have immense pleasure. I have immense pleasure in introducing Mr. Rabinder Henry from ST. He has a doctoral degree from VIT Vellore in electronic engineering. He has a Master of Science in RF and Microwave Engineering and Photo Technical University, Dresden, Germany. He had completed his Bachelor of Engineering from University of. He has played many roles in his professional career as researcher, professor, chief technical. His thrust area of work has been in transforming the education system, especially in schools and higher education, by making it more applied intelligence oriented. I request you to start your session, sir. Welcome, sir.
Hello, ma'am. Can you hear me?
Hello.
Hello.
Yes, sir. Dr. Rabinder Henry, we can hear.
Yes. Yeah,
please,
I am just trying to share my PPT.
Yes, sir. Yes, sir. Please share. Take your time.
Yeah. It is taking time to load, so just hold on.
Okay. It can take time. Okay. Participants, please mute your mic. Other participants, please mute your mic. Even though we mute all, yes, sir, please, you continue. Even though we mute all, some mysterious things happening. I made mute all. Even then, it happened. Sorry for this inconvenience.
So have you made me the host? I am not able to share the PPT.
Sir, you are presenter, sir. You are presenter.
Okay, just 1 minute. I am trying to share, but it's not happening. Just hold on.
It will happen. Rabinder Henry is made as presenter. If you find difficulty, you move out, then again relog in. That way also could work.
Yeah, I'm finding a difficulty. Just hold on.
Yes, we wait. You go out and again log in back. Again sign in back.
No, I'm not able to see the share window. That's what I'm searching for.
There are three dots. There you keep, there more options. There you can do all. You can.
Right. I'm not able to see. No, I have used it many times, but the options are not coming.
Yes, yes. So the share content, that the Afghano is there, you can see share
No,
content.
my role is the problem. I think you have to check once more whether my role is correct or not.
Your role is present there.
Only now. Okay, now I can check.
Yes, yes, yes. Your role is present there. No, it is.
No, but the share option is not coming. That's what I'm checking. Switch to desktop, connect to the device.
Entry present there.
Yeah, 1 minute, 1 minute, 1 minute.
Yes, yes. It's very well appeal. It happens sometimes. It happens
Yeah,
sometimes.
I'm not able to share my window. 1 minute.
We can see mic symbol, then video logo, then that share content, that icon, and
No,
the
I'm
time.
not.
Okay, take time, take time.
Hey, sand is there. Oh, just hold on.
Okay, okay, okay. No problem.
Hello.
Yes, yes. Have you found out? Have you
No,
resolved?
I'm stuck.
What you
No, that
do, you leave meeting, then again re-enter back. You leave meeting, again re-enter back. Sometimes that will work very nicely.
Okay, okay, I'll do that. Yeah. The PV is equal to nRT equation, that is the basis of all chemical reaction that can be done by a basic unit. Since we are using 3D printed parts with the embedded hardware, it is very lightweight, and this is going to be interfaced with the mobile platform. So you can do and we are going to connect it with the digital microscope. It is already being done, and these three things which can make a small mini synthesizer or a bioreactor. So in the cost of 5,000 rupees, a child can do the complete volumetric analysis at his home without coming to a school. So that is the main. He can self-learn, use the mobile as interface, and execute the ideas. So that is my first part, and that is what we have done as part of my STEM zone. And my second part of my presentation is basically about cognitive technology, which is my basic research, where I've been developing polymer implants for brain to access the surface cortex neurons, so we can take data and interface with the brain. So you may ask a question, how this is relevant to robotics, but this is the future, and this is what is cognitive technology. So basically, the cognitive technology has two basic aspects: neuroscience and cognitive science, neuroengineering and cognitive engineering, and neurotechnology and cognitive technology. So basically, now, if you refer the paper by the group Daniel T. Simpson, they are talking about developing artificial neurons. So the robotics can go to the next level of intelligence. So they call it as inatronics. And then we have organic electronic biomimetic neuron systems. So in this category, I am specifically working on brain neuromodulation. What we can do, basically, if we can get data from the brain, then interface with the digital hardware, we can have a complete circulatory system, and that way we can control the signals and what can be interfaced.
Sir, please continue. Something happened. So please continue. Sir, please continue.
structural aspect of the neuron, especially the conductivity aspect of potassium, chlorine, sodium, so that we can address most of these issues. So that is optogenetics. The current work that we are doing in Europe, especially in my university in Ottawa, Warwick University, is a polymer-based bioimplant which will have a LED photodiode and a wireless network implanted on the surface cortex of the brain. The space available for this implant is 2 millimeters, and within these 2 millimeters, we are implanting the complete LED photodiode and the circuit so that we can manipulate the conditionality. I cannot show the picture, but we have already developed a neural interface in polymer, and this neural interface has it is roughly 400 microns by 400 microns, and once you place it on the brain cortex, we can read the signals from each individual neurons, and then we can plot all the neurons together, and this is what we are going to interface. We have not started, we have only started animal trials. We are yet to move to human being trials. We hope in another 10 years we'll be there, so we can produce a world-class enabling technology for brain-machine interface. So that's my presentations. Any questions? I'm sorry, my PPT is not getting shared. There are some issues with the WebEx on the browser. So if you have any specific questions, you are welcome to type it on the chat box. Thank you.
Thank you very much, Dr. Ravindra Henry.
Thank you.
Very
Thank you. Welcome.
instructive, very wonderful. Audience, participants, please pose questions. Please raise questions.
Sir, good morning, sir.
Good morning.
Good afternoon, sir.
Good afternoon.
Sir, how to produce numeral interface by polymer, sir? It is printed by any 3D printer?
Yes, we are using a silver 3D printer from a Treeback system from USA. So we can print silver nanoparticles and gold nanoparticles. That is, the tracks can be developed on the polymer. So we can develop the connectivity circuit for embedding the hardware on the polymer. And the polymer is roughly between 20 microns to 60 micron in thickness. And we are having a sandwich structure. There is a top layer and a bottom layer. In between, the circuit is present, right? And for this, we are using 3D printing technology. Yes.
Thank you very much.
I hope
sir.
I have
Very
answered.
informative.
Thank you, Ji. Thank you, Ji. Yes, yes, yes.
Any other question? Still time we have. Still time we have. Education is a leading role. Sir, what are the difficulties you face, sir, while developing your model?
For the school education, for the school education is bringing down the cost, because we are not producing many of the components in India. Most of them has to be imported, that everybody knows. So that is a major limitation in developing low cost robotics for school education, because we have now pricing it around 5,000. You can get the complete box. It has all the units. You no need to go to school. So we are calling this concept school to home. So the complete box comes, which is as per the national curriculum. All the chapters have individual bots. You can assemble the bot, and then using your mobile interface, you can control the bot and learn. For example, if you want to plot the acceleration equation for 6th standard, you can make your own car, assemble it, interface with the mobile, and plot the equation. Instead of watching a simulation or by hearting a formula, you can implement it practically. So, but the major problem for us is cost of the components, and that is a major issue. Yes.
Other participants? Still time is there. Yes, please.
Okay.
Other participants, please ask. Time is there. Sir, do you have a plan to organize India level Olympiad for promoting motivating STEM education?
No, sir. We don't have any plans, but it has to be done. We are just a company. It has to be done at the university level. We can't do it. Yes. Yes. Yeah.
Dear participants, certificate don't standard. The STEM move, take it, everything, understandable learning.
Okay, thank you.
Not to be hesitant. Thank you very much, Mr. Ravi Secretary.
Thank you, Dr. Kumar. Thank you. Thank you very much.
Please come forward.
Thank you.
Hello.
Yes, Dr. Yalini, please come forward.
Can I start, sir? Good afternoon to everyone. I am delighted to welcome Ms. Padmaja Badadri from Academic Director and COO, Next Generation 3D, Chennai, India. The title of the presentation is Robotics in 3D Printing Part 1. Please, could we kindly request the speaker has to introduce few lines about yourself, ma'am?
Hello, hi.
Yes, madam, audible. You are audible, madam.
Yeah, so great. Thank you for the introduction, Yalini. So to introduce about myself, my name is Padmaja. So we started a company, Next Generation 3D Printers, about 4 years back. We have been into 3D printing from various composite materials to plastics to metals to ceramics. And we are lately researching on, bioprinters. So that's our background. And yeah, so today's topic to start off is about robotics in 3D printing. So rather than jump to start off with the topic, I wanted to know if we can have a brief about what 3D printing is and then start off. Okay.
Yes, please. Yes, please, madam.
Yeah. So I am just sharing my presentation. Is it visible?
Yes, visible.
Okay. Okay. So yeah. All right. So sorry, there is a lot of interference.
Some mistakes. Here I do all, even then someone is doing some mistakes. Hey, sorry for the interviewing.
All right. So to start off, I'm going to start with saying what are the various manufacturing methods, then how 3D printing is currently being used, its applications, then jump to how 3D printing and robotics go hand in hand. All right. So manufacturing. So basically, when everybody thinks of manufacturing, they think about a huge lathe machine because all engineers would have attended a workshop in the first year. So they have lathe machines. Then you have your that falls under the traditional subtractive manufacturing. Okay, so subtractive manufacturing is nothing but where you take a huge blocks of any material and then you chisel out whatever output you want from it. So this is nothing but the age-old method where sculptures would have huge rocks, take out bits and pieces and make the sculptures originally. Okay, so that is subtractive manufacturing. And as technology evolved today, lathe machines are being used, CNC, completely automated CNCs and cutting machines are being used. Okay, so obviously they have some drawbacks such as wastage of materials. So the next method that I'm going to talk about is formative manufacturing. Formative manufacturing came into play when mass manufacturing started. Okay, so mass manufacturing is like millions of parts per minute. All right, so where they make a huge die and they're going to put the die in machines such as injection molding machines or sand casting machines, and this method produces like millions of parts in 1 minute, and it's going to be very, very cost effective. So anything you're going to buy at your stores today, a chair or a bucket, which is like being mass produced and manufactured, that those are all 90% made through injection. Okay, so to give a brief about what injection molding, I'll just play a short video. So let's see how this, tray is being produced. Injection molding is nothing but where you make a die. Okay, you're going to make a negative cavity of whatever you're going to manufacture. Then put that cavity into a machine and keep pumping plastic into the machine so that the cavity is filled to give your output. Okay, so this video is an example of how robotics has combined with, injection molding to make the part, then, clean out the part excess, and then, put it into a tray for dispatch. Right, so you can see that the robotic arm is picking up the finished product, cutting off the excess, and then going and dropping it in the output. All right. So this is the traditional injection. I mean, this is the injection molding method. Obviously, it has its own drawbacks. Anything like thousands of parts cannot be produced because the initial, cost is like really, really huge. So if you're going to make a die, it's going to cost you like 3-4 lakhs. And unless you're going to produce 1 million parts or 1 lakh parts, it's not going to cut down your cost. All right, so this is a format of manufacturing. The next method of manufacturing is called additive manufacturing, which came into play about like in the early 1980s, right? Excuse me. So additive manufacturing is nothing but adding layers of material to give you the output. The advantage of this method is that you can make complex structures, all right, and you can also save a lot of material wastage. So let's see a small video of what additive manufacturing is. So additive manufacturing is nothing but 3D printing. So additive manufacturing, basically what it does is, a 3D printer has something called a nozzle, right, and a base plate. The nozzle extrudes material onto the plate to make the product. And this happens in a layer on layer process. So it's called additive manufacturing. You add a layer to the existing layer and then on and on. This basically has revolutionized the total manufacturing method because you're going to manufacture exactly what you want. Right? There is no wastage happening, nor is there any, change of, since it's a precision made manufacturing, it's like, 100% accurate on the dot. So what do you need for a 3D printer to make this output? You need your design file that you would design and then make a G code from it. Again, it's the same process as how you do in your CNC machines. You convert the file into a G code file through a process called slicing and then input it into the machine. All right. So yeah, 3D printer adds layer on layer, and any manufacturing that is like less than 100 parts, 3D printing is very, very cost effective. When you go for general fabrications like subtractive manufacturing or lathe, it's really costly, right? So compared to that, 3D printing is, time effective, very short time span compared to the fabricator who's going to do your work. And also the precision is very, very high. All right. So this is just a short video of a plant pot that we made for a customer. They wanted a cartoon to be replicated as a plant pot for their kid's birthday. So that's something very unique that nobody else, at least 1 in a million people only are going to do it. So you can't go ahead and make a die for it. And neither can you use fabrication because plastic fabrication is like really, really tough. Right. So this is just a time-lapse video where we're going to see how we are using the printer to make the pot. So it's as simple as that. You just input the file that you're going to make and, get the output from the printer. And if there is assembly, you do assembly, then you do post-processing. And that's it. You have the output in your hand. Okay, so moving on. Yeah, applications. Coming to the applications of a 3D printer, major today the healthcare sector is the major user of 3D printers. Okay, they use it extensively in like almost everything. They have their organ and tissue manufacturing, they do prosthetics, they do implants. Why is it so popular in the healthcare division is that every item manufactured in the healthcare division is going to be unique, right? The prosthetic made for one person is not going to match for another person. You cannot like bulk manufacture hundreds of prosthetics with the size M, S, and L. Right? It's going to be unique for each person. And when it is unique, you cannot mass manufacture. So that's when 3D printing comes into play. So 3D printing is, you can just directly equate it to custom manufacturing, right? So custom manufacturing, when you call that, it's a very, very niche market, which niche market is applied in the medical field, right? So, I mean, yeah, organs which are being made, they cannot be replicated, prosthetics, implants. As I said, they cannot be put into mass and kept in storage and utilized. So our company has tied up with some top hospitals in Chennai. So I'm just telling a case study where the doctor just calls up in the middle of the night and says that there has been an accident. We want an ortho implant, which is to be ready for the surgery tomorrow, right? So at that point, we just, in the middle of the night, we wake up, we go collect the engineer who's going to take the CT scan, then re-engineer the whole ortho part that is to be made, and then manufacture it and deliver, right? There are a lot of, companies today who are finding it, easier to set up a plant inside the hospital rather than, have an outsources and get it done. All right. So that is the effect of 3D printing today. So there are hospitals which are having 3D printers and manufacturing parts that are to be fitted into humans. And that hospital is not somewhere in US or something. Our own Apollo hospital in Chennai has it. All right. So next, dental. 95% of the dental work in the world today is done through 3D printers. Earlier, you used to have, a very gruesome process of where you take a huge clay-like thing, put it into your mouth, and, measure your whole jaw structure, and then make braces and all for you. But today, it has become very simplified. You just have to use a scanner, scan the mouth, tell the dimensions to the person. He just replicates what you want in braces form or in, caps or whatever it is, or implants. All right. So that's about dental. Then, yeah, coming to engineering, which is, the priority for all of us. Today, all engineering companies are adopting 3D printing because they feel that gives them a competitive edge. For example, Audi, what they did about 5 years back, they revolutionized their spares manufacturing. What they did, they just said, no more spare production. Each country that we are located in, there will be a zonal or a district level or whatever the level is. They'll have a mini manufacturing unit, which is going to have a 3D printer in it. Okay. So whatever spare the customer comes up with, the requirement is going to be sent to the zonal region. It's manufactured there and it's sent to the customer. Can you imagine how much of cost it reduces? An international company which is located in over 100 countries in the world, manufacturing spares for just like 1 million cars that they're producing, keeping the spares in each of the country and sub locations inside them. So imagine if you're going to have a tire rim, which is like you're going to sell only like 1 lakh cars in a year in, say, Chennai, right? But even if 10 of the cars are going to have a rim damage, you have to have spares for that, right? So you have at least 10,000 spares, which is warehouse cost. So to cut down all these costs, they implemented this new method of mini manufacturing, and their revenue, the profits for that year increased by 10%. Okay, so that's huge for a multi-billion company. All right. So again, 3D printers are there on moon as well. You can go up Google. NASA has sent a 3D printer. They have the printer there. Manufactures whatever spares is required by their equipments there. All right. So yeah, Adidas. Adidas is a shoe manufacturing company. You can think, what is Adidas going to do with 3D printers? But Adidas manufactures its soles using 3D printers. Okay, so in 2018, they came up with a project called Futurecraft, where they make soles which are going to compress to the shape of the foot. Okay, so you see the complex hexagonal shape here. This hexagonal shape gives the wearer a cushion where it can compress. If he has a high insole, it compresses at that region, or if he's going to have a flat foot, it's like a uniform thing, right? So to implement this, they pulled in 3D printers, and they plan to manufacture 1 lakh parts, but by the end of 2019, almost 50% of their production was done using 3D printers, right? So yeah, coming to India, Telangana and Andhra, split up, and Amravati was named as the capital. At the time, Chandrababu Naidu made a township plan of the whole Amravati capital proposed, right? This is something very small. I mean, it's not a big deal, but the minute he made such a proposal, the investors who flew in from foreign that year, they made a record high investment in Amravati that year, right? So yeah, next, jewelry. Okay, jewels today are made using 3D printers. How many of you were aware of it? Like, they make a 3D model, they make a wax output of the 3D model, then convert the wax output into a actual precious metal, and then fit the stones, right? So it's as simple as that. So whenever the earlier ages where you had to have a blacksmith to make out the casing, then intricate designs into it, all of that, it doesn't happen today. Today it's just done using a printer. It's as simple as that, right? Yeah, so you can so it has touched a lot of sectors, from common household items to gifting items to engineering companies to healthcare. Every single sector which has custom manufacturing is done to 3D printers, right? So coming to robotics and 3D printing, how is robotics going to work hand in hand in 3D printing? Is that bots are manufactured using 3D printers. Again, those the bots and printers go hand in hand in a way that an industrial setup is made using printers combined with bots. So a 3D printer is nothing but a machine which extrudes material and manufactures something. Okay, so if you're going to extrude that material using a robotic arm, that's a combination of 3D printers and robotics, right? So that's one application. Then you have rapid prototyping of new bots being done through printers. Then you have smart factory creation. Okay, what do you mean by smart factory creation? Smart factory creation is nothing but when you're gonna manufacture a complete product using a combination of robotics, 3D printing, AI, computing, and VR, right? So all of these combined together, or at least 3 or more of these, is called a smart factory, right? So let's just see an example of what a smart factory is through a small video. Okay, so this video is that of a construction happening through a combination of 3D printers and robotics. Okay, so there is a company in Zurich who's actually making a construction of a house using 3D printers with robotics. So you can see in this video that the design of the the house is first made, then they use these robotic arms combined with, a printer. So initially the, the laying of the steel and all is done by a bot, as you can see here, post which concrete is poured using a printer and so on, right? So that's how simple technology has made manufacturing today. And if as difficult as a field in construction it is being utilized, then you can imagine how it is revolutionizing all other manufacturing, right? So this is a small example of a smart factory. All right, so moving on. Next we have, making prototypes using printers. So this is a bot that, entered into a competition in India in, I think 2017. This bot was completely printed. It's a human welcome bot that was made by a student group. And this bot was completely printed using this printer, right? So yeah, making of new bots. How is it useful to, a designer? It's going to make your iterations faster, cheaper, because you don't have to go to generally, typically fabrications take weeks long, right? The minimum it takes is like 10 to 12 weeks, right? So that period is cut short by 3 to 4 days, maximum a week, to make such a bot, right? So yeah, that is robotics. And how to make a bot using rapid prototyping. The last point is that maintaining industrial bots. So assume you have huge bots are put for specific purposes. For example, we saw a construction which is happening, using a bot. So tomorrow, if that bot is to be modified or, changed to another specific need, like today is going to pour concrete, tomorrow let's say it's going to say mix the concrete and gravel and then pour it. So if you're going to make some small adjustments like this, you cannot go again manufacture using the traditional methods. Those maintenance or actual manufacturing of the bots itself happen using 3D printers. All right. So yeah, so this is just a slide on evolution, right? Okay. So I have a question here posted about, 1 second, I'll just close my screen. So I have a question here saying how sensors are embedded in 3D printers, printed robots. So sensors, it's just, there is no embedding. However, you are manufacturing a normal modem, you would have a chip which has a motherboard and all, right? So similar way, sensors are fitted at particular locations. So if you want to have a bot which is going to, replicate your movement in your hand in a bot, so that you're going to have a sensor here, then it is going to be connected to the motherboard in the bot, and it's going to replicate it. So that's how embedding, sensors into 3D printers happen. But to, tell about the latest evolution in it, there are companies who are working in on manufacturing boards, motherboards, and embedded systems using 3D printers, right? So we have Siemens, who's actually manufacturing nano chips and nano motherboards using 3D printers. So this is again, a combination of 3D printing and electrical circuits and systems. Okay. So any other questions? I'm done with the presentation. If you have any other questions or queries, you can reach us at through Facebook and Instagram link here. And yeah, this is the last slide is just about stats, where you can see how much of the total revenue for 3D printers in 2019 globally has been generated in which sector. As I said, healthcare is the leading generator. Then you have consumer goods. Consumer goods mostly is the gifting sector that we are talking about here. Then comes the automobile. Automobile, again, I would say in India, Mahindra and Mahindra is a huge adopter of 3D printers. They actually manufacture the complete car before they go into production, right? So yeah, so that's about it any questions on how bots or robotics with 3D printing, I'm ready to answer.
Very nice presentation, madam.
Hello.
Very nice presentation, madam.
Sorry, sir, I was not able to hear that.
Very nice presentation, madam.
Thank you, sir.
Participants, please ask your question. Dear participants, please ask your question. Participants,
Hello. Hello.
Yeah.
Good afternoon, ma'am. I'm Yolini from a category department, ma'am. Ma'am, you mentioned about the organ development with the 3D printing, ma'am.
Okay.
What can be manufactured with the help of the 3D printing?
Yeah, so about a year and a half back, there was a doctor in Istanbul, I think. He manufactured a heart using 3D printer, and they actually fitted it into a human, and it's working right now. So heart is considered to be one of the most complex, functionally complex organ of the body.
Yes,
So if they can
ma'am.
manufacture heart, anything is possible. So tissue, though, everybody is doing it. It's very common today to graft tissues using 3D printing. Organs are in development phase. Heart is being done. Liver is being done. Then you have bone replacement or joint replacement is material for heart. Okay, so how biomanufacturing happens is that they do a biopsy. Biopsy meaning your cells. If I am the person whose heart is to be made, the cells from my body are taken. They are cloned and replicated. Okay, so if you are having 5 cells are taken out and like million cells of it are made, then you use a bioprinter and you make the part that you want. So this is very easy in liver and spleen, which is commonly done. But functionally, when you're speaking a heart has to pump, right? It has to have valves, it has to pump, it has to have arteries. So that's why that was a breakthrough, I would say, in the industry. So they made it, and it's actually functioning in a human right now. So
Ma'am, if heart can be manufactured, and which means human are immortal?
It's not immortal. You can replace organs, but there is an end to how many organs you can replace, right?
Okay. Thank you, ma'am. Thank you very much, ma'am.
Madam?
Yes.
Good afternoon.
Yes, tell me, sir.
I am Kannan Mahadevan from Christian University.
Tell me, sir.
We are design and fabricate a human new joint in ABS material.
Okay.
In the last MTech student project.
Okay,
Maybe
sir.
tested with the harness, with the man bone harness with the ABS material, but having more differences in artificial knee joint making, madam.
Okay.
What do you mean about this problem?
Can you repeat the question, sir? So you already have manufactured a part,
Yes.
a bone. Okay. So what is the query there?
The harness of human joint is different from
Manufacture a bone and then fit a muscle to it. So basically what I would say here is that a case study of humans using this is to be done, and a result of probably decades of such research is to be published before it is to be turned into humans. It's really complex. See, basically bone manufacturing can be done, right? There has been research which proves that bone can be manufactured, but bone manufactured and implementing it into the human itself is very complex because the body has to adopt to it and take it forward, right? But muscle bone manufacturing and then the lubricating mechanism of the joint is really complex. All right, so I am not the person to answer that question. There are a lot of researchers in the industry who would be better equipped to answer.
Thank you, madam. You just design and fabricate only, tested
Okay.
with human bone joints.
I would.
Thank you, madam.
You can, if you can, you can just send a mail of the project to me. I would be really interested to read about it.
Take an X-ray and then converted into image, digital file, and finally printed by ABS material.
Okay.
It looks like a human bone joint without any deviation.
Okay.
But it cannot be adapted in.
That's basically an anatomical model. That is being done. Anatomical model for surgery is very common.
Yes. Our part is only fabrication only, madam.
Okay. Okay, that's.
Thank you, madam.
Yeah.
One more minute is there. Any participant having the opportunity? One more minute. I think 1% possible. Please. Participant, one more question, if possible. 1 minute is there.
Sir, I'm only sir. Hello. Good afternoon, ma'am.
Yeah, good afternoon.
Is not 3D printing time consuming process, ma'am?
What you're comparing it. It is time consuming, but the time is getting reduced as the machines evolve. See, for example, about 20 years back, it used to take 10 hours to make a part. Today it is being done in 1 hour, and it is still further reduced. Okay, so it is time consuming depending on the complexity and method of manufacturing you can take.
Okay. Thank you, ma'am. Thank you.
Thank you very much, Basmaja madam. Thank you very much. Excellent presentation. After your name, Mr. Sai Kumar is there. Sai Kumar is scientist. Thank you very much, Basmaja. Thank you.
Thank you.
Sir. Hello.
Yes.
Sir, can I start the next session, sir? Next.
Yes. Start.
Oh, okay, sir. Good afternoon to everyone. I have immense pleasure in introducing Mr. L. Sai Kumar to share his valuable knowledge about robotics in 3D printing part 2 with us. Could we kindly request the speaker has to introduce few lines about yourself, sir?
Speaker just left. He joined back.
Sai Kumar, sir.
Mr. Sai Kumar, he was appearing. He would rejoin. Expected to rejoin. Mr. Sai Kumar is expected to rejoin.
Oh, okay, sir. Okay, sir. Okay.
Followed by Ms. Basmaja, Sai Kumar has to join, and I will confirm. He joined and he left out. We wait for his joining back. Anyway, meanwhile, I confirm with Basmaja madam. Okay. Sorry for the inconvenience. participants, bringing back the Sai Kumar is in progress. Sir, Mr. Sai Kumar, you are welcome. You are assigned as presenter. Sir, Mr. Sai Kumar, you are assigned as presenter. Welcome, Mr. Sai Kumar. Mr. Sai Kumar, you are assigned as presenter. Sir, Sai Kumar, sir. Hello, sir. You please unmute. You please unmute. Sir, Mr. Sai Kumar, sir, please unmute. Sir, Mr. Sai Kumar. Dear participants, we have connection problem. We got message. We got personal message. We got connection problem. We connect soon with Cisco WebEx. Sorry for the inconvenience. Sai Kumar, Mr. Sai Kumar has joined. He has some connection problem. He will join. Sorry for the inconvenience, dear participants. Dear participants, he will join. He will join. We communicated. We are in touch with him. We are in touch with Mr. Sai Kumar. joined. Welcome, Mr. Sai Kumar. Mr. Sai Kumar, please check your audio. Please check your audio. Please check your audio. Sai Kumar is making attempt. Mr. Sai Kumar is making attempt. Mr. Sai Kumar is assigned as presenter. We are looking forward to hear the continuation of 3D printing. Dear participants, we are waiting. Yes, we are waiting.
Hi, sir. Let's just, I'm just trying to put a call between the WebEx and this thing. Can you see if he's audible?
Yeah, you are audible. You are audible.
Okay. Sai, can you speak?
Okay, sir.
Yes, audible.
Okay. Yeah, sir. Basically, I will tell you what are the parameters, common parameters to print in your robot or something else in a 3D printer. Common parameters, generally common parameters.
He's audible, right?
Can you able to view my screen, sir?
Yes, we can see. We can see. Mr. Sai Kumar, we can see.
Yeah, he can see, Sai. You can continue.
Yes, please continue, Mr. Sai Kumar. Thank you, madam. Thank you very much, madam.
I am sharing you my screen. This is the software in a 3D printer. So initially, we have to load the file into the software. So first thing we have to choose is the orientation. Orientation is the main parameter in 3D printing. Orientation means if we can print the part like this also, we can choose another orientation like this also. But we have to choose what is the best orientation for this part. So for this part, I would say the best orientation is this is the best orientation, so that we can make the part little so we can avoid this. So first thing is the orientation. Second thing is the layer by layer process. So layer by layer process is nothing but this 3D printing process is completely a layer by layer process. First layer, second layer, third layer, layer by layer process. We have to give dimension for the layer. I mean the thickness of this layer height. So layer height varies up to 1.1 to 0.35. From 100 micron, 300 micron, we can give the layer height for this to print the part object. So why maximum limit is 300 micron means we have nozzle in the machine. So that nozzle dia is only 0.4. So we should not exceed more than 0.3. So that's why we are keeping maximum layer height of 0.3. Sir. Sorry. Hello. Hello. Hello.
Yes, proceed. Audio, video, proceed. Yes, yes. Yes, yes, Mr. Sai Kumar. Yes, everything is fine. Everything is fine. Everything is okay.
Sir, am I audible, sir?
Yes, yes, audible.
Okay, sir. Okay, sir. I will share the screen. I will share my screen. 1 minute.
Okay.
Okay. Can you see my screen, sir?
Yes, yes, we can see.
Sir. Okay. As we said, first thing is we have to choose the best orientation for to.
Voice message. Voice missing. Audio is missing. Please try your own audio. Please try your audio. Since I unmute, lot of noisy. You please take your audio microphone. Use your microphone on. Mr. Sai, please unmute your microphone. Mr. Sai, please unmute your microphone.
Hello.
Yes.
Am I audible, sir?
Yes.
Okay, sir. Okay. Shall I start the procedure?
Sorry for the inconvenience. Okay.
Okay, sir. This is the first procedure is orientation. We have to choose the best orientation to print our model in 3D printer. So this is for example. So if we are going to print this model means first we have to choose the best orientation for this model. So orientation means we can print whatever we want, whatever orientation we can choose, we can print. Whatever we need, we can print, but we have to maintain the quality. To maintain the quality only, we have to choose the best orientation. For this model, the best orientation would be not this. What you are seeing is not the best orientation. We have to choose another orientation like this. We have to choose. So this is also not proper orientation. Why? Because means if we give support here, this will affect the quality. So we have to give support according to maintain the quality. So we have to choose another orientation. We have to choose this orientation. So this would be the best orientation for this model. Am I audible, sir? Hello?
Audible. Audible.
Okay.
Please.
Okay.
I unmuted, so you please continue. I mute, you please continue.
Okay, sir. Okay. Second thing, first thing is orientation. Second one, we have to give the support structures. Why? Because means this is layer by layer process. So without support, if we print any model, if we print any type of robots, so it will get collapsed at certain point of time. So for that only we have to give the supports. I will show you what supports exactly will be. So here we have to give the supports. Why? Because means I will show you. Yeah. While printing, it will give support for the overhanging beams or any type of angles. The supports will give the strength to the part. So while printing, we have to maintain the good support structures.
So that we can maintain the quality. Simultaneously, we can maintain the quality. Third thing is a infill percentage. So infill percentage is nothing but we can reduce the weight. We can reduce the weight of the component, which is not necessary. So, for example, if you are doing only a prototype or something like that, means we can reduce the material filling percentage inside the part. For example, I will show you. For 100%, if you are giving 100% for this part, means you can see the cross section here. You can see the cross section here. You can see completely filled material here. So if you are going to use this part only for prototype, means you no need to give 100% for this product. So why? Because means we can save the time, we can save the material. So for example, if you are going to print any model, that is only for demo purpose. Demo purpose means we can give 20%. 20% or 30% like that, so that we can save the time, everything. You can see the cross section here. Yeah, you can see the cross section here. So here we are maintaining the air gaps inside the part by reducing the weight of the particle. So for demo purpose, for parts which need not to be a direct application, for that applications and all, we can give this types of infill percentage. So if you are going to drill the part, or if you are going to break the part, or if you are going to apply in a heavy duty particles, means we have to give 100% like this. So by doing this, we can maintain the strength. So here you can see it's a completely filled. So like this, we have to differentiate the infill percentage depending upon the application, depending upon usage, based on the application usage, like that. Based on that, we have to differentiate the infill percentage. So this is the infill percentage. Third thing is the temperature. There are different types of materials are there in 3D printing, from PLA, ABS, chips. Depends on our usage, or if you are going to use only for demo purpose, or only to check the dimensions only, means we can go ahead with the PLA material. PLA material is nothing but a polylactic acid, so it's a completely biodegradable plastic. So for like that demo usage and all, we can use PLA. For direct implementation, for if you are going to part where you are going to apply the load, it's so if you are going to use extreme high load part, means then we have to choose polycarbonate, like that we have to choose. So depends based on our application, we have to choose these types of temperature. Here we can change the temperature. For example, I'm going to use a PLA material, means I have to give the temperature here. For PLA material, the nozzle temperature means the melting temperature. From 220 degrees Celsius, ABS will completely melt. So we have to give 220 degrees Celsius for PLA material. For ABS material, we have to choose 240 degrees Celsius nozzle temperature. So this is the melting temperatures of PLA and ABS materials. So next thing is speed. Speed is for default speed for 3D printer is 40 per second is the default speed of 3D printer machine. So we can change the speed of the machine. So likewise, if you are going to, if finishing is not necessary, means we can increase the speed. We can increase the percentage of the speed. If quality is not necessary, you are going to check one IR, you are going to see only, you are going to check the dimension alone, means we can increase the speed, we can speed up the printing. Likewise, for this part, I will say, for this part, the normal printing speed is 49 minutes. You can see here, 49 minutes is the common normal printing speed of this material for this part. Here, if you want to increase the speed, means you can change the speed parameters here, and you can increase the speed. But there will be some compromise in the quality. So to maintain the quality, we have to choose perfect speed. For depends on the part, we have to choose the perfect speed.
முடிச்சிருவோமா? நீ முடிக்க மாட்டேங்கிறா, எஞ்சி தனியா இருக்குல்ல. இங்க வாங்க.
Hello. Sir, is there any doubt in this, sir?
சொல்லுங்க எழுத்துக்கூட கா
Hello.
இம்மு புள்ளி வச்சா இம்மு ஒட்டகம் சரியா
Hello.
கை
Hello.
Yes, yes, audible.
Sir, is there any doubts from which I said so far?
After finishing, we have enough time. After finishing, our participants.
Okay, sir. I will tell you what are all the common technologies in 3D printing. So there are commonly there are 3-4 different types of technologies in 3D printing. So for example, the basic process in 3D printing is FDM. FDM means field deposition modeling. So this is the basic process in 3D printing. So this process will give you a rough finish, will give you a basic finishing, but we can get the part. This is a FDM process. Next thing is a SLA process. SLA process means the jewelry, nowadays jewelry people are not doing manufacturing the products. They are taking a mold from SLA process. So we can't able to print SLA part in FDM technology. I mean, if you are going to print a jewelry product, means you are not only applicable process is SLA process. You are not able to. It will collapse the quality if you print any jewelry part in FDM process. So we have to choose the process according to parts. If you are engineering component means we can choose FDM. If it is a dental product or if it is a jewelry product means we can choose SLA. Or if you are going to use this implement in any automobiles or like that means we can choose DMLS, which is called metal printing. So for metal printing also we can do 3D printing. So that is process called DMLS. Say so SLM, DMLS and all metal printing. So depends on application, depends on requirement. We can choose the process FDM, SLA, metal printing like that we can choose. So for this, I will tell you in this orientation, what happened if we choose wrong orientation or wrong parameter. I will tell you what will happen. So if you choose wrong orientation, which is this set of orientation like this, if you choose this, it will spoil the quality of bottom surface completely. So here there is a sharp edge. You can see if we choose this orientation, the total quality of those area will get collapsed. So for that only we have to choose the orientation which is very flat. So in this part the flat surfaces, this is the only area we can choose the flat. So I will give you that area. We have to choose this orientation. Next thing is we have to choose the layer height here. Layer height, each layer height. So since this is a layer by layer process, we have to choose the layer height. So for example, if you are going to print 1 mm thickness part means, if you are going to give layer height of 0.2 means the total layers of those parts will be 5. It means 2.2 into 5 is equal to 10, 1 mm, completely 1 mm. So likewise, we have to differentiate the layers. For example, if I give layer height of 0.15 means time is 55 minutes. So if we reduce the layer height of the particle means the time will get increased so that we can maintain the quality.
ஒட்டகம் ஓ இட் டா ஆ இம் ஒட்டகம் ஒன்று இன்று ஒன்று ஓடம் ஓ டா இம்
Participants, please mute. Participants, please mute. Participants, please mute.
டா இம் இம் மாக்கு புள்ளி வச்சா இம் ஓடம் இது என்னது இது வந்து ஓ ஓ என்ன வித்தியாசம் தெரியுமா ஓக்கு வந்து இங்க புள்ளி
Nearby people engaging.
இந்த வட்டம் ரவுண்ட் பண்ணிருக்காங்க இந்த சுருக்கி
Shall I continue, sir? Shall I continue? Shall I continue?
Yes, you please continue.
Okay, sir. Okay. What
ஓ
if we reduce the layer height of the particle, the time will get increased. So if we
இது
want to reduce
ஓட்டம்
the printing time means we have to
ஓட்டம்
increase the layer height of the material, sir. So more and more we increase the layer height, more and more the time will get reduced. By the time the quality also will get reduced. So we have to maintain the good quality. We have to choose proper layer height, sir. So from as I said previously, from 0.1 mm to 0.35, we can choose here. If you are going to use this for any showcase model, means for showcasing model, quality is a main thing. Quality is a main requirement for the showcasing material. So here we have to reduce the layer height.
Sai Kumar, sir, your screen is not coming. So your screen.
Sorry, sir.
Your screen is not coming.
Okay, sir. I will share again. 1 minute. Sir.
Okay, please.
Yeah. Now, sir.
Yes, appearing. Yes.
Like this. Here we, as we said, the parameter layer height we can change here from 0.1 to 0.35. We can give the layer heights. So, but it's completely depends on our application. If you are going to give 0.15 means here we have to give 0.15, but time will get increased. If you want to reduce the time, if quality is not important, or if you want to just see the part, quality is not necessary means here we can increase the layer height, but quality will be little bit rougher than what we did previously. So if you give layer height of 0.3 means you can see the time getting reduced. Here you can see it's reducing from 55 minutes to 35 minutes. Likewise, we have to give the layer heights. Next thing is, as we said, infill percentage. From 0% to 100%, we can differentiate the layer heights. Depends upon our application. If part is just for demo purpose means we can give infill 10%, or if you want to use this for any direct application, or if you are going to use this for any from high heating chamber, or if you are going to use this for drilling purpose, or somebody will test the material by breaking it. So likewise, we have to give 100% so that we can maintain the strength inside the part. Here you can see cross section. You can see it's completely filled. So likewise, we have to give. So next thing is a temperature. For every material, the temperature will be very different. For PLA, I will tell you what are the different materials: PLA, ABS, nylon carbon fiber, nylon glass fiber, TIPS material, PVA material, veggie material, PC material. So there are many number of materials are there, but we have to choose what material is okay for our product. If you are going to print any robo head means for robo head, ABS is more than sufficient for robo head. Why? Because means PLA is not suitable for robo head. You may have to screw the part. You may have to apply some load on the head. So for that, we should not choose PLA material for robo parts. For robo parts, we have to choose ABS. If in completely a robo setup, there may be some portions which needs to withstand more load. For that area alone, we can choose nylon. So likewise, we can choose different materials for each portions. So for head, we can choose ABS. For movement, if part is going to be in dynamic state, we can choose nylon. So we can choose the material according to application. We have to choose where this part will going to work out, where this part will going to sit, where this part going to, how much load this part is going to withstand. So likewise, we have to choose the application, then we have to choose the material. For example, what will happen is if you are going to choose, if you choose PLA material for any robo head means what will happen is while applying load itself, it will break. So PLA material is completely brittle material. For that only we have to choose ABS material. So likewise, we have to differentiate the materials. Next thing is a support. As I said, support is nothing but it's a layer by layer process. So it will be sent or it will be sent to the overhanging position like this. Like this here you can see the red areas is completely a support structures. After printing we can clean the support materials, but it will leave some rough surface here where you can see joints from support some part. So for that only we have to choose best orientation. I will for best orientation we have to choose. This is the best orientation. Finally, we have to change the G code. We have to export from SCL. We have to convert to G code. So I will tell you this software about the software. Also, the software only accepts the SCL format. So you can design in any format, step format, IGS format, whatever you can design. But you have to save in a SCL format. So then only you can able to import in a software. Finally, we have to export in a G code format. Here you can see the G code. Here you can see the G code. G code means after saving the file, we can start directly in the machine. We can copy that in a pen drive. We can run the machine, sir. Like this, we can do. Any doubt in that, sir?
Next proceed. Finally, our people will go there to bridge. Lot of things are there. Anyway, finally, you can answer. Please
Okay,
continue.
okay, sir. Okay.
Lot of materials you introduce. Please continue.
Okay, sir. So I will tell you the another orientation here. If you choose this orientation, the support structure, you can see the support structures here. It will affect the quality of the sharp edges. Here you can see this complete area will get collapsed if you choose this orientation. So for that only we have to choose the correct orientation for the products. So orientation, layer height, infill density, temperature, and all. If we give all these parameters in a perfect manner, we can maintain the quality of the output. If you fail to give any proper values, means the output will get collapsed. So we have to reprint again so that the time waste, material waste. So that for sizing it's we have to choose the district parameters like I said, orientation, layer height, temperature, everything we have to choose from here itself. This is we are converting the STL file to machine language. So this software will convert the STL from STL format to G code format. So for the G code format, we have to give some parameters here. Initially, you can see the layer height here. So here we can differentiate the layers. Brim is, I will tell you about the brim. What brim is. This is the brim. If we give brim, the brim is nothing but it will give some adhesion while printing. I will show you how it is. If we give brim is 5. Here you can see some extra layers. So this is to avoid the warping. By printing, there are common failures or warping. Warping is nothing but the print part won't attach to the bed. So to avoid that only we have to give some extra layers here. So if you want to increase the adhesion means, we have to increase the value. Like this, we can increase the adhesion of the material so that we can avoid the warpage, common failures we can avoid. Next thing is, if we give brim, it will give more extra layer. So like this we can give. Here you can see the thick layer that is called craft. This is to avoid the warpage while printing. So warpage is very common for ABS material and iron material. In PLA, you don't need to give craft and all. You can give just brim. But in ABS and nylon and all, this is a temperature reactive material. So it will react with the room temperature. So for that, we have to give these types of craft. Here, this is a raft set. You can see this is a raft. So, my suggestion is raft is not necessary because if you give raft, it will totally collapse the bottom surface. it will after removing the raft, it would looks very rough. So for that, raft is not necessary. You can just use brim. You can just review brim. Why? Because means I will show you the difference. Here you can see there is no bottom layer if we give brim, just the side layers are there. So this is to maintain adhesion. So for this, to maintain the bottom surface, we can give brim, not raft. Raft is we have to give raft in rare cases only. If part is not sticking to the bed properly, it's not completely sticking to the bed. If part bottom surface is not properly sticking to the bed, that cases only we have to choose raft. That cases only we have to choose the raft. We can choose the hoose layers also. Hoose layers means here you can see the extra layer. Extra layer means we can avoid the part reacting with the atmospheric temperature. So generally while printing part will react with the room temperature like that will react. So to avoid that we can give wall-like structure around the component. Like this we can give and we can maintain the temperature inside the machine or with the part. If we give, unless it will create any crack. In ABS common another issue is a crack formation. So after reacting with the atmospheric temperature, crack will start to form. So to avoid that crack formation and all, we can give these types of walls. While printing, we can give these types of walls and we can save the quality. Like I said, infill, there are many patterns out there. So if we give rectilinear pattern, I will show you inside the component. So this is a rectilinear pattern. So you can see line by line patterns. So this is a rectilinear pattern. So if you change any pattern, honeycomb, full honeycomb means you can see the pattern inside. Like this. So we can change the pattern according to our application. For example, for 100% infill, the pattern will not play a major role. For the if we reduce the layer height, there we have to choose the proper infill pattern. If we are choosing any 10% infill means 10% infill means here you can see some many gaps. So this is not applicable for 10% infill. Here we have to change the pattern. We have to give rectilinear. Here you can see the rectilinear pattern. So that the pattern is spreading all over the part. So likewise, we have to choose the pattern according to our infill percentage. For like I said, for 100% infill, for completely filled material, pattern is not a place. It will not play a major role. So we have to choose proper patterns only for lower infill particles like 10%, 20%, 30%. We have to choose. Next thing is, as I said, temperature, cooling. Cooling is not necessary. It's completely a fan speed. Fan speed. Next thing is a speed. So, like I said, the default speed is a 3,600 mm per minute. If you want the part to be printed very fast, we can reduce the speed, or we have to maintain the quality, we can reduce the speed. So, like this, we can differentiate the speeds. Finally, we have to save the G code. Finally, we have to save the G code wherever we want. We can save the G code and we can copy it from any pen drive or USB. We can load it in a machine. So finally, we can print it. What you can see here, we can print directly in a machine. So main thing is we have to choose the proper orientation, proper parameters, proper values. So to maintain the quality, proper quality, you have to choose proper infill, proper layer height, proper temperature, proper material, proper machine. So like this, we have to give complete setup here in this. So any doubt in this? Hello. Hello.
Sir, we can hear. Sir, we can hear. We can
Okay,
hear.
sir. Okay,
Even
sir.
then, I posted one question. I hardly wanted to disturb. then presentation, we hardly wanted to discuss the presentation.
Sorry, sir, your voice is not audible.
When presenter presents, if we ask the question diversion to avoid the finally question session.
Okay, sir. Okay. Okay. Okay.
You proceed. Your time is there.
Okay. I will show you another part. Not like this. Yeah, okay. This is another part. This is a face shield. You can see this is face shield. Common face shield. This is commonly used to prevent from atmosphere. So this is a face shield cancer. So we have to for this the best orientation is this is the best orientation for this part. Why? Because means if you choose this orientation, there will be support structures inside. You can see the red areas, which is completely support structure. So it is okay, but it will affect the quality in that area around, affect the quality. So to avoid that, we have to choose this orientation. Here we can see the flat surface here. That's flat surface. So if we choose this orientation, there is no support structures needed. Here you can give the supports and you can see it is support structures is not necessary for this product. So why? Because means I choose a proper orientation for this part. So if you choose any improper orientation, means the support structure will start the formation and it will affect the surface quality. So for that only we have to choose the proper orientation to avoid the supports. So that is the orientation. I will go for next. This is a layer height. We can see the time here, printing time here. I would say if the output of the 3D printing component is rough, how we have to manage that? So there is a complete process in 3D printing called post-processing. There we can smoothen the surface. There we can maintain the smooth surface. We can buff the surface. We can polish the surface. Whatever we need, we can choose post-processing. So for mechanical components, post-processing is not advisable. Why? Because in mechanical components, if you do post-processing, there will be microns level of changes this will be there dimensionally. For example, if you give any 10 mm for your bot for mechanical application, if you do post-processing like painting, like buffing, like sanding, if you do, what will happen is there will be a slight differentiation in dimension. Like if you do 10 mm means there will be a deviation of 0.5 mm, like that there will be a deviation. So for that we should not choose post-processing for mechanical application. We can choose post-processing for demo parts. We can choose post-processing for parts which is only to showcase. We can choose post-processing for architectural model. There the dimension is not necessary. Dimension is not important. So for if you are going to build a robo part, means you should not do post-processing for robo parts, especially inside of the part. You can do outside, but inside you should not do post-processing or painting or finishing process in inside. Why? Because means in robo, in inner only you are going to fit any parts, you are going to fit any boards like that. If you do post-processing inside, the total dimension will be different. So totally collapse the requirement. So for that only, we should not choose post-processing for mechanical components. We can choose if you want to, definitely we have to choose post-processing for mechanical components. We have to do with care. So likewise, I will show you the layer height for this component. If we give 100%, here you can see 1 hour 38 minutes. This is a proper parameters. 100% 0.2 mm layer height, proper speed. For all proper parameters, it is taking 1 hour 40 minutes. What happens if you want to increase the speed, if you want to compromise quality, or if you are going to choose proper or improper orientation? I will show you. If you are going to increase the speed here, 5000. Increase the layer height to 0.8. Reduce the infill. So the parameters which I have changed now is completely wrong. Why? Because means this phase shield is going to use directly. This is a direct implementation. So you should always give 100%. Next thing is a layer height. Layer height means we have to give 0.2 for proper quality. To maintain proper quality, we have to give 0.2. Here I am giving 0.3. For proper speed is a 3600 mm. Here I am giving you 5000 mm per minute. So completely it's a completely wrong parameter. What will happen? You can see here. Time will get reduced. You can see here. So from 1 hour 40 minutes to it's reducing to 50 minutes. By 50% of speed getting reduced, I mean 50% of time is getting reduced, we can save time, but we are collapsing the quality of the product. We are not maintaining the proper quality. So for that only we have to choose the proper orientation, proper layer heights. Next thing is that is so far our very main parameter is layer height. So this is a very main parameter. Infill, speed. These three and all very common and main parameters in 3D printing. If you are going to print any robot parts in 3D printer, in your 3D printer means you have to maintain a correct proper orientation, proper infill, proper speed, so that we can maintain the quality. Or what will happen means the quality will get collapse. We have to compromise with quality. What happens means if you are giving a low infill percentage means the part will get cracked or the part will get broken while fitting. So like this it will happen. So I will show you another orientation. So this is a very proper orientation. So this and all, for example, only I am showing you. I will show you what will happen. So you can see support structures here. While printing itself, what will happen means here it will get collapsed. So this is a very thin area. You can see. This area will get collapsed. So while printing itself, this part will get complete collapse. So to maintain that or to avoid that, to maintain good quality, we have to choose proper orientation. Likewise, this is a proper orientation. We have to choose flat surface for orientation. We have to choose best infill. We have to choose best layer height. Likewise, we have to give set. So finally, we can generate a G code. We can load it in a machine. So like I said, we are doing generally we are doing robo parts commonly here. So more of the hospital, more restaurants here started to give robo orders. Why? Because means to avoid contact between human to human. So if they have robot needs, they can use robots for delivery, for everything and all they can choose. So like this, we are printing robo parts here. So their requirement is they will say while giving order itself, they will say we have good quality, we have to maintain a good strength. So likewise they will say, then we will suggest some materials like ABS, 100% infill. Likewise we will say. So these are all the basic parameters. if we maintain these parameters, we can print whatever we need with good quality in 3D printing. So, any doubt in that, sir?
Yes, sir, you can conclude, then we can,
Sir, almost done. So, I have said every parameters.
You please summarize and we can go to the bottom step.
Sir.
Very good, sir. Please summarize. Sir, please summarize.
Okay. I will summarize the meeting, sir. For 3D printing, there are 5 different parameters are there. First thing is the orientation. Second is the infill percentage. Third thing is the layer height. Fourth one is the temperature. If you fail to give proper temperature, the part will get collapsed. Fifth one is the speed. So these 5 parameters will give you a good quality of 3D printed robot. So you can, it's easier to print your parts by yourself. You don't need to give printing from outside. You can print from in your home itself. You can print in robot parts. So it's easier. Basic thing is you have to maintain these 5 parameters: infill, layer height, orientation, temperature, speed. If you maintain these parameters, you will get proper quality of robot part. So thank you, sir. Any doubts?
Sir, wonderful presentation. Dear participants, please post your questions. Please ask your questions. You shut up or turn on your mic. That is, unmute your mic and you ask your question. Dear participants, unmute and ask your question. Sir, I posted one question to you, sir.
Okay, sir.
Sir, I have a question.
Okay, sir.
Hello?
Hello?
Hello?
Your voice is getting break, sir. Please.
Hello?
Sir, I'm audible now. Please let me know your doubts, sir.
Sir, I have a question. If we want to reduce the manufacturing time, then what should we do? Reduce the width of the layer or reduce the infill? Which would be better?
First thing, before reducing the time, you have to choose. You have to check whether it is okay to reduce the speed. Why? Because means if you reduce the speed, you have to compromise in quality. As you said, if you want to reduce the speed of the printing, for example, if part is taking 2 hours, you are asking how to reduce the speed. Like that only you are asking, right, sir?
Yes, sir.
First thing is we have to increase the layer height. For example, for 0.2 mm, it's taking 1 hour means we have to slightly increase the layer height. From 0.2 to 0.25 we can choose. You can see the difference in the time. There will be slight difference in time. But again and again, you have to cross check with the quality. If your part is just to showcase or just to check the dimension, means there you can increase the speed, there you can increase the layer height. But if your part is going to be very, very, very good manner, very, very good finishing product, means you should not compromise in any quality or any speed. You choose whatever the good parameters, you can done the printing set. In rare case only, if for example, if you want to show your design tools to your professor or something like that before 3 o'clock, so that you have to complete the printing before 3 o'clock, means there you can choose these types of speed increasing, this type of layer rate increasing. But if you have time, it is advisable to maintain good quality. So 3D printing is now already a rough process. Rough means the surface would be little bit matte. So there, if you increase the speed or if you increase the layer rate, there will be chances of getting failure in printing itself, sir. So, like you said, if you want to increase the speed, means you can increase the layer height, you can reduce the infill percentage. You can, if you reduce the infill percentage, surely the time will get reduced, and you can increase the printing speed. So like this, we can reduce the speed like.
Sir, if we want to reduce the time, and we have like two options: increase the height of the layer, or decrease
Infill
the
percentage.
infill percentage.
And same thing, printing speed.
And I want
Printing
and
speed.
I want like the part to have good strength. So
Okay.
which would be better, like decreasing the infill or increasing the width?
Okay. You need your part to be very strong, but you have to reduce the speed. So like that you are asking. If you can maintain 100% infill percentage, but you can increase the layer height. You can increase the layer height. Parallelly, you can increase the printing speed. Like that you can do. Your infill would be very 100%. You can maintain the strength, but the printing speed is very high. After printing, you can see some layers on the surface. Why? Because once you are increasing the speed, you are increasing the layer height. So that's why it will give some rough finish after printing. So likewise, we can do there. You can maintain the strength. Whatever the strength you want, there you can maintain the strength. But main thing is, if you want to compromise the quality outer surface.
Mr. Sai Kumar, thank you very much. The participants can ask. Thank you, sir. His email is available. Thank you very much. Have a nice day, Mr. Sai Kumar.
Thank you so much, sir. Thank you, sir.
Now, next presenter is online. Thank you very much, Mr. Sai Kumar.
Thank you, sir. Thank you.
Thank you very much, Mr. Sai Kumar. We have our next panel speaker, Mr. Saurav Karmakar, Infinos Tech and TEDx speaker, India. He's going to present on perspectives of human-robotic interaction. Saurav sir, please do share your content.
Mr. Saurav is available. Mr. Saurav is assigned as presenter. Can you note Mr. Saurav is assigned as presenter? Please feel free to do.
Hello, am I audible to everyone?
Yes, sir, you're audible, sir. Please proceed.
So thanks for thanks for the invitation, sir, and it is really nice to get in touch with you again. So I have a PPT, and also I'm trying to show from where I can share the screen. So
next to video, you can find up arrow. There you can find share content. You can find audio icon, then video icon. Then the third one, cup like there cup up arrow. If you keep your cursor, you can find share content. Through that you can share. You know, even then I tell it. Saurav knows. Please take a feel free to see. Okay. You can find out. Yes, Mr. Saurav, it is starting to share content. Excellent. It appears. It is going to appear. Yes, appeared. Human-robotic interaction. Proceed. Saurav sir, you proceed.
Yeah, sure. Okay, so today I'm going to talk about human-robotic interaction. So I have a research wing where I mostly work on the flexible robotics. So is one of the recent topics which is like very popular nowadays, and it is also kind of new generation robotics that is making some kind of traditional robotics into different format. So that's what we are choosing this. So yeah, so I'll just start from this. Okay. So today we're going to discuss about types of human robotic interactions, that is HMI, and what I mean by the research I do. I mostly kept pictorial images and some sort of information. Mostly I will talk about it, and I'll keep it very short so anyone can ask me the question. Open conversation, communication that I will research on, or any kind of related things. So if you go for robotic interaction, the most important area is like the major area you can find at this actually, where from long time, like at least from 10, 20 years, which is like the advanced era, right? Here you can say the robotics is coming to industry, medical robotics, social, all this kind of stuff, like for last 10 to 20 years or this. So now, what are the things we are additionally getting is like autonomous vehicles and such that you can see about all this kind of stuff. So when you go for industrial robot, the most important part is how like robotics is actually allowing the human effort from in a very efficient way. That means human will be in a control section mostly, or certain cases of maintenance, not too much into the operation, not too much into the kind of manufacturing or some kind of fabrication process. There actually robots will be working. So when any kind of industrial robot we imagine, one of the most important robot that we find is manipulated. There are a lot of companies like Robotics, Hyundai, and others. So they actually use a lot of manipulators. Depends on quality and types of variety, how much automation, all this kind of stuff. It depends actually, but mostly we see that manipulator is one of the huge and one of the most important part for industrial robots. So basically, and what is manipulator? Manipulator is basically kind of arm, like human arm. So we kind of get that we have a kind of joint between, and we can rotate it, and we can actually have a kind of opportunity to work on any kind of segment. So we have some kind of palm. The palm is represented into the work or some kind of actuation or kind of system. And if you see the arm and all, that is actually basically for the robotic manipulation. Okay. So in the case of industrial robots, mostly we see that it is very important how human and robot can work together, or like depends on the load of the work and efficiency and quality. All these things are very important. So that's the reason what we see that is that in any kind of very successful robotic industry where the robots are used for manufacturing and all, this kind of combinations are very, very important, and we can find it very interesting. Next, we can go for medical robotics. So medical robotics, one of the things is like there is a new term is coming, something called telemedicine. And also, if you see in that area, you can find that a lot of robots are there which is having to read. There are also manipulators and all this playing a major role. But it's not only just manipulating, we have a very important role for the clipper and how the surgical tools actually it can be made of metal or different other materials, which is like our body can support basically internal organs and support. So that kind of materials will use for the tools. So it is using for the kind of operation lot of cases. So one of the examples is like robots and all this kind of stuff. So there you can find a lot of cases where master slave models, that means the master that is equal to human or someone else or something else, which is controlling how the operation goes. And that can be now remotely, that can be performed remotely. So that is one of the advantages that we can use for robotics. Next, we go for social robotics. So social robotics, I think, one of the major part in recent history, you can see that a lot of robots are coming. Google Alexa, if I can take an example, or if it is like I don't consider it exactly like a social robot, but maybe one of the known example I can take, which is like having certain percentage of social robotics perspective. So Alexa, any other thing, which is actually but there are a lot of robots which is giving you understanding. You can talk to them. So not of elderly people who needs to only robots. There are a lot of robots who are talking with them to take care of them and all. So that's kind of social robots we can show actually this aspect. Then we go for space robots. So space robots, obviously, you know that anything is happening at the moment. 80% cases we can see that those are like only the robots which is going to outer space or going to the planetary sections. And it is actually enabling the risk factor very low because human is not stepping out first. The robots are going and they're trying to understanding this all kind of requirement or what is the situation, how we can how has human civilization go there, how do they can sustain or not, and even before we perform the colonization of the human civilization in different planets or satellites. So there are a lot of segments. Next is autonomous vehicle. This is, I think, again, it's a very recent past segment where we can find that we have the people car and the cars which is autonomous is like turning into autonomous vehicles. So basically, what is autonomous vehicles? Basically, it's like a driverless vehicle, and which is basically making a new impact on how car can communicate among each other, and they can actually go to the destination very fast. So there might be obstacle, there might be some hazard, there might be some kind of issues upcoming. So the autonomous car can actually be very smart and they can detect that thing from the different cars which is around and on the ahead, and they take the information from different cars. They can go for the segment where they can understand the situation and they take the decision to go in the same way or other way or any other things. It depends on the position of that. So there we can find that a lot of cases we find that a lot of automations are happening where AI is involved. So those kind of image processing is important because without camera car will not work. Even some cases you can find feeder, like another radar feeder is involved actually. So a lot of cases are there which is helping them to make a fast development in this section. And the last section for majorly the last section is like something else, search and rescue bot. So basically search and rescue bot is like obviously any disaster happens, we use some robot to find that whether anyone is alive inside any place which is under disaster or has some kind of like somebody is blocked in some big tunnel, some kind of mines, and also we have some robots. That's the reason I choose this image. There are a lot of such and rescue robots, but it's very, very important that how the robot looks like, whether it is able to pass through the problems or not, whether it is able to detect the obstacle and go passing through the obstacle. These things are very important. That's the reason I choose this image. And even that also includes something like the flexibility part. Though it is not completely flexible, it is made of rigid body. So I don't consider it as a flexible, but it has a kind of flexible movement, like a snake movement. So it gives you two important part. It's called biosphere robotics and the flexible robotics application. That's what my next point. So basically, my research area comes under this three mostly. So one is like circuitry and robotics and space flexible. When I'm telling flexible, basically it's like a kind of soft flexible robotics, which is made of, which is not made of plastic or metal or any other rigid materials, basically. So, like flexible robotics can also be known as soft, but soft and flexibles are used before. But mostly people term it as a flexible soft robotics, but I normally call it flexible because a lot of cases we can find that it is hybrid, like it's a mix of soft and rigid body robotic segments, or part of the entire robot may be soft or flexible or a little bit of rigid. So we can't only call it a soft robot if it is not completely soft material. That's the reason I call it as a flexible robotics. So these are the ideas. So what basically I do, at the moment working on some surgical tool, which is going to be involved in the different kind of like channels inside our body. I will not give exactly the thing, but I can tell you that, for example, there is a tool. So this surgical soft robotic segment, the flexible robotic segment, can go inside the coding and it can detect things and it can give you the idea of what is happening there. And why we are bringing the soft and flexible robotic, because if you see the difference of materials, it's like something like humankind, like it looks like a human skin, it's like a soft. So basically, if any kind of soft material goes inside our body, it has a less damage capacity. So that's the reason we are actually working on this kind of data. For example, this is a very tiny surgical tool for channelizing things. That is again the very, see, it's the kind of manipulates, continuum manipulator. It's again an example of this. I told about the manipulator. So this is an example of continuum manipulator. So what is continuum manipulator? Continuum manipulator is something that is made of flexible body, and it can be controlled by thread, it can be controlled by cable and other flexible materials like. And then we can find that how it came from. So it's basically the kind of elephant which is inspiring this kind of manipulator. And we can have a paper which is again depends on flexibility and again depends on the requirement. We can put rigid or soft paper here as a kind of hand or something like that. So this can actually be used for medical report, like where we have to have a lot of precision surgical atmosphere, so we can use this kind of stuff. So still in under development, that kind of example I can give. And for example, this is a kind of robotic segment which is very small, like a tiny microphone, which is like able to bend without having any motor or any kind of actuator actually. So it can also use, so it can also survive, or it can also survive the heating, or it can also survive any kind of pressure or something like that. If you throw somewhere, it will not break, or it will not like come out of certain shape or something like that. So there are a lot of benefits of this kind of technology. That's the reason we are thinking into this kind of sensitive things now. And my area is at the moment we are making some kind of technology for this kind of surgical technology. And the next area that is I'm working is called biorobots. So biorobot is something, again it is biorobots, which is basically inspired from biological creatures. For example, you can find it looks like some kind of quadruped, or it kind of like an animal just for legs, and some kind of octopus kind of things which is holding some kind of object. Here it is like the octopus, and then it is like the trunk of elephant. This is something of the fish, and it is again like kind of actuation we are showing pneumatic actuation between this one. So we are in all these cases like 1, 2, 3, and 4. In these 4 cases and these 5, in these 5 cases we are not using any kind of battery or power kind of connection directly. So that's one of the most important factors, that we can optimize the requirement for consumption of the power in this kind of networks, and we can make it more smarter as per the requirement and based on the situation. So where we have the possibility to meet a lot of obstacle, where obstacle can break the things and underwater, many other cases. So this kind of networks can actually do this. In this cases, I don't like it's kind of flexible about because it consists of soft and everything. This is the kind of example where we can get soft robots. This is the kind of biomimicry that we are showing. So it's like a finger, and we're trying to mimic the finger postures. So if you see the trajectory, how it is changing. So we are actually able to do the biomimicry for even finger and many other cases. So that's the kind of biomimicry example. And yeah. So I'm calling it space flexible because space robotics is a normal thing. So basically one of my segments is basically working on different kind of flexible robotics where we involve different material-based robots, and we try to use as a mechanism and we try to control it. So without having any motors. So that's I think 3 of the examples, like how you see the cycle. Here you can find that how robot is opening the legs and moving forward. So this is a kind of simulation, one of the example. And this is the kind of robot that is possible. You can, even if any car is going from this legs and all, it will not have anything, like it will not damage anything. Even the piece of glass or something, any sharp thing will not damage. So it's a lot of having advantage. So for example, this one, it is not having any motor, but still it's able to So we have this kind of smart materials which can work with that direction and we can operate properly. That's the reason. So it is like liquid to power, but here it is power is not directly connected to this. So it depends actually what kind of robotic segments is required and how we can do it. So biorobotics, and then we use it for different segments, different kind of situations where we have a lot of obstacles which is not normally happening to the user. Then we actually can introduce the soft hardware or flexible products. So this is one of the last slide that I want to present. Basically, if you see the research process product in terms of robotics, robotics is now one of the most important category after corporate and many other processes. So where robot can actually work where when human situation is not where one of the categories, second category in terms of health crisis, we don't have in terms of social robot in terms of different kind of like exoskeleton. So basically, I didn't mention exoskeleton. So exoskeleton is one of the segments which is like helping a lot of elderly people to walk or have a kind of movement without giving pressure to the body or something. So that's a lot of areas. So if I come to the research in terms of the flexible robotics and the products, this is for example, it is also holding it big and you can find. So we have like the metal which is able to manage within this. If we place any rigid material on metal, it will gas the actually. So we can't close the egg, we have to hold it properly. That's the reason. We have different kind of material which is able to manage it in a very sophisticated way. I mean, any kind of delicate item we can manage with the something like equipment. So that is like you can show that the difference. Normally, if you see any robotic equipment, hard robotic equipment, digital robotic equipment, you can find this kind of operation might not happen. Like this, if you put the power, it will be on or off. So that's one of the most important. But here you can control the actuation from different stages, like completely open, like parallel open and flip. So it has an opportunity to even make a kind of sub area or we can control the each part of the actuation, so we can control the entire gripping mechanism. So that's one of the advantages. So this is you can see one of the like it's very delicate paper cut. So if we use the little body, it will be very difficult to even there's a chance like when it will be coming to grip the glass, then there is a chance that the glass will fall down because the inside if there is any kind of water it will come out and like suddenly it will come to it. So in case of soft report, if you see the clipper is very soft and it is having a proper clipper, we can actually design the clipper in segment. We can actually even we can control the entire figure as per our requirements. So that's one of the greatest advantages of this. So yeah, this is one of the I think this is the area that I'm trying to focus. So I think I'm open for questions.
Thank you, Mr. Saurav. Very wonderful presentation.
Thank you, sir.
Thank you, Mr. Saurav. Wonderful presentation.
Thank you, sir.
Dear participants, please ask questions. Dear participants, please ask questions to Mr. Saurav. Dear participants, please raise questions. Mr. Saurav, meanwhile, have you attempted to commercialize your thoughts as a product?
We are like my product is actually coming under the different section, not exactly the robotics, but the research that I am doing presently, which is having kind of surgical robotics sector, there is a chance of commercialization because I have a connection with some medical. They are interested to see how the result comes, and based on that we can find if we can go for commercialization.
Good. The another one also, meanwhile, people can say, do you have in your mind to collaborate with a group of people across India to come up with one kind of thing, interesting thing, that kind of thing, availing the expertise spreading across India, even beyond. some, you post something, through that you could make a, joint venture as a, fraternal kind of robot, that kind of thing, okay? A cooperative kind of effort. Through that you want to make one kind of, I don't know, something. Since you are emerging young guy, you could have that kind of thought. Thank you. Got my point, Mr. Saurav? You got my point.
Yes, sir, I got it. Can you again repeat because certain parts of words are not clear?
I repeat, availing the spreading expertise across India and beyond, something, a novel kind of thing, you jointly work and come up with that object, that robot.
Sir, can you just type the message on the chat because...
Yes, I message. Other participants, since, it is, open time, I gave time for others to think. Please post your questions. Please ask questions. Since 4 more minutes are there, 4 more minutes are there, please ask questions.
I have a question. Hello?
Yeah.
Yes, audible.
Yes.
So I wanted to ask, for same amount of work, are soft robots more efficient or the conventional robots?
Same amount of?
Like for same job, like for simple gripping task, the conventional robots more efficient or the soft robots?
No, it's actually based on your requirement. You can't specify always that this is better, that is better. Like, for example, everything has their own specification, right? So if we have our own specification that, okay, this is like, as I told, like underwater, if you go, there might be some problem to use software. Okay, sorry, there might be some problem to use like the normal rigid body robots. Okay, but if you are going with soft support, there is a very good application based things, or you can try that the gripper with the soft delicate items, delicate food items. So if you gonna hold the delicate food items with the soft gripper, that might work. But if you gonna use the normal gripper for any for example, you are using some what can I say, burning material, for example. So there, if you use soft hold, that will not work obviously because it's a burning material. So it might also burn the soft gripper or something like that. Or if you're going to hold something like a very heavy fluid, so that is again like it is not possible by the soft robot in general. But again, it depends on which situation, what kind of environment that you're using. So if you are focusing on different environment and all, then you can actually apply. So it depends on what you are going to apply. So you can give me the specific case and all. Then that based on that, we can actually say that yeah, here this we can use, here we can't use, and like that. So that I think all that is.
Thank you very much, Mr. Saurav.
Thank you, sir.
Thank you very much. You are appreciated for sparing your valuable time with us. Now, next speaker is online. Thank you.
Thank you.
Dr. Vaishnavi, please take care of the next speaker.
Yes, sir. Thank you very much, sir. Now, we have the privilege of listening to Dr. S. Jayakumar from Renano Semiconductors, India. Today, he is going to handle a session on vision-enabled robots, DL-trained to deploy vision intelligence in robots. So, we request Dr. JK to share his content with us. So, please.
Dr. Jayakumar, you are assigned as a presenter role.
Please unmute yourself and please do share your content, sir. Thank you.
Sir, please unmute. Jaykumar. Sir? Sir? Sir, please unmute. Dear participants, it is in progress. Dr. Jaykumar is on the way. Dr. Jaykumar is on the way. He is on the Cisco WebEx Internet Highway. Dr. Jaykumar is on the Cisco WebEx Internet Highway. Our remote signal is there to him. Our remote signal is there. He has to land on Cisco WebEx. Thank you very much. Song is appearing. Wonderful, sir. Dr. JK is the communication source of communication. That kind of a person in front of us. Dr. Jaykumar is his source of communication. The source of communication is a sense technological communication. Dear participants, he landed on preparatory in progress. Maybe sharing is content, maybe yes. Good evening, sir. Could you please share your screen, sir? Unmute your microphone, sir. Please unmute your microphone, sir. Please share your content, sir. Your video is very much fine, sir. Very happy to see you, sir. Extremely glad. In front of us now a person who worked in Media Lab during 90s. Dear participants, The resource person now in front of us who worked in Media Lab, Boston, USA during 1970s, 1990s, sorry, during 1990s. Sharing content may be on the way. Person landed, the sharing content, that's on the way. Dear participants, sorry for the inconvenience. Yes. Sir, please unmute. Sir, you can find the icon share content. Maybe next to the video icon. You know well, even then, it's our duty to support. Dear participants, sorry for the inconvenience. Sometimes it happens. Sometimes this happens. Jayakumar rejoined back. The resource person now Dr. Jayakumar rejoined back. Sir, please unmute. Sir, next to video you can find share content icon. Sir, please unmute. Sir, please unmute. சார் சொல்லுங்க சார். அது வந்து இப்ப பார்த்து ஷேர் கண்டென்ட் இல்லைன்னா திருப்பி வந்து அது மீட்டிங் எகைன் ஜாயின் வரும். அந்த இதுல இருக்குல்ல அந்த ஒரு இது மாதிரி இருக்கும், ஒரு பவுல் மாதிரி இருக்கும், ஒரு அப்பேரா இருக்கும், அது ஷேர் கண்டென்ட். சம்டைம்ஸ் அது நடக்கும், சம்டைம்ஸ் அது நடக்கும். அவன் திருப்பி நான் அசைன் பண்றேன், வச்சோன்னு நான் அசைன் பண்ணுவேன், அப்படியே வச்சிருக்கேன், நான் இது பண்ணிடுறேன். ஆமா நான் தான் அசைன் பண்ணுவேன். இப்ப செஞ்சா அசைன் பண்ண முடியாது, செய்யறேன். க்ளோஸ் பண்ணிடுறேன் உங்க காலை. Sir, assigned as presenter, sir. I assigned as presenter, sir. Sir, I assigned as presenter. Have you found share content icon and you unmute please? Unmute please. Unmute please. Sir, you are assigned as presenter. You please unmute and find the icon share content. Sir, unmute. Sir, please unmute and share content.
Great, good.
Yes.
Thank you. Thank you. Thank you. Thank you.
Yes, sir.
So now you can, I can share, I can go for a presentation mode now, sir.
Yes, presentation mode. Yes, presentation mode. Yes,
Yes, sir.
yes.
Yes, sir. Can you see that now?
Yes, we can see you.
Oh, yeah, yeah. You can see the vision. Sir, you can see that first page also vision enabled robots trying to see that also, sir.
Yes.
Sir? Okay.
Proceed.
Good. Yes. Sir, please tell me.
Yes, you are hearing your voice. Audio is fine. Audio fine.
What about the slide is visible?
Yes, visible.
Okay, good. So shall I start, sir?
Yes, please start. Please start,
Okay,
sir.
thank you, thank you, thank you. Good evening to all of you. It's very interesting to present certain new research what we have done in the past.
Sir, if you have the content, please share that content. Share your content. You are appearing. Share your screen. Share your screen. Now you are appearing. That's fine. Yes. Now starting to share content. Good. Yes, sir. Sir, you have to complete within 15 minutes. Then the next presenter is on the go. So you please take 15 minutes. Now time is 3:20. Please continue, sir. Welcome, sir.
See what is going on presently with this environment.
Yes.
So
Very nice,
with this, thank you so much from the heart of it, and also allow to share what have been gone through the last recent past, maybe like in a year and a half. So in this, the vision-enabled robots are robots getting ubiquitous in almost all the vertical. It used to be kind of mining. Now everywhere robots are keep coming in. Of course, robots historically had a kind of mechanism. People think that it's a kind of a machines. It doesn't have high. The latest robots are essentially getting the vision centric, like what we see. Similarly, robots also want to see. That's our research area. In that, we had done a good amount of experiments and so on and so forth. Allowed to share with you. In that, when we create certain things, and then how do you enable the visual intelligence in the robots? For that, we created a platform called TL-Train. TL-Train is our platform which we had created with the great effort in it. I'll unveil that down the line. Of course, most of you rather I don't think anyone in our group now we are there who can find it difficult for this. How many flowers are there in this picture? So all of us, whoever has a normal vision will come to say that it's a two flowers. But the next question goes, the question goes to that, how many flowers in this one? We say the two flowers now. That is how many flowers in the second right side. is, that we almost like say it's, it's not interesting, it's not our cup of tea. Or someone might say that, there's a many flowers. Instead of say the many flowers, so many flowers, rumba flowers, and so on and so forth, right? But the things become a little more tough if the third one. This, well, of course, as a normal human being with the intensive, intelligence or whatever, they just give up. We don't know how to count that. The first flower we can count two. The second set we can say so many or something. The third one is almost gone. So there is no. If you see clearly, the first flower two had a kind of a identity, individual identities. And the second picture also there is an individual identity as almost. The third picture doesn't have individual identity. This is exactly the classical physics. If we go to Boltzmann and Maxwell, they said, there is every, those days called bosons. There has a, independent. The particle is independent. They had identity. Then they, visualized that they created distributions and so on and so forth. But what happened is in that story changed extreme. Things become very difficult when the particle not had a individual identity. What will happen? That's what called Higgs boson. That's a place Einstein and Bose Einstein created a kind of distributions which I'll share with you later. So these kind of distributions rocked that classical physics in the middle of last centuries, that created too much of innovation around that, which we as a beneficiary and in now that kind of a mathematics, that kind of kind of a models required for us to go and further enhance our vision to the machine visions much more deeply. One more exercise allowed to take you all this because in fact I started with this when I when I asked one of the junior engineers, I asked to count how many stars in these pictures. So the junior engineer just given up. So we don't know how to do that. So if you see that it is a sky, night sky, that so many stars are there, how do we can count them? So then, I was thinking that there is a way to, get this one is, computationally tractable. Now, sir. So then I was thinking that how I can. Sir, is it okay? Audio is okay? Sir?
Audio is fine. Audio is fine. You please proceed, sir. Some noises will come. We control. You please proceed.
Okay, thank you. Thank you. So then what happened is the sky, night sky, we have a lot of disturbances coming, sir. Okay, when we have that, okay, now it's clean, sir. Thank you. So now we have night sky. How do we count the number of stars? Okay, so that's a place. Then I was quite fascinated that this is a computationally trackable problem or not trackable problem. As a human beings, we say if you ask a robot to see the sky, how's the robot going to see it? So obviously, there's any clue, right? As of today. So then I try to make this problem is computationally tractable problem. This presently is it looks infeasible, just give up kind of problem. So if you see someone who has a little more knowledge in RGB things, like it's a 0 to 250 scale, which has been plotted. The right side, if you see, then I remove the background, white and black pictures. Even then it is not computationally, we cannot see something much clear about it. So this is a kind of RGB to black and white transformations. It's a mathematical transformation, but even then it's not computationally tractable, right? Then still further I went on this one. So what happens is filtering. The filtering is essentially happened. I share with the filter coefficients if someone who is interested in it. So they design the filter coefficients by using methods, digital signal processing, which is my core portfolio. So then change this problem into reasonably good problem, which we can do the counting. So then applied little more signal processing techniques on that and filtering in particular filtering. Then we brought this kind of the fourth picture what you see. Anyone can count, reasonably you can venture it the counting, but the first picture, top 00, sorry, this top left, people say just is, not trackable computationally. And the problem is now this top bottom, right? It's a computationally tractable, at least it looks like that, right? So the physical nature of the problem today in the vision ranges, to start with, it may not be ready for computations. That's the moral of the story is now is on the physical world, the signals may not be computationally, trackable of signal processing tricks that normally people call computer CVs, open CV, and so on and so forth. I don't want to get into that kind of a mess for 20 years. So we need a clear signal processing algorithms to bring this the whatever reality in front of us, that to a kind of computationally trackable picture or images or videos. So then it's the last one. It is a kind of thing. So you can say, easily venture into do this kind of things. So what happens, the moral of the story of this experiment is the computationally horrible problem of top left is brought it, reasonably good. One can venture it computationally trackable problems. So when we design our machines like robots, there are machines, correct? Then we need to put them a proper algorithms, proper mechanisms into that. Directly beaming the camera pictures into this, that's not going to help anymore, right? It's not the kind of thing. That's the way we done the second exercise. The first exercise, which I told you how to overlapping create the new distributions, which I share with you later times. So this is what the final picture, correct? One can count it. I can share with you. Some of you feel time to do a little research into some numbers also. I can share with numbers. You can write a program to algorithms to do that part. So what happened is this one is a mode of exercise which is we brought down the second exercise. We brought down computationally, looking tough problems into the computationally feasible problem now, correct? So the third exercise, which is interesting one. So you can see this is a kind of pictures, millions of pictures every minute will go through in India, and people like microbiology lab, they take pictures or not pictures, the samples, and the samples converted into images, maybe UV images, sometime PCR. So the images need not be RGB at all. Okay, images can be different also. Image is a general term in English, but the information can be different forms. So different kind of radiation, different kind of colors. So when we see this one, so this is a cell which has this so much of items in it. How we are going to count it? Today, if you see in any microbiology labs, people are, I assume that they're all counting by human beings. Human beings are deployed around the world and then count one by one what it is. That's the reason it takes time. Morning, if you give a sample, even day next second day will come or first day. In fact, now COVID takes 2 or 3 days. And that's because of even to get this picture itself, they required another day, right? So they're tracking the problem. They bring the problem into computationally feasible problem. The the sample is it needs to be converted into picture. That takes more than 8-7 hours. That's what I think. So maybe Kumar sir can tell you more. So things are happening around, and imagine robots are computing and taking unbiased decision about COVID status of a given person. So then the fourth experiment which I done is much more interesting is today what happened is in agriculture is in organic cultures and micro precision agriculture is booming around the world because people are put to buy costly items and so on and so forth, health conscious people. So what happened is when we do the kind of massive
audio missing. Sir, you are okay.
We train that our neural network and then train them with the samples, and then we use that and then find out how it is happening. This is the fourth experiment which we done at our lab. So these four experiments, which has given us some kind of a direction for us, how does the vision looks for a robo is not just taking picture of it. That's not going to take us anymore. Like it is another picture, JPEG picture or something going to be on the hard disk or whatever it is, right? We need to infer the thing. So this gentleman.
Right. Sorry, I think I mistakenly take a wrong number. Don't know if mistaken number or not. Right.
Sir, your audio gone. Sir, your audio, please. Sir, your audio, sir. Sir, your audio. Sir, your audio. Sir, your audio, please.
ஹலோ நான் யாரோ பேசிட்டு இருக்காங்க ஏற்கனவே இல்லை? ஓகே, எனக்கு இன்ஃபார்ம் பண்ணுங்க. சவுண்ட் வர மாட்டேங்குது. அந்த அந்த பேசுறவங்களோட சவுண்ட் வர மாட்டேங்குது. அப்படியா? பேசுறவங்க சவுண்ட் எனக்கு வராத.
Hello, Dr. Jayakumar, sir. You are not audible. Can you check, please?
Hello? Hello?
Hello, sir, Dr. Jayakumar.
Yeah, I'm audible. Hello, am I audible?
Yes, audible. You are audible. Sir, Jayakumar, sir.
கேக்குது. Yeah, when is my turn? Maybe another 10 minutes?
Yes, sir. So your term is another 10 minutes. Okay.
Okay.
டாக்டர் ஜெயக்குமார் சார்,
கேக்குது கேக்குது.
ஜெயக்குமார் இல்ல உங்களுக்கு இல்ல, பிரசன்டர் ஒருத்தர் போயிட்டு இருக்காரு.
ஓகே.
டாக்டர் ஜெயக்குமார், டாக்டர் ஜெயக்குமார், டாக்டர் ஜெயக்குமார்,
crossing, the kinetic segment to the person crossing place, then the instant segmentation. There is a lot more research going on in that. But however, for today, a need for industry, need for robots, this is more than a more realistic is image classification. All other things appears to be in the research directions going on that. So imagine like most of you might have seen the city living people, and also the Swiggy is one of the guys who's distributes or Amazon or whoever. When the person coming in on the road delivering their thing, instead of that, imagine the robot comes and delivers the things and that. That means the robot need to understand all the things whoever crossing the road and so on and so forth, right? That kind of things essentially getting along. So with this, experiments which is illustrated in front of you, and also the kind of research came from Hinton Lab, which is Canadian university called Toronto Universities. So what is very clear to all of us is, the robots can get a text inputs and image inputs. They can comfortably can take inferencing. But today the robots may not be able to understand speech and audio because that's much more complex, lot more research going on. So that's a place as an industry, when we run industry, we need to make money also to do the monthly, on out in and out, right? So we are more restricted to the image signals and to classify them as an R&D things going on the speech and audio segment. So in the right side, you can see kind of a models, the CNN model mostly done with image. Then we have RNN model, the recursive neural network. People are trying it for speech and audio, but the text is more of the old classical one, like histograms and so on and so forth, which is the old stuff. Which is text is almost done stuff. People are going out in the image now. Moving up the chain, speech and audio is a green. I know a lot of flourishing research are happening with different models and so on and so forth of their own thinking. So see, in the world, if you see, confused you, with very easily within few minutes, TensorFlow, Python, this and that, Coffee, something like AI means they'll some 200, 400 jargons comes out immediately. So that's place, a lot of problem happening. What we did is we in our lab work, we consciously find out all these jargons, avoided them, how make life is easy to make things better. So this is one of the companies. Similarly every company has this. I just took one slide how complex things come this from IBM. See what all the framework which they say to do one image classification problems. Imagine. So what we did was from real scratch, we created a called Day-3. The Day-3 is a model which can support, presently neural network, NN and CNN, both models. So the user no need to do any programming. They can be domain expert. So agriculture they can bring out their images, what they want to train them properly, and then just define how complex the layers, like they want to 5 layers or 10 layers, or what they can afford. The layers going to depend upon what computing infra we have down, right? So they don't need to write any programs, any code, and they bring the pictures and then put it on this one, a DL train. DL using this IBM Open Power is a modern computer today. Is a part of supercomputer which is runs in Oak Ridge Lab in Florida, where massive computing happening in the a really high scale. The same computer we have in front of my home, as you can see it backside of me. So at there, this is called Open Power IBM Power.
Sir, audio is missing. Sir, audio is missing.
To do the train the network. For that, we need a real high computing capability machines at our place, and also we need a network to connect the data to that. That's a place we done this DL train. Here the output after training that it comes, the green one is output. After I'm assuming that 2 days, 3 days, the training is over, the network is trained successfully, then we get out the one data called JJ. It is a trained one, so that's a kind of output. Now it's useful, which can be tradable as well. What do we do with a network, a trained layer, network? One can ask. So these are the machines which I showed you to train in our lab. Is you can see one Power 9 machine here on like a tower kind of thing standing there. That's a Power 9 machines. Then other one you can see on a flat card which is almost like this much big. 10 kg one, that's called NVIDIA, so 207X RTX one machine. That's another view of the same machines, right? Which is we use this one to number crunching for this model. So what happens is today our data, we no need to go to some place. If we have this one on our desktop, our table, then immediately we can use this TL train to train the network. After training the network, we can deploy it in a various robots which we like. It can be as a robot can be like a mobile phone as well, right? Our robot can be NVIDIA chipset or Jetson Nano, or a complex robots we can deploy it, which will show you how it is. So with the trained model, which you see in here, the green one, that is a network. It's a commonly called neural network. I just remove the name neural, it's just called network. The network which has the one trained, it has a weights and then the connectivity data, correct? These things. Then we will bring that model to NanoSam. NanoSam later process it from Qualcomm 820. Solutions, one of the company which I consult also these days. And they've created a board called NanoSam. It's a very micro, very small, less than finger, that can go in any robot with ease. So we can deploy this train network onto that. So that NanoSam can interact with even a motor or any IoT node on board. Like it can be camera, it can be any movable items or something. And always GPIOs are there exposed to that, and you can connect those things. SPI is also exposed. You can connect to them and they get the input and do the real-time inference things. Okay. So in case if you want the robot to get back to the kind of IoT things I've been watching today, the yellows one today, it can be a cloud. Come from NVIDIA. That this platform is very popular now in robotic industries, where you can this has not only a CPU, it has a 128 GPU also called CUDA cores. We call it CUDA cores, Compute Unified Digital Architectures. That CUDA cores parallelly can run 128 of them. So that gives it in a real-time performance. Imagine you are driving on the robot driving, goes on the road. It takes a 10 seconds or 10 minutes, data to keep rounding for computing. Then it might hit another person, right? Then we need a decision within 20 microseconds or 30 microseconds or sub milliseconds. That's the kind of order of that. Then we need engineering perfections and kind of hardware and support onto that. So there is a NanoSam is again illustrated. So what I really brought you all to that is the vision is a kind of required a lot of algorithms and signal processings to make the vision is feasible, bring the real world problem into computationally trackable problem. In the computationally trackable problem can be then modeled as a neural network or convolutional neural network. Then the neural network can be trained by using the pictures and then perform the further things. So I just take you to the NVIDIA place itself. Sir, now what do you see, sir? Picture, did you see Boltzmann machine or the old one only, sir? I think I have to unshare that one. Okay, 1 minute. Because I'm going to a new one. Let me unshare it. Yeah, where it is unshared. So now you might see that full screen, right? Sir, now did you see something called Boltzmann machine in deep learning? Sir, are you seeing that?
No. Starting to share content that appears.
Which, sir?
Share content, not now appearing. It will appear. It may take time, I think.
You are sharing is coming, sir. Already shared.
No.
Okay. I'll reshare it, sir. Screen. Enter screen. Share. Now you can see NVIDIA things, correct, na, sir?
No, sir.
You are seeing the old one. You are seeing the old one only, correct? Huh?
Now share content. That's all. Now yes. Yes. Your ID appeared.
Okay.
Again, your ID appeared.
Okay, understood now. Now I reshared it. No?
Again, wait, we will see what result we will see.
What's that?
Wait, we will see. Wait, we will see. Again, ID.
1 minute. And now at least you are sharing the entire sharing your application.
We will see. Again ID.
Then 1 minute. Sir? now seeing a deep learning called Boltzmann machine in deep learning. Sir, sir, are you there?
No, sir. No, sir.
Sir, are you there? Are you
Yes.
there? Are you there?
Sir, it's not appearing. It says ID. Your ID appears. Sir, you can summarize, sir. You can summarize it into the next
Screen is
speaker.
done, sir. It is shared.
Again, your ID, sir. Sir, you may summarize, sir.
Okay, good. So, essentially, of course, as summarization only, I thought of sharing that, all this here chart part www.jkus.com. So I had already shared this one for you. You can. This is what I want to show you there. www.jkus.com. There you can go and get the whatever I done the practical experiment. How we can put that vision intelligence in two platforms which are explicitly illustrated. One is the platform called Jetson Nano. Another is Android phone. Both the platform source code, everything is given there. So you can try it out and then see. So some of you might ask where is this robo and Jetson Nano and so on and so forth, correct? Now the modern robots are coming with the vision ability with us. So that means that we need to load the vision intelligence onto the robots. Then the robot can see and then perceive and then take a decision. It is not just relaying the images back to our back office and then we send the robot move or like it's not like a master slave mode. The robot when independently when moving further away right then now there, that's the reason called vision intelligence. Be given the methods and process in which one can put that intelligence into that. That's exactly I illustrated and then seen. If any questions I can take from here, sir.
Thank you very much, sir. Extraordinary presentation. Participants, please ask only one question. Dear participants, please ask only one question. Sir, participants will ask later through your email ID. Thank you very much, sir.
Thank you, thank you, thank you, thank you.
Thank you, sir. Thank you, sir.
Bye, bye.
Bye. Dr. Vaishnavi, please take care of the next speaker.
Yes, sir. Thank you very much, sir. Our next panel speaker is Dr. K. Damodaran from Apollo Hospital, Chennai. Now we have a privilege to listen to Dr. K. Damodaran. He's going to present on robotics in coronary artery disease management. Sir, please.
Hello, am I audible? Hello.
Yes.
Yes, sir. Yes, sir. Yes, sir. You are audible.
I have to do sharing, no? Sharing.
Yes, sir. Yes, sir.
Share. Share.
Dr. Damodaran, you can find next to video icon. Yes. Next to okay, appears.
My slides are visible? Hello?
Yes, visible. Your slides
Am I
are
audible?
visible.
Am I audible?
Yes, you are audible.
Okay.
Your slides are okay. You are audible. Please continue, Dr. Damodaran.
Okay. First of all, let me thank the administrators as well as the faculties of Christ University for giving me this valuable opportunity. As an odd man out, I am a non-engineer, being a clinician who happened to give a talk on robotics in coronary artery disease management. Being a cardiologist, I want to focus my talk in robotics, in cardiac catheterization laboratory, as well as in coronary interventions. You all been aware that the robotics has found a place almost more than 2 decades in minimally invasive surgery, both in cardiac as well as non-cardiac surgery. But in the recent past, it has found some role or place in the non-surgical interventional arena, that is cardiac intervention. Am I audible? My line is okay?
Yes, audible. Please proceed.
So the robotic PCI, when I come to talk about the robotic coronary intervention, just have a word on the technology trends in medicine, which has been there for the last couple of years. And also the trend, what is going to happen in the next decade. We all know that the smartphone applications and cell therapy, 3D printing, as well as when it comes to precision medicine, what the clinician is interested in to apply a precision medicine. That means personalized healthcare to an individual by doing a gene printing or making the treatment which is so appropriate to the given patient. When we want to talk about robotics, robotics is the more interesting as well as the upcoming field in the arena of cardiac interventions, especially cardiac management, especially in cardiac intervention. We have been aware that robotics have found a major place in various industries, whether it is manufacturing industries or in automobile industry like auto driving cars, as well as in the hazardous area, but also has an important role in medicine also. When you look at the market share of the robotics, it is not single digit. When you call it in terms of dollar, the projection in the next 5 years is almost like $25 billion. When it comes to the annual compound growth rate, it is also growing in the next 5 years in terms of the robotic mediated surgery or robotic mediated coronary intervention. So when I want to talk about my area, that is the cardiac cath lab, when we have a technology, new technique, it is not that we should wish that we have a couple of joysticks and a comfortable cockpit to operate on. We also need to demonstrate the need for this new technology in the field of cardiac catheterization laboratory. So the need has to be demonstrated in terms of the consistency as well as the reliability of the technology in terms of the operator skills. When you heard of the operator skills before robotic era, one may say this clinician this surgeon has a better operational skills when compared to the other doctor. Whereas it is being customized in terms of robotics, the operator skills doesn't matter much because the robotic takes care of the precision. Number two, thereby it also improves the clinical outcomes as well as it will also bring down the cost. When the technology comes into place, obviously over the period of time and the volume of the procedure goes up, the cost will naturally come down. It is not only the result or the outcome of the procedure, but also the health hazards which are due to the cardiac catheterization laboratory radiation, as well as the other occupational hazards like an orthopedic injury that I am going to discuss in the next couple of slides, is also being much reduced by the robotic assisted coronary intervention. And above all, the one important thing what the robotic is going to do in the near future is to give access to all the patients. It is the one thing which is going to really promise the slogan of reaching the unreached. Even the unreached places, if we have a robotics, we can do a tele-stenting, tele-procedure. Sitting at one place in a cockpit, we can monitor and control or even deliver our therapies in the remote places like some places with underprivileged healthcare facilities. So this is the routine conventional cardiac catheterization laboratory. For those who are not aware, this is the cardiac catheterization laboratory. This is how we are doing in the contemporary practice. Though there is a catheterization laboratory with the intense imaging, intense imaging intensifier as well as the X-ray source. There is a monitor. So naturally, one has to lean over the body of the patient. One has to look at the monitor. So one will have the radiation which can cause the cataract. One can have an orthopedic shoulder problems because one has to lean for. So many issues because of not only for the physician, also for the patient also, because they will be getting more doses when it is a conventional cardiac catheterization laboratory. This is how it is being done nowadays. Whereas in a robotic suit, you don't need to stand inside the cardiac catheterization with a lot of radiation. You can have a separate cockpit that I'm going to show you. So finally, the cath lab is a very hazardous place. There are a lot of radiation awareness from various societies, starting from radiological society to cardiological society. There are various guidelines, various recommendations for a tighter regulation for radiation protection. And also, as I told you, when the radiation hazard or the dose of the radiation increases over the period of years due to the increased volume of procedure, the cumulative dose of radiation can cause cataract, as well as it can also cause brain tumor. The very interesting thing is because the doctor who is always looking by the side of the patient, obviously the radiation source is towards his left side. So the preponderance of the left-sided brain tumor is more for a radiation worker or a radiation radiologist or an interventional cardiologist. So these are the various radiation-induced sinister problems one can get in a conventional cardiac catheterization lab. Let us see how this robotic system as well as robotic-aided cardiac catheterization lab is going to reduce all these occupational hazards. Sorry, not able to. Are you able to see my slides?
Yes, sir. We can see your slide.
But I'm not able to share.
Audio, slide, everything is okay.
So I'm not able to share. There is a problem with 1 minute. Yeah. Okay. So anything hiding in my slide? Nothing, no?
Nothing, yes. Appears. The orthopedic burden is unacceptable.
Okay. The issue is I'm not able to move further. This is Cisco, no? Cisco.
Now we see that cath lab is a hazardous place. The orthopedic burden is unacceptable. That's what we see, the slide.
Yeah, no, the slides are not moving because of some low signal. Anyhow, so naturally the orthopedic problems in a clinician for a cardiologist is unacceptably going high. I can say from my perspective, some of my colleagues who has not even crossed 50 years has got so many orthopedic problems in terms of arthritis or cervical spondylitis. It depends on the years of exposure or years of practice, as well as the number of procedures he is doing daily, as well as the volume of the institution, volume of procedures done in the institution. Naturally, when it increases, obviously the heart, because the patient and the operator has to stand in front of the patient in the cardiac cath lab, unlike in a robotic cockpit, you can sit comfortably within a lead, which is the obviously no radio protective material, lead covered cockpit, so that you can be literally avoiding the radiation exposure. You can sit comfortably. You can can avoid this. The same. Sorry, this external noise. Can you please mute your mic? The host can mute his mic.
Yes, you please proceed. We take care. You please proceed.
No, I can't do it. There is an external noise. So you have to mute. Whenever you want to ask, you can switch on. Okay. So there are 42 new publications in this era and in this area. Obviously, you might be knowing that starting from the occupational health related thing, starting from that as well as into the interventional cardiology area. So all this again proves that the conventional way of doing cardiac catheterization or intervention can only produce more of an occupation related health hazard, like this orthopedic as well as the radiation. So the very important thing is the reaching the unreached. So this is the way we can promote the telemedicine. The doctor, the interventional cardiologist or radiologist can sit in one place and with the help of a paramedical or allied medical personnel, he can do even the most critical procedures in the remote locations where the real healthcare is not available or under privileged healthcare. So even a doctor can control more than 10 cath labs sitting in his office room in a place like the US, and he can do a tele-stenting or a tele-interventional procedure in a remote place in Africa and Asia. This is the gift of this technology into cardio interventional practice. So this is the historical moment when in 2006, almost 14 years ago, the first case of robotic PCI, the first proof of feasibility was done in Israel by Rafael Bayer, and he has done the first case and showed the world that this is going to be the way forward in cardiovascular interventions in the coming years to go. And he has got 100% success, and that case he has done it. And the years to come, the technology has much improvised to the next generations, obviously. Then comes the CorePath robotic system. The CorePath robotic system has all the equipments to feed the hardware for an interventional procedure. This is the robotic arm. I can show you in the next couple of slides, and through which you have to feed the guide wire and put the hardware, whichever is going inside the cardiovascular system, to remove the blockages, the acclimatous blockages, and you can place a stent also. The current technology has only it has only the facility of advancing over 1/4 inch guide wire. In future, there may be more slots for putting other size guide wires for even peripheral and other intervention. The third more important key factor is the measurement of anatomy. The anatomy, when we usually in a conventional way, when we look at the angiography, we can say, okay, this lesion is say 15 millimeter length, vessel diameter is 2.5 only by our visual analysis. So there may be a lot of inter and intra-observer variation because of this, because this is more of a subjective experience-based analysis, whereas in robotic, it will show you the precision. So there comes the precision medicine. So it will tell you the exact length of the lesion as well as the exact diameter, so that you will avoid complications and you can improve the outcomes both in acute as well as in the long term. This is where the robotics won over when compared to the conventional angioplasty. Oh. Not moving slides, huh? Is it visible now? Hello?
Yes,
Hello?
visible.
Can I do it? I can do it in this manner. Otherwise, it's not moving forward. Is it okay to visualize? Yeah.
Yes, visible. Please proceed.
Yeah. So the robotic PCI is a novel approach not only to reduce the radiation exposure but also to improve the precision in the delivering the therapy. In the original one has only 2 or 3 joysticks, 2 or 3 knobs to only advance the balloon as well as the stand. Whereas here you have one more. This is going to be the way forward. I mean, it will have a guiding catheter control also. This is the setup for the robotic PCI cath lab, robotic angiographic suite, where the operator or the cardiologist will sit inside the cockpit, which will be surrounded or covered by a LED console, as well as he has his controls through the joysticks, and he has his scrub nurse who are the technician who usually sit by the side of the patient. This is the robotic arm. Whatever he operates from here will be controlled through this robotic system, and it will be delivered as per his commands. So there was a pivotal trial called a precise pivotal trial. It showed that device success was almost 98%, and the radiation reduction is 95% less than that of a conventional thing. This is what amazing that the radiation exposure to the doctor as well as the healthcare has been reduced almost 95%, which is beyond imagination. So the FDA has given approval for and using this in the clinical arena. So there comes further trials. There are more than couple of trials, and part of the trials I have listed here. Every trial has proved again and again there is a reduction in radiation, as well as even in complex cases like where you usually will be done by only an experienced operator, can be done even with a moderately experienced operator with the help of a robot, because it has got all its functions fed in this system, as well as the precise measurement of taking the measurements so accurate, and placing the devices like stents are so accurate. It is far better than a manual stenting or operator dependent percutaneous intervention. So these are the various things. Also, it has found a role or a place more than coronary, that is in the peripheral circulation, even in the leg arteries. So thereby it has proven role in the other vascular systems. So these are the trials which has proven again this is going to be the way forward. So what this penetration of the robotic procedures has been more than 2 or 3,000, and in the year 2016 now. It has been done in so many places, mainly all the major hospitals in the US as well as in our hospital. We have started this program 2 years ago. We have got a reasonably good experience in this robotic PCI, at least in the simple and reasonably complex cases. And we have got now the advanced next generation robotic system called Cortex GRX. The one important thing in this key point in this advanced system is we can even manipulate the guiding catheter. Previously, the cardiologist has to sit and stand by the side of the lab, and he has to do the initial work, or he has to prepare the patient and actively engage the guiding catheter. Then only he has to go from this patient side, from the patient side to the cockpit. Once we do the initial things, then he has to go to the cockpit and do the rest of it. Whereas now, the cardiologist need not come near the patient. Only the technician can fit everything through this arm, a robotic arm. The cardiologist can comfortably sit in the cockpit. He can even control the guiding catheter and wires and all the stuff. And even one can do an imaging, intravascular imaging, which is an advanced mode of percutaneous coronary intervention, which can also deliver a more quality-oriented outcome. So these are the various advantages for the physician as well as staff, apart from the patient factors. And this is our experience. You can see I'm doing the cockpit and controlling the robotic arm. This is the robotic arm. This is the robotic arm, and my assistant is helping me in feeding the wire. The initial part we have to thread the wire, then we have to come back to this console and do the rest of the procedure. This is what we have done in our place. This is how the robotic PCA arm or the port will look like. So now, when the present, the current era, that is COVID era, we always, whenever we have a technology or a medicine or a vaccine, we always now more bothered about COVID than anything else in life. So when I looked at the literature, is there any answer from robotic PCI in patients who are positive for COVID or who have suspected COVID, whether robotic PCI find a role? In fact, hypothetically or concept-wise, it tends to reduce the exposure of the healthcare personnel rather than in a manual or a conventional way. At least there needs to be four person, including the cardiologist, should stand inside the cath lab. That is a cardiologist, assistant cardiologist, and the cath lab scrub nurse, as well as the cardiovascular technologist. Whereas here, with the help of a robot, we can reduce the personnel and from 4 to 2, so that the healthcare personnel exposure to the COVID-19 infection, that is the virus infection, is reduced, so that we can maximize the healthcare resources in this current challenging time. So there are hypothetically or concept-wise, there is a role for robotic PCI. Even one can do a remote PCI in patients who are positive for COVID-19. So the futuristic vision is it is not only the angiography and the angioplasty, even the non-invasive imaging modalities like myocardial viability, echocardiography can be integrated within this angiographics tool, so that one can have everything under one roof, like so you can even look at the cockpit and you can view the imaging like a non-invasive imaging, that is echocardiography of the patient, or you can even do a fusion imaging, like you can fuse the CT images with the angiography images, as well as you can even look at the nuclear perfusion imaging. So these are all the various modalities. Ultimately, it will give more outcomes in terms of precision, in terms of reducing the effort or reducing the radiation to the operator or a doctor. It is really helpful. This is the way to go forward. And second important thing, what I have mentioned in the initial part of my talk, that is telestenting, that is reaching the unreached. If a very specialized doctor, like a cardiologist or interventional radiologist sitting in, say, Chennai, and if he wants to do a procedure in a remote location like Dharmaburi or, say, Tiruvannamalai, he can only arrange this sort of robotic cockpit in this prime city in his office, and he can train the cath lab scrub nurse or a technologist or junior most cardiologist who is not much well versed in the intervention, is not fully qualified, equipped or trained enough. So he can give instruction to his cockpit so that the personnel who is standing there in the remote place can do an angioplasty. This is going to be the future in terms of robotic angioplasty, and thereby we are going to serve the entire or the global population, especially the reaching the unreached. That is the motto. So one way I can say the robotic is going to socialize the medicine. Such it is not only the precision medicine, it is a socializing medicine. It can offer the therapy or the complex therapy, like in a complex cardiac interventions, or which are the life-saving procedures in times of heart attack, where a remote person cannot get this kind of treatment, will be done through this robotics. So it is a real revolution in the field of cardiovascular intervention, and it is not only at the concept level. It has been already, proved in data in a feasibility trial, and was published in the European Heart Journal. That they call it as a remote PCI. PCI means percutaneous coronary intervention. There is angioplasty and stenting. where they treated a patient sitting in major city like in Italy or in Europe, and they treated patients even in the remote places. And this study has again confirmed there is a feasibility, there is a safety in doing such remote PCA vis-a-vis conventional PCA. So my final thoughts about robotic PCA journey is the cath lab environment is rapidly changing with the advancement of the technology. The environmental hazards are now getting controlled with the means of robotics, and the PCA outcome is also very much optimized by the use of precision medicine. Even the complex procedures has become simplified with the help of analyzing the endovascular anatomy or the structural anatomy, and integrated all these things into the cardiac catheterization laboratory to give the best outcome or the precision medicine future. Robotic PC is also rapidly evolving. It has reasonably controlled the environmental hazards like radiation hazards, and also in future it will deliver therapy to even the remote locations, to reach the unreached, as well as in future it will integrate with various other imaging modalities apart from the catheterization fluoro modality. It will also get combined with the fusion modality of the CT scan, or fusion modality with echocardiography, or with the physiological studies. So there are a lot of thought process which is going on. So robotic PCA is here to stay in the feasibility studies, in the real world practice. It has been evolving, and in the future it is going to be one among the standards of care for the best optimal management. Thank you, sir. Hello? Hello?
Thank you very much, Dr. Thamodaran. Very exciting.
Yeah.
Now, the participants, please ask questions. The participants, dear participants, please ask questions to Dr. Damodaran. Dear participants, please ask your questions. Dear participants, please unmute and ask your question.
Okay, there are no questions.
I have one question. Hello, Dr. Yeah. So, what are the facilities in Apollo related to robotic surgery in your field, like especially cardiology? So, are there any also training programs running in Apollo Hospital for it?
So Apollo there is no formal training program for any doctor.
But is there any robotic surgery there, Da Vinci or some setup there?
Yeah, Da Vinci is there for both cardiac and non-cardiac surgeries. They have been doing for almost more than a decade, almost more than 5-6 years, to my knowledge. Now, whatever I have spoken about is non-surgical, that is interventional robotics, that is CORPAC, that is angiography, angioplasty, you might be aware. So this is a robo which helped us in doing angiography, angioplasties. What you have been asking is Da Vinci. That is mainly for performing robotic surgeries, both cardiac and non-cardiac surgeries. And there are reasonable specialists both in cardiac surgery. Ours was the first of the kind in robotic mediated, robotic assisted cardiac surgery plus angioplasty. What we call it as hybrid revascularization. Doing robotic surgery mediated LEMA to LED and putting stents to other blockages. If you go into the Google, you will know in this country we have done the first of its kind with the robotic assisted hybrid coronary revascularization. So there is this robo system for surgery that is called Da Vinci that is being practiced by our cardiac surgeons as well as non-cardiac surgeons. What I have spoken about is robo in cath lab, that is to help us in angio and angioplasty. I think I'm clear.
Yes, yes, pretty much clear. Thank you, thank you. I got the point which you're trying to say. Thank you so much.
Welcome.
Thank you so much, Dr. Damodaran.
Thank you.
Then, Dr. Vaishnavi, please introduce the other speaker.
Thank you very much. Our next speaker is Arshad from Sahalat Medical College in Hospital. She's going to handle a session on robotics in ENT surgery. It's a pleasure to
Am I audible?
Yes, ma'am, you're
Audible. Your video is coming. Everything is fine. Yes, your screen appears. You please proceed.
Okay, so
Yes, full screen mode it appears. Good. Proceed.
okay, good evening, everyone. So I'm Dr. Shadma Arshad, and I'm going to discuss on robotics in ear, nose, and throat surgeries. So this is the Jawaharlal Nehru Medical College and Hospital in Aligarh, which is situated 200 kilometers from Delhi. And this is the currently my location from where I'm presenting. And our organizers in Chennai and Priest University in the southern part of India, and our co-organizers in SUTD Singapore. And of course, we have participants from all over the world. So I would first of all like to thank our organizing team for giving me this opportunity to participate in this very well organized initiative in this COVID times. So let us start. So first, I'll discuss about the evolution of surgery. Initially, we had open surgeries, which is performed, which is still in practice, and we have newer modalities coming up, which has emerged, like the laparoscopic and the endoscopic surgery. Further evolution has taken place to robotic surgery and digital surgery. The research on this is still ongoing. So open and endoscopic surgery, they have their own benefits and challenges. But most of the challenges that we face are due to the human errors, which are caused either due to tremor or fatigue of the surgeon, or due to the imprecision or variability from surgeon to surgeon in their skill or their state of mind, inability to process quantitative information quickly, and ineffective sub-millimeter scale or the minute movements that are required, especially in ear surgeries where the bones are very small. And there is more chances of scarring in open surgeries as larger incisions are required. There's a prolonged recovery time as there is more trauma of the tissues during the surgery. So with the development of robotic surgery, most of these challenges have been addressed. So first of all, what is robotic surgery? It is the use of a powered device that functions under programmable computerized control and may be used to manipulate the instruments and to perform the surgical tasks. So according to the role-based classification, I think all of you must be knowing this, active robot, semi-active robot, and passive robots. Active robots are basically robots that independently perform the task without direct human manipulation or without surgeon's control intraoperatively. Semi-active robots are systems which constrain surgical manipulation through the feedback to restrict what can be done surgically. So basically, it is having the contribution of both the surgeon as well as the robots. And passive robots are systems that guide the surgeon who direct the robotic instrumentation to perform a task. So basically, in passive robots, the robot is entirely under the control of surgeon. Now, classification of the robotic surgical systems that we use. First is telesurgical system or telemanipulators. Then we have shared control systems and supervisory control systems. So telemanipulators are in this the surgeon operates the robot in a master-slave configuration. That is, the surgeon directs the motion of the robot. The surgeon is sitting elsewhere and he is directing the robot to perform the functions. These are mainly three types: the Da Vinci surgical system, the Zeiss robotic surgical system, and the ESOP robotic surgical system, which we'll discuss later. Then we have the shared control system or the computer assisted navigation system. In this, the surgeon during the surgery, the human does most of the work due to the presence of active constraints. And it is an image guided functional servoing. That is, it is a vision based robotic control wherein the functional state of a surgical stool is controlled based on the real time measurements of its location in or near the patient. The robotic system monitors the surgeon's performance and provides the stability and support. And the navigation here is basically provided either by CT scan or fluoroscopy, or it can be imageless as well with the help of infrared sensors. And an example of such surgery in ENT practice is the image-guided sinus surgeries, which we do for extensive sinusitis or neoplasms of the paranasal sinuses. So it is basically done to see the distance of the disease or the operating area from the vital structures like the orbit, the eye, the brain, the internal carotid arteries, etc., and to minimize their injury, as well as it is used in revision surgeries where a surgery has been previously performed and the anatomy has been distorted. So in revision surgeries, the new anatomical landmarks can be seen through this image guided function. Then we have the supervisory control system. Now the shared and supervisory control system, both of them, they entirely rely upon the 2D or the 3D medical image data to control the position, orientation, as well as the functional state of the device. In supervisory control, it is mostly automated. That is, follows a specific set of instructions. In this, the robot performs a pre-planned move or action automatically or semi-automatically based on the pre or peri-operative medical imaging. An example of this is a RoboDoc system, which is used in orthopedic surgery for drilling. So this is not used in ENT. Now here are some of the telemanipulators which are discussed in detail. So this is ESOP, the automated endoscopic system for optimal positioning, and it was the first commercially available robot. It uses a single surgical arm for voice activated camera positioning, as you can see. It is not in common practice use now. Then we have the Zeiss surgical system. It is made up of an ergonomic surgeon console, you can see here, and there is a three table-mounted robotic arms which perform the surgical tasks and provide the visualization during the endoscopic surgery. And it has these robotic arms. They have a 5 degrees of freedom, and it is voice activated. But this system was earlier used. Now it is not used. The system that is currently most widely used in ENT practice is the Da Vinci surgical system, and it has 4 components: the surgical console, the vision system, the patient side cart with the robotic arms having the endorist instruments. So these instruments, they have 7 degrees of freedom, whereas these instruments had only 5 degrees of freedom, and it was voice activated. The Da Vinci is not voice activated. So I would like to show you a video. So this is the surgical console in which the surgeon is sitting and he's operating and giving the commands for the robots to follow. So in this, the person is able to view high definition 3D images inside the patient's body. Here, this is the patient side cart positioned next to the patient, and it utilizes 4 robotic arms to carry out the surgeon's action. So here the surgeon is having a high definition 3D image, and the console is fitted with a globe-like apparatus, that is the robot master hand controller, that translates the surgeon's hand, wrist, and the finger movements into the real-time movements of the surgical instruments. So you can see the robotic arms that are moving based on the surgeon's control. One arm is used for holding the camera and the others are used for holding the instruments. And here, these are the endo wrist instruments which have 7 degrees of movement freedom. They can perform different functions like cutting, ligating, suturing, tissue dissection. Here we can see the suturing is going on. So this is the entire setup of the Da Vinci system inside the OT. Now, these are camera that are used in the Da Vinci system. They have dual mounted endoscopes that provide distinct views for the right and the left eye, which produces a three-dimensional field of vision for the surgeon at the console. So we mainly use two types, 0-degree endoscopes and 30-degree. So this is the 0-degree endoscope and 30-degree endoscopes. And we have two diameters, 12 mm diameter for adults and 8 mm diameter for children. And two main commonly used instruments are the Maryland forceps and the spatula-tipped monopolar cautery. Forceps are usually for gripping or grasping, whereas cautery can be used for cutting or coagulating. So a range of instruments are mounted to the robotic arms and can be used to perform the surgical maneuvers. So there are degrees of freedom. As we discussed earlier, there are 7 degrees of freedom, 3 translational, 3 rotational, and 1 gripping. So the tip of each instrument allows 90 degree of articulation. And the degree of freedom which I feel is missing is the haptics, that is the tactile perception, which usually we are able to, as a surgeon, we are able to differentiate between a nerve, an artery, or a vein when we are operating via tactile stimulation. That is usually absent in robotic surgeries, but now research is going on this field as well. This is another video of a transoral robotic surgery that is most commonly done in ENT practice. As you can see, surgeon is sitting in the console. He's providing the information in the Da Vinci system. This is the robotic cart with the robotic instruments. The instruments are placed inside the oral cavity. There is no external incisions given. And the incisions given here are very precise. As you can see, there is minimal or no bleeding at all. And the trauma to the nearby structures is also very less. Now, the latest innovation in the robotic surgery is the Med Robotics Flex robotic system. It is a highly flexible robot which is able to traverse the non-linear upper aerodigestive tract, that is the oropharynx, hypopharynx, larynx, and gain physical and visual access to the important anatomical landmarks without laryngeal suspension. A highly articulated multi-linked scope is used, which is able to follow a non-linear and circuitous path due to its numerous mechanical linkages, and a high definition visualization of the surgeon can be seen. And it is mainly used in transoral robotic surgeries as well as in cervical head and neck surgeries. So this is a video showing the Flex robotic system. Now, although the Da Vinci offers a clear surgical advantage over the pass through different curves and crevices inside the oral cavity and larynx, which could not have been traversed by a rigid endoscope. This is a flexible part of the endoscope, and the movement can be provided in all directions. Mainly the workspace area of this is a hemispherical region. Like Da Vinci, it can also perform different functions like cutting, ligating, suturing, etc. And you can see through a single port, all the instruments are passed by the surgeon and then operate through the joystick. Precise incisions are given, clear incisions, and even minute incisions can be given with very minimal bleeding and edema. Now, the clinical applications of these robots in ENT can be used in pharyngeal tumors, in laryngeal tumors. In pharyngeal tumors, basically, we do biopsy and excision. In laryngeal tumors, as well as we can do biopsy and excision, as well as total laryngectomy can be done by transoral robotic surgery. For tongue-based tumors, we can do resection. For obstructive sleep apnea, there is a very common phenomenon that we see nowadays, snoring. So in those when the snoring or obstructive sleep apnea is due to tongue-based bulkiness or due to bulkiness in the oral cavity, this ulopharyngoplasty or as well as tongue reduction procedures can be done. If there is any malignancy of the tonsil, radical tonsillectomy can be done. And a wider term for all these surgeries can be the transoral robotic surgery, which I've already shown.
Now, robotic surgery can also be used for thyroid removal and thyroidectomies. And there are basically two approaches: a robot assisted transaxillary surgery, in which the incision is given in the armpit or the underarms. And through that, the robotic instruments are approached to the neck to remove to the thyroid. Mainly, it is done for unilateral, that is one sided thyroid enlargement or nodule. And another approach is the robotic facelift approach, thyroidectomy. In this, the incision is given in the post-auricular region up to the occipital hairline, and from that, there the instruments are approached. Other uses in ENT are in rhinology, that is in nose, we can use in sphenoid, ethmoid, and frontal sinusitis, in extensive fungal chronic sinusitis, in neoplasm, that is malignancies of sinuses, in cerebrospinal fluid leaks, in traumatic injuries, in pituitary tumors. So in all this, a common surgery that we use is the image-guided sinus surgery through FES. FES is functional endoscopic sinus surgery. So here we are using the image-guided sinus surgery. That is, we earlier discussed the share control system through navigation. So we used intra-op monitoring of the anatomical site, or the site of operation is done through CT. Now, in otology, that is in ear, different surgeries are performed like mastoidectomy, stapes footplate, microprick fenestration, cochlear implant, and hearing aid implantation. We all know that ear, the ossicles, the facial nerve, that is the bones in the ear, they are very, very small. The smallest bone is present inside the ear. So very minute incisions or minute instruments, small instruments are required to do the surgeries in the ear. So for this, robotic surgery is an excellent procedure. Here, this is a diagram that is showing the cochlear implant. Cochlear implant is basically done in patients who are deaf and mute, where when you introduce an external and internal device with an electrode array, and this electrode array is passed inside the cochlea to stimulate the nerves so that the person is able to hear. Then other uses in ENT practice are for salivary gland removal. If there are any stones in the salivary gland, any malignancy, any benign tumors, or it's also used in neck dissection for any cervical lymphadenopathy, could be metastatic, could be due to an occult unknown primary, or also used in oropharyngeal reconstructions. That is, after pharyngeal tumors which are removed, they have to be reconstructed. So reconstruction can be done with flaps, and also microlaryngeal surgeries for laryngeal polyps, laryngeal vocal cord nodules, etc. We do microlaryngeal surgeries. The last two, that is the oropharyngeal reconstruction and microlaryngeal surgeries, these are mainly performed by the medrobotic flex system. Now, even though it's an unfair comparison of the surgeon with the robots, the robots are only present for assisting, but still there are some benefits of the robotic system. So they are, first of all, there is a magnified 3D high definition vision of those spaces where the surgeon cannot see directly. For example, in the oral cavity, in the larynx, the surgeon cannot see directly. So through these robotic instruments, he is able to see. There is improved dexterity, there is 7 degrees of freedom, very precise incisions are given, repeatability, stability, accuracy, and it can be used in various particular environments. For example, when we are using navigation system, that is intraoperative CT scan is done, radiations are produced which are hazardous to the surgeon. Whereas in robotic surgeries, robots can work in these environments without any hazards. Then programmed hand-eye transformation is there. Multitasking can be performed by the robotic instruments. Surgeries in these, multiple instruments can be introduced at the same time, whereas surgeon has only 2 hands, so only 2 instruments can be used. Then image guidance and stereostatic orientation of the surgical instruments. Then there's motion scaling. That is, as I've discussed earlier, very slight millimeter to sub-millimeter movements should be done, especially in ear surgeries, which is difficult to be performed by a surgeon, but it can be easily monitored and done by a robotic surgery. There is minimal mobility to patient. Of course, there is improved surgical outcome. There's reduced invasiveness, and there is reduced trauma and blood loss. Reduced trauma and blood loss due to the refined movements of the robots, which has a tremor-free manipulation, which will be seen in surgeons. There is reduced recovery time because there is reduced edema. There is minimal aesthetic impact because since no external incision are given, or sometimes a very small incisions are given, so the scarring is less and the aesthetic impact is good. Now, despite of all these advantages, robotic surgeries have some limitations as well. Like, they are highly expensive. It is very cumbersome and a very large setup is required. There is a large space in the OT is required, especially for the Da Vinci system, as I showed earlier. And the surgeon should be trained and experienced for that. and also the time internal for the operation has increased because there is added setup time for the docking of the robot and the robotic console. There is also inability to process the qualitative information. That is, the tactile perception is not there, and lack of awareness regarding the robotic procedures among the general population. So since there is lack of awareness, people do not opt much for the robotic surgery. So the debate over the proper role of robots continues, and the robotic technology remains a complicated medical, economic, and ethical issue. Now, finally, we come to the digital surgery, which is the future of robotics, and it includes the telesurgery, where the surgeon can operate on a patient remotely from a separate physical location through a robotic digital system. And research is still going on in this. So, as we see in the industry, we have the 1.0 to 4.0 in industry. Similarly, we can see in surgery as well. So 1.0 is basically the open surgeries where we have to explore the anatomy, sterile instruments are used, new surgical instruments were introduced. In 2.0, we had reconstructive surgeries, transplantations. In 3.0, minimally invasive surgeries were used and robots were used as assistants. But in 4.0, digital surgery is done. That is robotic surgery, telesurgery, as I discussed, and man-free OT, which is also research is going on in this field, is taking place. So with the increasing versatility and miniaturization of the robotic technology, as well as the integration of additional qualities such as the haptic feedback capabilities and expansion of the uses and indications of the robotic surgery, the research is likely to continue, and more robotic surgeries will be opted for in the future. So how many of you in the participants will opt for this in the future, the man-free OT? Thank you. So overall, I would like to say that robotic surgery in ENT and head and neck surgery represents a novel, minimally invasive approach in the treatment of multiple diseases. Thank you.
Thank you very much, Sadma. Very nice presentation. Wonderful presentation.
Thank you.
The participant, please ask questions. The participant, please ask questions. Meanwhile, my question is, telesurgery may be considered as IoT-based surgery. Now, IoT is obsolete. So, can we call IoT surgery?
Sorry, I'm not able to understand your question. Can you please repeat?
Now, the time of Internet of Things. Earlier period, that is called telesurgery. Now, Internet of Things. So, could we call IoT digital surgery? Just, I am posing this question.
Hello?
Hello?
Yes.
Yes.
I'm not able to understand your question.
What I say, that telesurgery may be called as revisioned as Internet of Things. Now the era of Internet. So Internet of Things. Can we use?
Yes, of course, it can be used.
Okay,
Because the
thank you.
surgeon is in some separate physical location and the patient is elsewhere, and the surgeon can still operate on that.
Okay. Now the era of Internet of Things. So IoT, I say. The participant, please ask questions. Participant, please.
Hello, madam. Good evening.
Good evening.
Madam, I am Kannan Mahadevan from Prest University.
Yes.
How do you decide a degree of freedom to your surgery, madam? Because it is very difficult to ear, nose, and throat.
So we usually use the Da Vinci surgery system, in which we have 7 degrees of freedom. So it is basically imitating the hand movements.
Like a man degree of freedom.
Yes.
Okay. Thank you, madam. Thank you.
Thank you.
Thank you very much. Now, thank you very much.
Thank you.
Now the
Thank you
Vice
very
Chair,
much. Yes, sir. Yes, sir,
introduce
please.
the other speaker.
Yes, sir, please. Thank you very much, ma'am. Our next panel speaker is Dr. Barris from Belgium. He holds his PhD in mechatronics engineering and he has been working on AI-based control algorithm for several application domains. Now he's going to handle a session on magnetic levitation and vibration isolation. We are eager to listen him. So please share your content, sir.
Okay, just a second, please.
Yes, sir.
Okay. Anyone can see my screen clearly?
Yes. Yes.
Okay.
We can see your screen very clearly.
Okay. Very nice.
Welcome.
Okay. Thank you for this kind representation. So let me start. Today I will talk about closed-loop stability via state feedback controller for magnetic levitation systems. And this study, I've conducted this study during my PhD, and yeah, today I will give you some outputs related with this subject. So as constant, firstly, I will give you objectives, keywords, and some useful links. And after that, I will talk about state space representation approach, stability, controllability, and observability of magnetic levitation systems. And then I will give you some information about reference tracking server systems and why we need to do that. And as a third section, I will talk about a case study, reference trajectory tracking problem for magnetic levitation. And after that, I will give you conclusion and then we will conclude the presentation. Okay, let me continue. So first of all, as objectives of this study, construction of linear state space system model from ordinary differential equations, and then understanding stability, observability, and controllability for linear systems, and then synthesizing state feedback gains to achieve Lyapunov stability. And the keywords of this study are state feedback, stability, eigenvalues, observability, controllability, and reference tracking. And here there's a bunch of links that can be used to reach some of MATLAB libraries. And if anyone is interested after the presentation, you can basically go into the libraries and check it out. Okay, firstly, let me give you the general definitions of state space representation. In control engineering, a state space representation is a mathematical model of a physical system as a set of input, output, and state variables related by first-order differential equations or difference equations. State variables are variables whose values evolve over time in a way that depends on the values they have at any given time and on the externally imposed values of input variables. So output variables values depend on the values of state variables, as all you know that. So general definition is that you basically have a closed loop system, and you basically have an input, output, state variables, and you basically feed the state derivative of the state variables as an input here, as you see here, into the system. And X is state vector, Y is output vector, U is input vector, A system matrix, B input matrix, C output matrix, and D feed-forward matrix as given here in the appropriate dimensions. And there are some advantages and disadvantages of using state space representation and transfer function approach. As you can see here, if you use state space representation, you can easily use state space representation in multi-input and multi-output systems. And state space representations are efficient, is an efficient way in time domain modeling. And if you use non-zero initial conditions, it's a good approach. And that representation can be used for both LTI and nonlinear systems. And they are flexible due to the multi-matrix algebra, which means that if you use a kind of a computer program in which you can create many sophisticated matrix algebra, this approach is a great way to create your system. On the other hand, transfer function approach, it can be used in simple input, single input and single output systems, and this approach can be used in frequency domain and zero initial conditions and only for LTI systems. So what's stability actually is a huge question. In signal processing, especially control theory, bounded input and bounded output stability is a form of stability for linear signals and the systems that take inputs. If a system is BIBO system, then the output will be bounded for every input to the system that is bounded. As you know that you can create a finite energy methodology as written here. So this theorem was firstly proposed by Lyapunov, as you see here. He basically asked a simple question: does such a function ever exist? And if the answer is what's that? If the answer is yes, what's that function? So the answer is exponential function, and this function can be used in a very frequent way for magnetic levitation approaches. If a is negative, the function goes to 0 while t goes to infinity, which ensures the stability for any initial condition of t. And as you see here, there's a MATLAB code that you can run in your MATLAB environment. And same analogy is also valid for eigenvalues of the system matrix A. An analogy exists for matrix algebra. Any LTI system is asymptotically stable if and only if the real parts of the eigenvalues have negative values. And you see here the Taylor expansion. And you see here the A matrix value, and if the eigenvalues of the A matrix here have negative real parts, which means that this value somehow goes to a bounded value while the time goes to infinity. You can also represent this inequality by using Lyapunov inequality approach. This is your system matrix, and if you can find any P matrix which is positive, which means that the real parts of the eigenvalues of A matrix are negative, which means that your system is stable. Here, there's a simple problem, RLC circuit, and somehow if you use a proper RLC circuit, any RLC circuit is stable in terms of their system dynamics, which means that any R, any L, any C values are positive, which means that in any case, in any values of these subsystem parameters, your eigenvalues will be negative real parts. And this approach can be used for magnetic levitation as well. So here's a bunch of MATLAB code you can easily run it on your system, and the dissipation of the system will be bounded, as written here. And we will use the same approach for magnetic levitation system as well. So for controllability, a system is said to be controllable at time t0 if it's possible by means of an unconstrained control vector to transfer the system from any initial state x t0 to any other state in a finite interval of time. And observability, a system is said to be observable at any time t0 with the system in state x t0. It's possible to determine the state from the observation of the output over a finite time interval. So the concepts of controllability and observability, these concepts were first introduced by Kalman, as can be given here. They play an important role in the design of control system in state space. In fact, the conditions on controllability and observability may govern the existence of the complete solution to control system design problem. So you see the controllability matrix here, and you see the observability matrix here. If the controllability matrix is full rank, states are independent, and the controller signal has access to each state. So you need to have a look at the rank of these values, and if these values has full rank, it means that your controller signal has reached to each state independently, has access to reach each state independently. And for observability, and this approach can be used especially in industrial domains, which means that in industry there is no always chance to have a bunch of sensors to keep track on some specific variables, which means that you can somehow derive specific data from different sensors. This approach can be used for this purpose. So stability for servo systems. Reference tracking for varying frequency reference signals, frequency domain optimization is needed, which means that both have magnitude and phase plots. However, we only achieve stability here by moving the eigenvalues to the left side of the imaginary axis, as you see here. So how to construct key vector? We basically use Lyapunov matrix in actuality. We have an A matrix and we drive the positive matrix. And if the open loop shape of the system is not stable, we need to synthesize key vector here, which means that somehow we manipulate the eigenvalues of the A matrix, which also means that we will have a new A matrix which defines the system. So in internet, there are many solvers that can be used for this approach. The most popular ones are Sadumi and Yalnif. And you basically define a system which consists of basically a bunch of mathematical equations, and you basically create a system which is convex in its nature. So yeah, now you have a new A vector which has new eigenvalues, and that can be used for reference tracking approach. So this is a case study from a project TÜBİTAK 1003 project fund, project number here, and multi-dose hybrid electromagnetic levitation system. You basically have an input and you basically have an output. And the thing you need to do for reference tracking approach, you need to equalize the value here between the second norm of this value to 1 at a specific frequency, so that you will have a robust reference trajectory problem. There's a bunch of MATLAB code here. As you see that we basically define the system variables here, and somehow we define our constraints. If you can synthesize a specific y value at here for a given A, and if there is a solution, and the solution will represent your key value which stabilizes the overall system. And the response of the overall system will be like that, as can be represented as a second degree of freedom ordinary differential equation. It will be an overshoot, overdamped, or overdamped. It depends the values that you choose for your system. But the thing is that for each degree of freedom, there will be a specific type of this system. And at this point, I would like to show a video presentation for you from this project. Let me open it. I hope everyone can clearly see. As you see that there's a magnetic levitation system which has 5 degrees of freedom, and 2 rotational degrees of freedom, and 3 translational degrees of freedom. And as you see that for each degree of freedom, we use a linear Lyapunov stability approach for reference tracking problem. And let me play the video. As you see that the system moves towards z-axis now, translational movement, and alpha axis rotational movement, still alpha axis rotational movement, and the beta axis rotational movement. As you see that there is no contact, which means that there's no mechanical contact, and there is no friction just because there is no mechanical contact. And the advantage of using this approach is that somehow the system is overall highly nonlinear. And the disadvantage of using this approach is that even though the system is highly nonlinear, you need to first linearize the system. And after the linearization approach, the system will be unstable. The system that you will obtain the linearization approach, it will be not highly unstable, which means that you need to have Lyapunov stability approach for the reference tracking problem. Yeah, now you see a coupling movement between the axes. And the air gap data between the vehicle and the surface is being obtained by the laser gap sensors here. And as conclusion, state feedback gains, how to obtain key vector to ensure the stability and the reference tracking purposes. What's Lyapunov stability? I have basically explained. And the Lyapunov inequalities to ensure Lyapunov stability, and how to achieve reference tracking, which matrix inequalities need to be synthesized. So there are a bunch of references here that I used for my work. If anyone wonders, you can basically click and download, especially these MATLAB libraries. I use it for for solving two optimization problem for my system. Yeah, thank you for listening, and I'm open to answer any questions.
Thank you very much. Introduce a novel area to the participants. Now this is the time of participants to raise questions. Dear participants, please ask questions. Sir, meanwhile, my question, in robotics, practical purposes, have you introduced such a control algorithm?
Sorry, can you repeat your question?
This control algorithm of magnetic levitation kind of techniques, have you introduced into any practical kind of affair?
Yeah, actually, it's a very good question. In robotic manipulation, as you know, that many of the system parameters can be modeled as nonlinear. So for using these optimization methodologies, firstly, you need to linearize your system. Let's say you have a 6 degree of freedom robotic arm. For each degree of freedom, you need to have a kind of linearization. And without linearization, and this optimization methodologies cannot be used. But even though, how to say, when you linearize the system, there's a danger that you mislead the system. You may have misleaded information. This is something that you need to be very careful. And yeah, but at the same time, your advantage of using linearization approach is that you need to have less computational power, which means that you have enough space to do more computations. But in my opinion, you need to be very careful to use this approach for robotic manipulation systems, because they are very highly nonlinear system. Even though magnetic levitation is very highly nonlinear system, this approach has its own advantages. Yeah, I guess for each degree of freedom, different Lyapunov stability approaches can be used. Actually, it's been used for several decades, Lyapunov approach itself. But for convex optimization problem, yes, there are still space to use, I think.
Thank you. Thank you. Participants? Dear participants, do you have any questions? Please ask. Thank you very much, sir.
Thank you. Thank you very much.
Now, Dr. Vaishnavi, please take care of the other next.
Sir, Dr. Lata will deliver vote of thanks. Ma'am, please.
Good evening. Am I audible, Vaishnavi?
Yes, ma'am. You're audible.
Good evening, everyone. It's been a pleasure being with all of you today. Thank you all for your patience listening. It's been an honor to be among such accomplished individuals and to be able to sum up various aspects being covered in today's session. I should state that today's topic discussed will add value to our research work on robotics. The focus of our webinar on role of deep learning, robots for automated application, robotic vision system, space robotics and artificial intelligence will build value and make us expertise in our fields. We'll learn how to apply knowledge properly and to put it into practice in our research work. Our heartfelt thanks for the concentrated contribution of all the speakers of today's session. Our thanks are due to our Honorable Vice Chancellor for his able support and direction. We would like to thank our beloved advisor who indeed mooted the idea of this webinar. We are greatly indebted to our Honorable Chairman, Ponnaya Ramajayam Institution, for his encouragement and guidance in organizing this webinar. Heartfelt thanks to our Dean Academic who backed us with constant support and lots of encouragement. extend my sincere thanks to the advisory committee members and the faculties for the enormous cooperation in the organization of the event. I thank all the participants for showing the interest in the program. At this point, I wish to express the interest and commitment of the team, Mr. Satyan, Mr. Amir, Professor Mohan Rajesh, Mr. Bala, Mr. Madan, in collaborating with all learned scholars in the successful preparation of this webinar. Thanks to our technical team members. Sincere thanks to all the speakers for their valuable contribution. Thank you one and all. I once again thank everyone for making this program a grand successful event. Thank you everyone. Thank you.
Thank you, Dr. Kumar. Thank you, Lata Madam.
Thank you, sir. Thank you so much, sir, for the excellent collaboration work what you did for us, sir. Technical team.
It's a pleasure.
Really wonderful, sir.
Jointly we did, sir. Jointly we did.
Yeah.
Yes, sir. Jointly, exactly, sir.
Yeah. It's a teamwork, sir.
Yes,
Fantastic job.
Thank you all. Yes.
Thank you, sir. Thank you, Ramayendra, sir.
Yeah, thank you very much, Satyan. All the best. Convey my regards to our team members.
Sure, definitely. Yeah. Okay. Thank you.
Yeah.
We learned how to work jointly, organize this kind of webinar. This is the first item.
We can still work together, do much better, wonderful jobs in future as well.
Miles to go before this. What Jawaharlal Nehru said, the same thing continues.
So hopefully we can see each other maybe at the Prest or at the CTD in the nearby future.
Yes.
Okay. Yeah. Thank you all, and go and take rest.
Thank you very much. Like one may be leg, the other may be giant. Like whether to giant, act like giant or leg. We will see.
Sure.
Satyan sir, thank you very much, sir. It's a very great support.
Thank you very much.
Thank you, Satyan
Really
sir.
excellent work done. Compliments to you.
No, sir. It's a
All the
teamwork.
very best.
Teamwork. Yeah. Good. Okay, sir. Your speech was very interesting and inspiring, Dr. Ramayendran, sir.
Thank you, sir.
The speech was very inspiring and interesting.
Satyan sir, thank you very much.
Okay.
Yeah, bye. Thank you, sir.
Thank you. Yeah. Bye.
Thank you, ma'am.
Okay.
Mr. Satyan.
Bye. Thank you all the moderators today.
Thank you.
Yeah, Lada, Vaishnavi, Yalini, all good. Done a good job. Yes.
Thank you, sir.
They did. Yes.
Thank you
Bye.
very much.
Take rest.
Okay,
Yeah, all
sir.
the best.
Okay, sir.
Thank you.
Bye.
Thank you, sir. Thank you. Bye, sir.